30 seconds and counting. 25 seconds and counting. We are still go. 20 seconds. Guidance alert. The guidance system now going internal. 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence start. 5, 4, 3, 2, 1.
Good afternoon, spaceflight fans. Obviously this is not the angry astronaut, this is Assistant again. I'm getting the live stream going for you all just so we can start to coalesce around the flyby of the moon that's happening later on. So the angry astronaut will be joining us on the countdown roughly in around 2 hours. So please feel free to get excited in the chat around the fly around and be here in a couple of hours time where the angry astronaut will join us and give us commentary during the fly around. Thanks very much.
Good morning from Mission Control Houston here in the Artemis Flight Control Room at NASA's Johnson Space Center. We are coming to you live with our 24/7 continuous coverage of the Artemis 2 mission. The crew is currently in their sleep period aboard the Orion spacecraft named Integrity. At a mission elapsed time of 4 days, 16 hours, and 1 minute, we are getting closer and closer to the moon than we are to Earth. We are currently about 244,000 miles and counting from Earth and about 19,000 miles away from the moon. There are a couple of milestones that I wish to share with the group this morning. First off, we will be passing our Apollo 13 distance record. That's the furthest humans have traveled away from Earth. That is scheduled to take place today at a mission elapsed time of 5 days, 30 minutes. Integrity will reach a max distance from Earth of 252,021 statute miles. This will surpass the Apollo 13 distance record by 3,366 statute miles. Integrity's currently on a trajectory that will carry it to the closest approach to the moon of 4,070 statute miles. That's the closest the vehicle will get to the moon. In addition to that, the spacecraft will be traveling at a speed of 60,863 miles relative to Earth, but that's just a little bit different because we are actually in the lunar sphere of influence, and the vehicle is being pulled by the moon's gravitational pull. So that velocity is actually reduced since Orion is in that sphere of influence. This means that Orion will be traveling only at 3,139 miles an hour relative to the moon. Once we complete the lunar flyby today, we will depart the lunar sphere of influence, which will take place tomorrow, and we will be captured by Earth's gravitational pull. Essentially, what that means is that as that pull gets stronger and stronger during our return to Earth, this will speed up the vehicle to make us swing around the moon and head back home and splash down off the coast of the Pacific. We'll continue to provide live updates for you here from Mission Control. The crew is scheduled to wake up from their sleep period in about 11 minutes and counting. For now, this is Mission Control Houston. This is Mission Control Houston here in the Artemis Flight Control Room. At a mission elapsed time of 4 days, 16 hours, and 7 minutes, I wanted to provide a quick update on the different milestones and times today that we will experience the lunar flyby. Today is Monday, April 6th, and we are in Houston, so that is in Central Daylight Time. At 12:56 p.m., Integrity will pass the Apollo 13 distance record by humans of 248,655 statute miles from Earth. At 1:45 p.m. Central Daylight Time, the lunar observation period will begin. The crew will complete some lunar observations before we enter the loss of signal period, which is scheduled for 5:44 p.m. Central Time. This is when Integrity begins its transit behind the moon. At 6:02 p.m., Integrity makes its closest approach to the moon at a distance of 4,070 miles. And at 6:07 p.m., Integrity reaches the farthest distance from Earth at a distance of 252,760 miles. That's about 4,105 miles farther than Apollo 13. At 6:25 p.m., we get the acquisition of signal, which essentially means that Integrity will emerge from behind the moon and begin its journey back to Earth. At 7:35 p.m., the solar eclipse period will begin. And at 8:20 p.m., the lunar observation period will end. Finally, at 8:32 p.m., the solar eclipse period will end. Now, all of this is happening after the crew entered the lunar sphere of influence in their pre-sleep period. Tomorrow, on Tuesday, April 7th, at 12:25 p.m. Central Daylight Time, Integrity will exit the lunar sphere of influence. This will happen when Integrity is at 41,072 miles from the moon. This is when Earth's gravitational pull will increase the velocity of the vehicle to speed up and re-enter Earth's atmosphere and splash down off the coast of the Pacific. For now, this is Mission Control Houston.
Hello again, folks. Just additional clarity for everybody. As I said before, the stream will start proper in a couple of hours, where the Angry Astronaut will join us and give us commentary on the fly around the moon. This stream was spun up just to give you guys a chance to watch the live mission coverage, if that's what you would have intended to do prior to the fly around, and get excited in the chat about what's about to happen. So stick with us for a couple of hours. Go away and do other things if you need to, because the big guy won't actually be here for a couple of hours, so enjoy.
We want to do a string swap to string 2 to confirm it's a good string. We're going to do that from the ground. We'll command the swap to string 2 and also uplink bailout etcdem commands to swap back to string 1 in case string 2 is loss of comm.
Okay, any crew action there? Is it all ground commanding? If so, go ahead and knock it out whenever it's waiting for you.
No correction, and we'll go ahead and knock that out from the ground. I'll probably give you a call back up with a voice check when we're done.
Outstanding, thanks. So before we lose you there, I'm surprised that at least on the DUs, our flight plan does not say anything about stowing our saliva science kit this morning. Confirm we want to leave that out in the cabin today?
Checking. Integrity Houston on 1 for saliva sample stowage.
Go.
Okay, Reed, the first set of saliva samples can be stowed per the stowage note. That's part of Victor's timelined activity at 1825. The second set of samples will be temp stowed out in the cabin.
Copy all, thanks.
This is Mission Control Houston in the Artemis Flight Control Room here at the Johnson Space Center. That was Artemis 2 Commander Reed Wiseman having a conversation with our capsule communicator, or Capcom, Amy Dill, about their pre-sleep activities. Just minutes ago, the wake-up call for the Artemis 2 crew aboard the Integrity spacecraft marked the start of Flight Day 6 activities. We are at a mission elapsed time of 4 days, 16 hours, and 26 minutes and counting. The song you heard for Flight Day 6 was Good Morning by Mandisa featuring Toby Mac, as well as a message from Apollo 8 and 13 astronaut Jim Lovell. Apollo astronaut Jim Lovell is profoundly important to today's lunar flyby, and hearing his enduring voice wake the crew reminds us of the gravity of this moment. The message the crew heard was recorded months before Jim passed away on August 7, 2025. We thank his family for the opportunity to share his words with the crew today. As the pilot of Apollo 8, Jim and his crewmates became the first to lift off on a Saturn V rocket and orbit the moon, proving that a lunar landing was within reach. During the mission, they captured the iconic Earthrise photo that inspired the world and offered a new perspective on humanity. As commander of Apollo 13, his steady leadership brought his crew safely back to Earth and demonstrated the quick thinking and innovation that have shaped NASA missions for more than 50 years. Apollo 13 also set the record for the farthest distance traveled by humans. A record Artemis 2 will break this afternoon at the start of its lunar flyby. We will remember Jim as a pioneering astronaut and great American. What a great message to kick off the day. This is Mission Control Houston.
Hi folks, just to update you again. As I said earlier, we're just counting down to the angry astronaut joining us for the crew fly around the moon. I've popped the countdown to that up on the screen, so if you see on the bottom right hand side there's a countdown there. The angry astronaut should be joining us in around an hour and a half from now, so feel free to go away and do what you need to do and check back for the fly around where the angry astronaut will join us and give us a commentary of that event.
Security Houston for post S-band string swap voice check.
Got you loud and clear on S-band 2.
Yep, string 2 is looking good, so we're going to remove those bailout commands.
Loud and clear on 1, looking good.
Yep, concur on Orion to Earth 1.
Okay, that's awesome. Everything looks good on board. I got so far as to take a single window shutter off, and the moon looks amazing. Aristarchus is the brightest thing that I see on the entire surface, and if I can pull myself away, I'm going to get to work in the post-sleep.
Sounds great, Reed. Thanks for that description. And we also wanted to let you know that you are go to perform the dock cam remove activity, no rush.
Copy that, thanks.
This is Mission Control. At a mission elapsed time of 4 days, 16 hours, 34 minutes, the crew has woken up, and we are about 245,000 miles and counting away from Earth and about 18,000 miles away from the moon. You can see these live views coming through right now, and the bright celestial object in front of us is the moon. Counting down to our lunar flyby, we are 7 hours, 53 minutes from the flyby conclusion. We are also 2 hours, 48 minutes and counting from our Apollo distance record. We will continue to bring you our live 24/7 continuous coverage of the Artemis 2 mission here from Mission Control. This is Mission Control Houston at a mission elapsed time of 4 days, 16 hours, 45 minutes, and counting. The Artemis 2 crew was just woken up. We are about 245,000 miles away from Earth and just over 17,000 miles away from the Moon. Today marks the commencement or beginning of Flight Day 6. Flight Day 6 is the day we do our lunar flyby. There are several science activities and priorities taking place, so let's tell you a little bit about them. The Artemis 2 lunar science program is guided by 10 prioritized science objectives informed by community-driven science documents and tailored to this mission's profile. The targets that they've selected for this mission maximize that high priority lunar science we just discussed, with a particular emphasis on far side regions and features relevant to future exploration. The lunar science team developed a 360-degree target list covering the entire moon, allowing the mission to remain flexible regardless of launch date or illumination conditions. That lunar targeting plan that you've heard about this morning, if you've been following along, has 30 targets based off of our launch and trajectory for this launch window. The targets include features tied to past robotic missions, current science priorities, and future exploration sites, including regions near the lunar South Pole that are being considered for future Artemis missions, and observing how surface features change as lighting evolves, allowing scientists to better understand color, albedo, texture, and morphology. These are key pieces of information for interpreting orbital and surface data. Now, the crew is going to be doing lunar observation where they will see the entire lunar disk. So from this higher vantage point, a little bit further away from the Apollo's lunar orbits, on average, astronauts can observe both poles and large-scale geologic features in a single view. Based on the lighting conditions, as Artemis 2 astronauts will become the first humans to directly observe certain far-side regions of the moon with unaided eyes. Human eyes and trained judgment remain among the most powerful scientific tools NASA can send to space. During this Artemis 2 mission, the crew has been able to quickly survey wide areas, adjust their focus in real time, and describe relationships between features, capabilities that cameras and instruments alone cannot replicate. The crew observed the same regions multiple times under changing lighting conditions during a single flyby, providing perspectives here on the ground that would take robotic missions years to accumulate. Audio descriptions and situational reports, you'll hear them called sit reps, as well as crew annotations, will provide essential context that enhances the value of scientific imagery. We will continue to provide live, continuous coverage of the Artemis 2 mission here from the Flight Control Room. For now, this is Mission Control Houston.
Hi there, just a quick update. As you all heard there, the crew have been woken up, getting ready for today's event. I'm fairly sure about 5 minutes ago we seen fluid dumps taking place. There was a lot of activity there on the camera. Around about an hour from now, the Angry Astronaut will be joining us to start the live event for the fly around. Bear with us.
Houston, integrity for image.
Good morning, Christina.
Good morning, Amy. Great to hear your voice. Great to be working with you all today. We wanted to share what we're seeing out the window. There's one picture of the moon as it looks right now on PCD3 and images for downlink.
Excellent, Christina. We will downlink that now, and we look forward to seeing it.
Houston Integrity for daily summary answer.
Houston's here.
Yes, ma'am. For the question about the quid, caution warning ID 1421 is showing suppressed, and we did not do that on board.
Copy. Thanks for the data.
This is Mission Control Houston coming to you live from the Artemis Flight Control Room here at the Johnson Space Center. We are coming to you live with 24/7 continuous coverage of the Artemis 2 mission. At a mission elapsed time of 4 days, 17 hours, and 5 minutes, the crew is currently undergoing their pre-sleep period. This is where they complete various activities such as hygiene and getting ready for the day, as well as their daily crew conference. The Orbit 3 team is getting ready to hand over to the Orbit 1 team of flight controllers. Currently, the Orbit 3 flight director in the room is Brandon Lloyd, with Capsule Communicator or Capcom Amy Dill. We are getting ready for our lunar flyby today, which is happening today, flight day 6. What I'm going to do is take a moment and explain some of the milestones that are coming up later on, and I will be doing this in Central Daylight Time. At 12:56 p.m., Integrity passes the Apollo 13 distance record by humans. This will be at 248,655 statute miles from Earth. At 1:45 p.m., the lunar observation period begins. Moving forward at 5:44 p.m. Central Daylight Time, we have a loss of signal as Integrity begins its transit behind the moon. Then at 6:02 p.m., Integrity will make its closest approach to the moon at a distance of 4,070 miles. At 6:07 p.m., Integrity reaches its farthest distance from Earth at a distance of 252,760 miles. That's about 4,105 miles farther than Apollo 13. At 6:25 p.m., we will have an acquisition of signal as Integrity emerges from behind the moon to begin its journey back to Earth. At 7:35 p.m., the solar eclipse period begins. At 8:20 p.m., the lunar observation period ends. And at 8:32 p.m., the solar eclipse period ends. Now, on flight day 5 in the crew's pre-sleep period, the Integrity crew or the Integrity spacecraft entered the lunar sphere of influence. This means that the moon's gravitational pull is now stronger than that of the Earth's. Integrity is currently 246,000 miles and counting away from the Earth and just 17,000 miles away from the moon. Once the lunar flyby concludes, tomorrow, Tuesday, April 7th, at 12:25 p.m. Central Time, Integrity will exit the lunar sphere of influence and will be about 41,072 miles away from the moon. Once Integrity does exit that lunar sphere of influence, the Earth's gravitational pull will be stronger than that of the moon's. This means that pull will help speed up the spacecraft as it begins to splash down off the coast of the Pacific. For now, this is Mission Control Houston.
Hi there folks, just another quick update. The Angry Astronaut's about half an hour out and he should be going live. I've seen a few people in the chat pointing out that the moon had moved, which I'd noticed as well. There was obviously some kind of course correction or adjustment prior to the fly around that was taking place for the moon to drastically shift in the way it did in the viewport. But yeah, interesting. Hope you're enjoying the stream, and we'll see you in about half an hour with the Angry Astronaut live. Cheers.
This is Mission Control Houston at a mission elapsed time of 4 days, 17 hours, 36 minutes and counting. We are coming to you live with our 24/7 continuous coverage. The Artemis II crew is currently in their pre-sleep period aboard the Orion spacecraft named Integrity. We are currently 246,000 miles away from Earth and just over 16,000 miles away from the Moon. We'll continue to follow operations along here in Mission Control. The Orbit 3 team has completed their handover and is handing things over to the Orbit 1 team. I'm Nilofer Ramji, and I'm handing things over to our Orbit 1 commentator, Leah Cheshire Mustachio, who will take us through the next several hours as we kick off Flight Day 6 and fly around the Moon with the Artemis II crew. For now, this is Mission Control Houston. This is Artemis Mission Control at MET 4 days, 17 hours, and 40 minutes. We are here live covering Orion and the Artemis II crews fly around the Moon. I'm NASA Public Affairs Officer Leah Cheshire Mustachio. We are currently 15,915 miles away from the Moon, and we have an exciting lunar tour set up for this historic day. From Reiner Gamma to the Oriental Basin, we are in Lunar Flyby. The Orbit 1 team is now on console, led by Flight Director Jeff Radigan. Capcom today will be Canadian Space Agency astronaut Jenny Gibbons, a backup for the Artemis II crew.
30 seconds and counting. 25 seconds and counting. We are still go. 20 seconds. Guidance alert. The guidance system now going internal. 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence start. 5, 4, 3, 2, 1.
Artemis 2. Very exciting thing indeed. And let me tell you, it's a big moment, obviously, a very, very big moment. Lots of firsts going on within about 20 minutes or so. The Orion capsule, the Artemis 2 mission, or the Artemis 2 capsule, will pass Apollo 13's record distance from the moon. When Apollo 13 made its free return trajectory around the moon after the mission was aborted in order to get them back as rapidly as possible. It went further away from Earth than any other Apollo mission had gone because the mission had to be changed. But this particular mission is going to be going even further. Okay, we just had a disconnection on the microphone. That was odd. Just 1 second here. Let me check. Just checking to see which. I just checked echo cancellation. Why is that? Hold on. I just changed that. I don't know why that went back to the original setting, but that has just been adjusted. 1 second. Let me check something else here. I'm checking the source. Okay, let's see. No, the microphone source is what it's supposed to be, and it's okay. We all right, guys? Is it improving? Once again, I appreciate it. Producer, can you make sure that the dialogue on the actual video is not in my ear? I don't know if there's a way that you can do that, just so that I don't have the echoing going on in my headset. Thank you very much. And thank you, Airborne Bob. Really, really appreciate your support. Thank you so much. So we're going to do everything we can. And I'll try to speak up a little bit. How about that? And we'll see what we can do. The audio is just, I don't know why we've continued to have audio issues on this channel. We'll just do the very best that we can with all of this. All right, folks. I don't know. It's just different. Some people saying 5x5, other people saying yes. I don't know. It's a curious thing, but in any event, the majority of this coverage is not going to be me as much as it's going to be us going past the moon. Again, the moment here that's coming up is going to be when NASA flies by the moon, or Artemis flies by the moon. It will, of course, fly behind the moon, and therefore the signal will be lost for a considerable period of time, less than an hour. All right. So once again, thank you. I appreciate that, producer. We've got some folks helping us out audio side at the moment. So in any event, doing the best we can here, but it sounds like things are working okay from feedback that I'm getting from the moderators. Okay, so again, we have this flyby taking place. Artemis will go behind the moon and out of signal range. There was talk of a Chinese satellite on the far side of the moon that theoretically could have provided communication. But in order to do that, they would have had to have linked that satellite up with the NASA Deep Space Network, which NASA and the Chinese Space Agency do not collaborate enough to do something like that, even if it were possible. So that being the case, we are going to lose communication for now. That's something that's going to be rectified in the future, something that was never rectified with Apollo, but it's going to be rectified as far as the Orion missions, or rather the Artemis missions, are concerned, because they're going to put up a network of communication satellites. It might be something similar to SpaceX Starlink. Also, the UK is working on their own lunar communication satellite system. So there's a variety of different different solutions that we're looking at here in order to provide communication around the entire moon, rather than having these communications dropouts on the far side of the moon. So as you can see, the moon is not as big is not as big in our perspective from this particular camera as we might think. But again, keep in mind, the moon is quite some distance away. The Artemis capsule is orbiting far further away. And bear with me for just one moment. Let me go ahead and Artemis tracker. I'm going to go ahead and pull up the tracker real quick, and I'll tell you exactly what the situation is, because Artemis is not going into LLO, low lunar orbit. So bear with me for a second here. Artemis is currently 6,727 miles. Let me go ahead and check that. Yeah, away from the moon currently. So over 6,700 miles still away from the moon, whereas low lunar orbit, where most of the Apollo missions were, that was more a few hundred kilometers off the surface of the moon, sometimes much closer than that. So this is a much, much greater distance away from the moon than most of the Apollo missions were. And again, the reason they're doing that, originally the idea was to put the Artemis missions into an orbit that was far further away from the moon than the Apollo missions were. A near rectilinear halo orbit was the original idea. And even though this particular capsule isn't in that precise orbit, the idea was to still have it at a considerable distance away from the moon, because that's how far away it was supposed to go. But interestingly enough, that is no longer the case now with the new changes that have been made to the Artemis missions. Airborne Bob, thank you so much for your support. I really appreciate these super chats. Thank you so much, folks. And feel free to ask any questions. I'm happy to answer any questions that you folks might have about what's going on. And just so you know, I can hear myself on the broadcast as well. So if there's any issues with low volume, all I can say is that it must be an internet issue, connectivity issue between myself and wherever you might be, because I can even hear myself on my own YouTube broadcast currently, and I don't hear that low volume. So for those of you experiencing that, I apologize, but we're just going to keep this going, because the vast majority of what we're going to be doing today isn't going to be my narration. We're going to be listening to what NASA has to say as Artemis makes its flyby, as Artemis prepares to pass behind the moon. We are currently about 11 minutes away from the moment that Artemis 2 will pass further away from Earth than any human mission has ever gone. So the 4 people on this capsule are at the edge right now. We're talking 11 minutes away from the moment to where they will be further away from Earth than any human beings have ever gone. And it will only be about 10 minutes or so after that that they will reach the apogee of the orbit and be the furthest away from Earth that they're going to go. But nevertheless, yeah, they're going to be going further away from Earth than any humans ever have. It's a huge, huge moment in that regard. Quite a milestone to accomplish as these 4 human beings prepare to set a record. And again, the reason for this is all of the Apollo missions traveled in low lunar orbit as they orbited the moon, and the LEM was dispatched down to the surface of the moon. They needed to be as close to the moon as possible. So the LEM, the lunar lander, had to consume the minimum amount of fuel necessary to descend down to the surface of the moon and then get back up to the capsule. They wanted to put as little stress, as few demands on the lunar lander as possible. However, for the Artemis missions, well, until very recently, the Artemis missions were going to be putting greater demands on the lunar lander and fewer demands on the Orion capsule. And the reason for that is there's going to be a space station, the Lunar Gateway space station, and a space station cannot be sitting in low lunar orbit. That's impossible. And the reason is that a low lunar orbit will decay rather quickly, which means you would need a lot of fuel to be constantly shipped to this space station in order to keep it in orbit. Very similar to what we have to do with the International Space Station. And it's far more difficult to send fuel all the way out to the moon to keep a space station in orbit than it is to keep the ISS in orbit. And so therefore they were going to put it into an orbit that was further out, the NRHO, near rectilinear halo orbit, which is a very stable orbit that requires very, very little fuel. The problem with that orbit, however, is that it was much further away from the lunar surface than any of the Apollo missions, meaning that any of the lunar lander designs, the Blue Moon or the Lunar Starship, were going to have a lot more fuel, a lot more capability than the LEM ever did. But fortunately, fortunately or unfortunately, depending on how you see it, Lunar Gateway is done. I don't think regardless of what NASA says, I don't think we're ever going to have a Lunar Gateway. And so now the objective is to deliver the Artemis capsule into a lower orbit and to build a base on the moon without a space station. Again, I think a space station would be very, very useful on lots of different levels, but what are you going to do? It's over with. I really don't see how they're going to be able to. I mean, at some point, maybe they'll build a new space station, but they've already taken a critical component of the Lunar Gateway, the PPE, the power and propulsion element. In other words, it provides the power for the space station and propulsion for the space station. That has been removed from the Lunar Gateway and repurposed for a nuclear powered mission out to Mars. How do you build a space station in the future if you've thrown away its power and propulsion element? So I don't see how they're going to have a space station anytime soon. Let's see here. Hold on. Thank you very much, Bob. Thank you. Oh boy, that's kind of you to say so. To ask for contributions, let me tell you, it makes a big difference. It's things like that made it possible for me to cover the launch, which was an incredible moment, and also makes it possible for me to travel to things like Space Symposium in Colorado Springs, Colorado, which I'll be doing in a week or so. I'm using some of the extra funds that I got for the Artemis to fund the Artemis trip to pay for Space Symposium, where there's lots of stuff going on there, including all the big players in spaceflight. So thanks very much. I appreciate that. Moon truck stop is a must. Yeah, I would say so, Baldwin. I think that it is a good idea to have a space station. China they intend to launch to the moon in 2030, to put human beings on the moon in 2030. So are we able to see it through the telescope? No, it's too small at this kind of distance to be visible with the telescope. Even spacecraft in orbit are difficult to see with telescopes. So I don't think that Orion can be seen with even the largest telescopes that we have at our disposal. Currently, the spacecraft is traveling at about 6,000 kilometers per hour. Speed 3,879 miles per hour. Again, it's slowing down. Keep in mind, it's reaching the end of its orbit. So that speed is going to keep dropping off and dropping off as it prepares to slingshot around the moon and come back. So you're not going to see a lot of velocity from this vehicle currently. No, we should see a live feed the whole time, and astronauts will be taking pictures as well. But we should see, as a matter of fact, they made mention. Yeah, right now they're showing a animated view, but I'm very confident that they're preparing. I believe they made mention that they're preparing their lunar view cameras, is what they said, for this moment. So I do believe that what they're doing now is prepping the cameras that are designed to give us the best possible view of the lunar surface. But again, keep in mind, none of these images are being processed. None of these images, a lot of post-production work is done on these things in order to show the proper features, the proper details that the astronauts are seeing with their eyes. It's very difficult to properly simulate what a person sees with their eyes with a camera. Anytime I point my cell phone camera, for example, at the moon, all I see is this bright light bulb. It's just producing far too much light. You have to have a camera that's specifically designed to see it properly, and also proper exposure times with those shots. So if you're seeing it live and in real time, you're seeing a light reflected off of a high albedo object. So that changes things. Okay, so right now, of course, we getting at least from my perspective anyway, getting a view from inside the Orion capsule as the astronauts were preparing for this live event. The capsule has about 60% more room than the Apollo capsule did. So it's a little bit more spacious, but then again, you've got 4 people instead of 3. So it's not a whole lot more room than what they had available. There have been people that have, how much force is put on the craft from the slingshot maneuver? Not a tremendous amount, because they're not passing that close to the moon, and also the moon's gravity is not that powerful. So they're not going to pick up a lot of speed from this particular maneuver. They'll pick up a little bit. But not a lot. That's not really what this is designed to do. It's just a free return trajectory. And again, the whole purpose of what they're trying to do is test the capabilities of the spacecraft, test life support, test the toilet has been the big problem of this mission so far. It's been the only big problem, and the only thing that's really been making news is the damn toilet. There's also some temperature issues at the beginning of the mission. Things were very cold inside the capsule for a while until they managed to rectify that problem. There's some very brief communication issues, but for the most part, yeah, this has been a pretty boring mission because it's been going so damn well. Again, this is absolutely what we want to see, but there isn't a whole lot of drama. So yeah, it's very interesting. And yeah, you can definitely stretch your legs. You definitely have some room. There's no question about that. All right, let's see here. What any other questions? Yes, re-entry, of course, is the big scary moment of this mission, the one that has generated the most controversy. The fact that the Orion heat shield did not endure the inferno of reentry very well. However, had there been astronauts on board Orion when it did reenter during Artemis 1, they would have been just fine. The heat shield sustained damage, more damage than they would have wanted, but it survived without too many serious problems. So the astronauts would have been fine had there been people on board. But nevertheless, they don't want to see that kind of damage to the heat shield. So they've changed the trajectory of the re-entry this time. That should put less punishment on the heat shield. So we'll see. Hopefully that will go well, but that has been one of the most controversial issues thus far. So in any event, what else do we have? Any other questions that folks might have, and I am happy to answer them. More than happy to answer them. We are getting close to the, oh boy, we're really close to the time for the, hey, actually, as of right now, in my understanding, as of right now, Orion has passed that milestone. Orion is now further away from Earth, and the 4 astronauts on board are further away from Earth than any human beings have ever been in history. They've passed that milestone. They have passed the Apollo 13 record, and here we are. Really fantastic. Very exciting indeed. One of the experiments that they're going to do is test the radiation shield capabilities, the radiation shelter. We don't know if they're going to get hit with any solar storms. We hope not, but at the same time, we definitely need an opportunity to test this heat or this radiation shelter at some point. But even if we don't do that, they are going to go through the procedure of getting the radiation shelter set up. They assemble as much material as they can, especially water. The water is some of the most valuable stuff that they can put between them, or liquids of any kind that they can put between them and radiation. And they hunker down inside this radiation shelter for a few hours to see how well they can hold up under those circumstances. They're supposed to set up all of the material that provides them with shielding in a 10-minute time frame is what they're supposed to do it in. So they're going to go through a radiation emergency drill. That's going to be one thing that they're going to do. In addition, of course, they've been doing wastewater dump tests with the toilet, and those have not been going all that well. There's been a lot of ice, as near as NASA can tell anyway, ice that's been creating a lot of problems in the plumbing. It's been clogging things up. And by the way, for everybody who keeps seeing tiny little fragments, these bright fragments that look like UFOs, all that is ice crystals escaping from the toilet, and it's happening all the time. Even though they're supposed to do wastewater dumps at specific times, because it hasn't been draining properly, you're going to have this stuff. You're going to have this stuff escaping bit by bit. And incidentally, we're just a couple of minutes. Go ahead. Okay, so we have 3 minutes, folks. 3 minutes before NASA will be going live. And the moment that NASA goes live, I'll be shutting up, of course. Yeah, we've got some exciting stuff coming up as hopefully Artemis is able to show us some interesting things about the moon, about the surface of the moon. As they make this pass, hopefully we'll be seeing some things that we don't often see because they're passing behind the moon, behind the far side or the dark side of the moon, whatever you want to call it. We'll be seeing craters that you don't Obviously, we never get to see from Earth because the moon is tidally locked. It keeps one side of it, one face of the moon, always faces Earth all the time, and that never changes. So that being the case, humans don't get to see this side of the moon very often. Thank you, Airborne Bob. Thank you. Boy, Airborne Bob keeps those super chats coming. You are so generous. I really appreciate it, my man. Thank you very much indeed. And by the way, Christina Koch has been the space plumber, apparently, during this entire process. Yes, that's a good point, Mike. They must enter their spacesuits on their own without assistance. They also wear these radiation vests that protect their vital organs in the torso. So they're doing their best to try to get some protection against the radiation, because that's going to have to be done. All right, so NASA's going live here real quickly. Producer, go ahead and bring NASA on if they are indeed live. Of course, we have the splash screen, the live event starting soon screen, but they should be live here real soon. So give us just a moment, folks. NASA should be live in 1 minute or so. Once again, any music, we're going to have to mute that out.
Right now, the Artemis 2 crew and Mission Control are preparing to support today's lunar flyby, the first time we've sent humans around the moon in over 50 years.
Integrity, you can use the OEs and your HHP camera for the milestone words at the Apollo 13 record distance.
You'll notice that we pause every time we hear communications to and from the crew. They are the stars for today. This afternoon, the crew will have their closest approach of the moon and will surpass the record. That record just mentioned of the furthest humans have ever flown, set by the Apollo 13 astronauts in 1970. You're looking at a live view inside the Orion spacecraft and at our Artemis 2 crew members. They have just completed their post-sleep period, during which they conduct any hygiene and cabin setup for the day. They also had a chance to eat breakfast before we got into our daily planning conference. The flight control team here in Mission Control Houston collecting information from all consoles around the room that we could relay up to the crew ahead of this monumental day. As you can see on your right, NASA astronaut Christina Cook taking a video of NASA astronaut Victor Glover. We expect to have great views of the crew throughout the day, as well as, of course, the moon.
We expect to surpass that Apollo distance record in 55 minutes and 50 seconds. We are now looking live at a camera mounted on one of the spacecraft's solar arrays, pointed to our lunar neighbor. We are currently just
doing our best, folks, but there's only so much we can affect NASA's volume.
247,672 miles away from planet Earth.
Houston, integrity for AGA.
Ready to copy.
Carbon dioxide 2.3, oxygen, which has the alarm, 26.3, 73.1 degrees, 10.3 psi. And one follow-on question. We understand milestone words will be directly following the conference. Will that take the place of the PAO event, or will the PAO event still take place per the timeline?
Good question, Christina. The milestone words that we exchange at the record distance at the end of the conference will take the place of the PAO timelined activity. So that'll be our moment to talk about this occasion, and after that there will be no more expected PAO words, and you can get straight into your flyby. Copy all AGA.
Okay, thank you. And final clarification, even though it's taking the place of it, it will all just be on OE1 with HHP camera, no additional video. Is that right?
Affirm.
Okay, thank you. Yep, some of us had already heard that. Sorry about the second question. We appreciate it. Talk to you soon.
No problem.
Yeah, folks,
Those communications between NASA astronaut Christina Cook and Canadian Space Agency astronaut and today's Capcom, or capsule communicator, the one person here speaking with the crew right now, that is Jenny Gibbons. She is an Artemis 2 backup crew member here in Mission Control Houston. We are now 4 days, 18 hours, and 30 minutes into the flight of Orion for Artemis 2. The Artemis 2 crew inside Orion lifted off atop the Space Launch System rocket on Wednesday, April 1st from NASA's Kennedy Space Center in Florida. Those 4 crew members are the first to live and work inside the Orion spacecraft, which they have named Integrity, and have been busy conducting meticulously timelined events. It was a beautiful ascent from Kennedy Space Center.
Yeah, I just checked the NASA stream directly. The volume's low there too.
The Artemis 2 pilot manually flew Orion after having just detached from the interim cryogenic propulsion stage as if they intended to dock. This was practice for future Artemis missions, during which astronauts in Orion will dock with the lunar lander that will take them to the surface of the moon. About 24 hours after launch, 25 hours actually, Orion then conducted TLI, the translunar injection burn. This 5-minute, 50-second burn committed Orion to departing high Earth orbit and set us up for today's flyby. That translunar injection burn also served as the spacecraft's deorbit burn. It slingshots Orion around the moon and sends the crew on a free return trajectory, with splashdown approximately 7:07 p.m. Central on Friday, April 10th. Last night on Flight Day 5, the crew entered the lunar sphere of influence, the point at which the pull of the moon's gravity will become stronger than the pull of Earth's. We've also been getting some great views inside the cabin of the crew members living daily life, from working out to eating, taking photos, and making memories together. But they've also been taking some beautiful views of our home planet and of the moon, and we expect many, many more of those following today's activities.
Yeah, that ship does look a little bit more spacious.
These live views back inside the cabin of Orion, but before we get into flyby, let's take a minute to get reacquainted with our crew. Reed Wiseman is the Artemis II commander and a Baltimore native. He's been in space once before.
I think there was going to be some families heading into the viewing room today. If they end up showing up, could you just give us a heads up when they're there so we can just wave to them on the camera?
Absolutely.
And that was the voice of Reed Wiseman. He has been in space once before as a flight engineer for...
And if they don't come, you could just lie to us and tell us that they're there. That'd be great, thanks.
We'll keep that in mind, too.
And
I'm sure they'll be here.
Wiseman also has a great sense of humor. He was aboard the International Space Station from May through November 2014 as part of Expedition 41. This was a 165-day mission during which he and his crewmates completed more than 300 science experiments in areas like human physiology, medicine, science, earth science, and astrophysics. They set a milestone for station science by completing a record 82 research hours in a single week. He also served as chief of NASA's astronaut office from December 2020 to November 2022, and here on Earth he has 2 daughters. The Artemis II pilot is Victor Glover, selected as an astronaut in 2013, when at the time he was serving as a legislative fellow in the United States Senate. His first trip to space was in November 2020, when he launched as a pilot of NASA's SpaceX Crew 1 mission. That was the first operational mission of NASA's Commercial Crew program, which resumed launching American rockets from American soil to the International Space Station since the end of the shuttle program. Victor is a U.S. Navy captain and naval aviator who served as a test pilot, racking up more than 3,500 flight hours in more than 40 different aircraft. He also became the first person to pilot Orion the other day when we saw the Prox Ops demonstration shortly after launch. He and his wife have 4 children. Mission Specialist Christina Cook is a native of Grand Rapids, Michigan. She was selected to the Astronaut Corps in 2013, the same class as Victor Glover. She served as flight engineer on the International Space Station from March 2019 to February 2020. During that time, Cook set a record for the longest single spaceflight by a woman with a total of 328 consecutive days in space. She also participated in the first ever all-female spacewalk with her friend and colleague, Jessica Meir, now living and working aboard the International Space Station yet again. Before becoming an astronaut, Christina helped build space science instruments and led scientific fieldwork in some of the most remote environments on the planet. Her hobbies include surfing, rock climbing, community service, yoga, travel, and photography, and she is certainly getting a chance to do that. First-time flyer, Canadian Space Agency astronaut Jeremy Hansen is flying to the moon as a mission specialist on the Artemis II mission. The London, Ontario native was selected as an astronaut in 2009. After that, he worked as Capcom at NASA's Mission Control Center here in Houston. Capcom stands for Capsule Communicator and is the single direct voice communicating with the astronauts in space. He also participated in training exercises like living on the ocean floor off the coast of Florida to simulate deep space exploration for 7 days. In 2017, he became the first Canadian to lead a NASA astronaut class.
Thank you, iPlay. Thank you so much.
Climbing and mountain biking. And he and his wife have 3 children.
They are in the process of the flyby right now, actually. But they will reach the apogee of the orbit in less than an hour. But of course, they'll be behind the moon at that point, so we won't be able to, there will be no communication with them, nor will we see any video from out there. Let's go ahead and bring NASA back. Okay. So, all right. So we got nothing from NASA currently. Oh, there we go.
Inside Orion. As they prepare for
So they're dimming the lights so we'll be able to see better, perhaps.
To allow for proper positioning as they move about to and from the windows, taking photos of the moon. Dimming the lights also helps prevent reflections from inside Orion onto the windows. Ahead of this lunar flyby, let's dive in and explain what you can expect over the next several hours. The crew has about 6 hours allotted to make observations about the moon. Throughout the flyby, their activities have been precisely timelined. There are five blocks of time during which the crew will be observing the moon from Orion's windows. At any time, 2 members will be at the windows working in a pair. One crew member will be taking photos from window 2 with a blue shroud over the window. This can help prevent that glare or reflection from inside Orion. They have an 80 to 400 millimeter zoom lens to use. The other astronaut will be in window 3 using their portable computing device, you'll hear that referred to as PCD, to make annotations. Both of these crew members will make audio recordings of what they are seeing, and they'll wear headsets connected to those PCDs. Those audio recordings will be sent to the science team at a later date. We will not hear them live. The 2 crew members at the windows will swap roles and positions halfway through their timelined block. The other 2 crew members who won't be at the windows at that time will be serving in the background as support. One will be conducting the science sit reps, or situation reports. This is what we will hear live from the crew. They'll be calling down a few times each hour to discuss what they are observing. Those situation reports include how the crew is positioned, any missed targets, or anything unexpected they saw, lunar target descriptions, any hardware issues, and of course, their emotions and reactions as they fly by the moon. The other support crew member will take pictures of the astronauts at the windows and serve as camera support, providing new SD cards when needed. There's a 15-minute time frame between each observation block during which the 2 support members switch places with the crew making observations. Two views, both coming from Orion. There on the left, the inside of the spacecraft, and on the right, a view of our moon, the destination for today. During the lunar flyby today, Orion will provide astronauts with a full disk view of the lunar surface. They'll have a higher vantage point, much farther than Apollo's lunar orbits on average. And these astronauts can observe both holes and large-scale geologic features in a single view. And due to our April 1st launch date and current illumination conditions, the Artemis 2 astronauts have become the first humans to directly observe certain far-side regions of the moon with unaided eyes.
It's true, Mike, what you just said. You get a better opportunity to see certain parts of the lunar far side that generally, well, for one thing, there'll be parts that humans have never seen before because the Apollo orbits didn't allow for it. It's one of the reasons why they're as far away as they are, is they can get a real-time view of the entire far side of the moon and photograph all of it in great detail. But yes, they are significantly further away than any Apollo mission aside from Apollo 13. But that's a wide angle lens that you're looking at there. So they're using much better equipment for all the photographs they're going to be taking today. We're going to be seeing a lot of really detailed stuff. I hope we get to see some of it live. It'd be nice if we got to see some of the close-up stuff live as they make their way closer to the point to where we'll be losing communication with them. But once they slide behind the moon, of course, we won't be able to hear from them at all. There'll be no data stream, nothing like that. So a lot of the best views that we're going to get are going to be coming after the fact rather than right now.
How do I, is it all?
But everything we're seeing right now is definitely live. Well, a couple seconds delay. Yes, very good point. The Lunar Reconnaissance Orbiter has given us lots of really good views of the moon. There's no question about that. The LRO has showed a lot of different things, but now humans will actually get to see what the LRO sees. Also, they'll be using different equipment than the LRO has to do some of the photography. So it should be very interesting.
We are now 36 minutes until we see the Integrity crew pass the Apollo 13 distance record. And joining me on console, I have Julianne Gross, the Artemis curation lead. Thanks for joining me today.
Thanks for having me. I'm very excited to be here.
We're very excited to have you. So can you tell me about your role as Artemis curation lead and what that entails?
Yeah, so for the overall Artemis
Yeah,
campaign,
sorry guys,
Artemis,
I missed that
Lunar
one
Sample Curation Lead.
moment.
That means I'm helping
I got the
helping NASA
hour
to
wrong for
return
the
next
record.
set of lunar
Sorry
samples
about that.
from the lunar surface. And for Artemis 2 specifically, I'm one of the science theme leads. And
yes,
specifically,
Susie,
I'm
they did go through
responsible
the
as a
Van
voice
Allen belt.
for impacts, poles, and landing sites.
Fascinating. So what helped us select the targets that the crew is going to be photographing today?
So we had a plan coming in where we basically made a list of all the available targets during the April launch window, because before you launch, we wouldn't exactly be sure which targets would be visible. And so once we launched, we then were able to cut down on that list and prioritize our targets. And the 5 theme leads came together and really discussed and talked through which which targets we could then see and prioritize. And so that made it into our plan. We worked then with timeline to make sure that all the targets are visible. Some targets are time dependent, like Earthset or Earthrise, and some targets will rotate out of view when Integrity starts going around the moon. And so we put these in early so that the crew has a chance to describe those to us.
Fascinating. I cannot wait to hear what they have
Lunar
to say.
Comms blackout is
We
at
just heard them say that their
1:44
long lens is
p.m., I
configured.
believe,
That's very
Airborne Bob.
exciting. And for us, when we look at the moon from
1:44
Earth,
Eastern.
what features are we seeing that the crew will also fly by today?
Yeah, so I really hope that people on Earth who are in nighttime will look up into the moon tonight. The features that the crew will see that we can also currently see is Aristarchus Plateau. Grimaldi is another feature. They're going to be sort of on our limb. And then Oceanus Procellarum, that really dark, large area on the near side that we can see. The crew is going to see that in the beginning. The more they fly around, the less of that they will see. So those are targets we will hear them describe early on in the flyby.
Fascinating. Well, and the crew has been training for years for this day. And so we're going to hear them make a lot of calls about what they are seeing on the moon. And they're going to use a lot of interesting terms that I myself need some brushing up on. So could you walk us through a few of the things that we'll hear them use to describe the moon, like albedo, exosphere, ejecta, just some of those major terms we expect to hear from the crew?
Yeah, of course. Albedo is basically a term of a reflectiveness of the surface. And so high albedo usually for the moon means bright areas, and low albedo means like darker areas. And so when you look into the night sky, you can see the high albedo areas are the white parts and the low albedo ones are the darker areas. Ejecta is when you have an impact and it ejects or throws out material that then ends up on the surface, and you can see that as sort of rays or ray systems. So you might hear them describe, oh, I can see Ohm, for example, with its rays. It has an isometric rays coming out, and so we're excited to hear them describe that. You might hopefully hear stuff about color or color hues, and so if they can see any changes in those color hues from like white to gray to maybe brownish, we're excited to hear about that. Exosphere is the almost no existing atmosphere of the moon. It's barely there. But there is dust on the lunar surface that can get lofted up through electrostatic forces. And when the sun goes behind the moon, it can scatter forward on those dust particles and sort of like create a little glow on the horizon. And so we're really excited to see if the crew can actually see that.
This is so exciting. Thank you so much for walking through all of that with us. Julian Gross, Artemis Curation Lead, we really appreciate you joining us here today, and good luck to your team.
Thank you. I'm really excited to be here.
We are now MET 4 days, 18 hours, and 49 minutes into the flight of Orion. This view of the moon from the Orion spacecraft as we get closer and closer.
Getting a better view of the moon. Bill, thank you so much for the $2, $2 Australian. Thanks so much. These super chats make a big difference, folks. So I really appreciate it. No matter how big it is, it all makes a big difference, folks. Okay. The distance from the moon. Let's see here. Let me check that real quick because Apogee Artemis 2. About roughly 406,000 to 773 to 406,780 kilometers from Earth. In terms of how far that is from the moon, which is further than any humans have ever gone, and 6,550 kilometers away from the moon.
We're live here in Artemis Mission Control at Johnson Space Center in Houston, Texas, just about 32 minutes away until the crew surpasses the record set by Apollo 13 as the farthest astronauts to ever leave Earth. This view coming from a camera mounted on the tip of one of Orion's 4 solar arrays. Each array has a camera on its tip, and so we anticipate getting views throughout the lunar flyby. Of course, except during the point of loss of signal when the spacecraft flies behind the moon. Inside the cabin, the crew are configuring the inside of Orion for today's flyby, making sure they have everything just where they want it to help them take the pictures that they are aiming for the science team here on the ground. Coming up in just a few minutes, we will have a pre-lunar flyby conference. During that Lunar Flyby Science Crew Conference, our science officer here on console, Kelsey Young, will be speaking directly with the crew members about their targets, about their goals for today, what they expect to see, and what we are hoping to hear from them.
And yeah, that is a good point that's being made here. It's waxing right now. It's a waxing gibbous moon currently, 3 days from going full, meaning that the vast majority of the dark side of the moon is actually dark because the vast majority of the far side of the moon is facing away from Earth. And the vast majority of the moon that's lit is facing the Earth. So what they do get to see of the far side is going to be limited.
At 1:56 p.m. Eastern Time, the crew will pass the distance from Earth record set by Apollo 13 in 1970. At 2:45 p.m., lunar flyby officially begins. The crew will have that time on their schedules to begin photographing and providing audio recordings of what they are seeing on the moon. At 7:02 p.m., Orion will make its closest approach to the moon, approximately 4,070 miles away. Of course, all of these numbers are going to have to be confirmed following the flyby. These are estimates, and we are working with orbital mechanics. At 7:07 p.m., Orion reaches its maximum distance from Earth, approximately 252,760 miles away from us all. At 8:35 p.m., the spacecraft will enter a solar eclipse. The crew will become the first to see a solar eclipse from the moon.
Very interesting. So, Gerard, thank you so much for the €4. Really, really appreciate it. Thank you very much.
Ahead of the official beginning of flyby today, Kelsey Young, Artemis Science Flight Operations Lead, will be conducting a pre-lunar flyby crew conference. She will give information on camera setup, remind the crew of their intended targets, answer questions from the astronauts, and more. Young will help the crew set their targeting timeline, which counts down the time they have to image each target and what they'll be capturing next. She'll also remind them that the ground team will be calling for science sit reps, also known as situation reports. Those are essentially call downs to report what they've been observing. They'll continue to do this even through their LOS, their loss of signal, as those communications will come down later on after they reconnect with us on Earth.
Thank you, Major Mucho. I appreciate it. The internal temperature of Orion has been varying, actually. It started out quite cold. And they had to do a lot of work to get it up to a more tolerable temperature level. One thing is that it was cold to begin with, and then all of the fans blowing constantly created almost kind of a wind chill inside
they have dimmed the cabin lights to allow
the capsule.
better visibility outside of the windows and fewer reflections. Now, 28 minutes until they become the humans to travel farthest from our planet.
Thank you, Bill Alexander. Really appreciate the $2 Australian. Thank you very much.
Houston Integrity, we are ready for the conference on your call.
Here we go.
Houston is ready for the conference, passing you over to science. Good morning, crew. This is Science. We couldn't be more excited for a full day of lunar and planetary observations today, the first one in over 54 years. How do you hear me?
We hear you loud and clear, and Kelsey, you just got to know you're pulling us away from the moon right now, so let's go.
Message received. I will keep it tight here. I did just want to start with a thank you on behalf of the Lunar Science team and the entire lunar and planetary science community, of which you are absolutely a part, for what you've already done in this mission and what you're going to do today to inspire the next generation of scientists. I have to say Moonjoy is the new term that's already become our team's new motto, so thanks for that. In this conference, we'll cover hardware and config reminders, and then I'll just briefly, as you said, cover today's science plan. I'm assuming you already have your LTPs up. Confirm that, and I'll jump quickly into the cabin config reminders.
Mike, you made a good point here. Because there's most of the far side of the moon is going to be dark, and they'll be hidden from the sun as they pass behind it. There's going to be no light, meaning they'll be able to get some incredible shots of space, of the stars, perhaps some of the best shots ever.
Copy that. That was going to be one of my questions for you, and I'll ask a question back. Is that the config that you and Christina plan to carry throughout the day for PCD use?
Midnight, Orion is 60% bigger than Apollo.
Negative, Kelsey. Our plan for PCD use is we have run the power cables to Windows 2 and 3, and we are going to leave one PCD. The yellow PCD will be in window 2, and the green PCD will be in window 3, and we will do that the whole day, and then the red PCD will be a rover.
Understood. Super helpful.
Yeah, there could be a discovery. They might get a photo of something on the lunar surface that we've never seen before.
So we can keep track of who's
That's possible, Mojo.
And then given that you have 3 PCDs instead of 4 for the data transfer at the end of the day, recommend making a new subdirectory entitled for science for your own photos or with your initials, that we can keep track of which pictures came from which flashcards.
Oh, they just made it real black inside the capsule. They have blacked out in there again, trying to get
this view.
So, Kelsey, I just want to here's what we're doing. We have community cards in all cameras on board, and then when each astronaut approaches their camera, the intent is they will put their card into that camera for photos and then put the community card back in at the end of the session. But just know it is harder to manage cards than we thought, and we don't want to miss science, so it might end up a bit more disorganized.
Understood. Thanks for that, SA. Just read the flashcard numbers down when you get a chance, and we'll follow your lead on the best thing to do operationally.
Thanks so much, Bald Dolbrun, or forget, I'm sorry.
Windows.
Thank you so much.
So
That's your
window
first super
characterization
chat.
VFTO you
I'm
guys
honored.
did a few
Thank
days
you.
ago, confirm that window 2 is ideal for imaging, so no change to config of photographer in window 2, observer in window 3, and science at reps in window 1. Coming up on the handover. Be back.
Hang on, Kelsey. The way we have it configured, tell us if this is going to be wrong. Window 2 is the long lens with a shroud. Window.
As you heard, science officer called to the crew. We are now in a handover time period. We will regain communications with the crew very shortly. These are tracked.
All right.
And we are currently on the Deep Space Network. This is the first
So they're
time
handing
used
off
the
to a
Deep Space
different
Network in over 50
communications
years, given that we
dish
currently use
in the
tracking
NASA
data
Deep
relay
Space
satellite
Network.
systems
So
in
we're
the,
losing
for the
communication
International
briefly.
Space Station. This view from Artemis Mission Control on the right is Kelsey Young. That's who you hear speaking with the crew. Young is the Artemis Science Flight Operations Lead, and we also look forward to speaking with her here today.
So photos in infrared, UV, and star vision. Thank you, Mike, for that information. So even with really low light, they'll be able to get some interesting views of the lunar surface. And again, I really hope we get to see some space views if they turn it around and look at just how amazing the Milky Way galaxy and other features are going to be when the sun is completely hidden, and also there's no reflected sunlight coming from the lunar surface either.
The Apollo record. We are in a handover of satellites with the crew aboard Orion.
T-shirt shroud for the Z9 and solar, and then window 3 will be for visual observations, and window 4 is for floater.
And thanks, Integrity, for that. Reed, we had a handover during that time, so I'm going to have to ask you to give that read back on window orientation for the crew again.
Okay, we are happy to change it, but the way we have it configured right now is window 1 has a T-shirt shroud for the Z9 for solar. Window 2 has the shroud for the long lens for both lunar and solar. Window 3 is for visual observations. Window 4 is for floater. And then the docking hatch window has had a great view, so we've done a lot of mapping through that as well.
All right, copy all, Reed. A note just on the window 1 T-shirt shroud that you can remove that for the lunar observation block if you want to, if you want that extra view for another floater, but defer to you guys on that. You are go to use the full 400 millimeter zoom on the long lens, but where possible, try to keep the end of the lens flush with the window to prevent imaging through the multiple window panes at an angle. And if you have to take an image at an angle, recommend you limit the max focal length to 200 millimeters or simply acquire the images at multiple focal lengths. Last imaging update as a result of the DFTO is that if you can take the images out of the left side of window 2 where possible, that is the best half the window. Understand that might not be possible with the shroud. Any other imaging questions from you?
Okay, copy that.
Okay, last couple reminders. Don't forget the ability to take the WAV files to tag imagery that you are wanting to follow up on using the FN3 button on your camera. And then a couple quick notes on your LTP. We have refined your precise flyby timing since generating the LTP. Optimus has the correct timing for the LOS and AOS, but the LTP identifiers for LOS and AOS are roughly 2 minutes later than they will be in reality. Final LTP timing update is that the green line on your LTP should start automatically 45 minutes before the flyby. If it doesn't appear, let me know and I'll have troubleshooting steps for you. Last updates are on the Eclipse, so only for that last hour today. Of course, remember if the sun is in view to use your Eclipse glasses. And reminder that we will have a few activities for you prior to the eclipse to reconfigure all 3 cameras for corona and deep sky observations. These activities, some of which will occur during the forward link LOS, so we wanted to flag it for you now. Any questions before I cover the last 2 reminders?
No, we have no questions on that.
Last couple Eclipse reminders, the sunset period and the first roughly 23 minutes of the eclipse will fall during that forward link LOS, but we'll still have a return link and we're still looking forward to your science sit reps and observations during that time. And I do have a reminder for you on your preferred starting config for the eclipse in terms of role responsibility. Let me know if you want me to read that up or if you guys have that in your minds already. And if no other questions on config, I'll give you a few science-focused reminders.
Give us a quick high level, but we see it in Optimus, and I think we got it squared away. But give us your quick Kelsey high level.
Okay. A couple changes from the first LTP you studied is that Glushko is the only feature that the same pair will view twice. That's Reed and Jeremy. That's why that's the only target you see that is marked as 1 of 1 and 2 of 2 and 2 of 2. So Ohm and Oriental are in there twice, but they're by different pairs, which is why you don't see them marked accordingly. A note from feedback on your observations so far over the last couple days, a reminder that if you note structure and texture as well as color and albedo, please note any correlation between the 2, and also a reminder that negative observations are still valuable science. So a lack of color or a lack of structure associated with color is also valuable. A reminder also that your observations so far indicate it will likely take some time for your eyes to adjust. We especially heard that around your terminator observations and your color observations. So reminder to know that your eye adaptation is going to kind of come in throughout your shift, and let us know when you start to see that nuance. Last reminder is around Earthset and Earthrise. When you're viewing us back here at home, you'll be looking directly at Asia, Africa, and Oceania. So I'm sure people watching from those places here on Earth will want to give you all a wave as you take their picture. Any other questions for me?
Kelsey, hey, when you're talking window 2 left and right side, just can you say towards window 1 or towards window 3, and then we'll know that we are talking the same language?
Absolutely. So I mean that the side of window 2 closest to window 3 is preferred for imaging.
Okay, the side is preferred for recording. Stand by, we'll talk to the crew.
Again, we are in our pre-lunar flyby science conference with Kelsey Young. Kelsey Young is the Artemis Science Flight Operations Lead, speaking with the crew aboard Orion. They've been training for this moment for years, and this is their last opportunity to get some further pointers and information.
Thanks so much for the super chat.
What window does the science team think will have the best view? Is it window 1 or window 4?
The only time we're strongly recommending use of the window shroud.
The window, the t-shirt window shroud for the Eclipse viewing. Which window is primary for Z9?
Window 1.
Okay, awesome. So we have got that all set up. And just to be 100% sure, window 1 is the most port window by the food warmer. Window 2 is right in front of seat 1. Window 3 is right in front of seat 2. And window 4 is on the starboard side by the side hatch. Do you agree with all that?
We agree on the ground. Good read back.
Okay, that's awesome. Kelsey, we're going to close with happy words. It's just incredible. I wish you were up here to see all the smiling faces, to hear all these terminologies being thrown around, and we are just fired up to get started on this day. Let me pass the mic around if anybody has anything to add.
Kelsey, it's so great to hear your voice on the loops. I just want to channel everything that you guys are probably feeling right through my eyes and heart. It is awesome to see the side of the moon. You guys made us excited for this day, and we couldn't appreciate it anymore. And we are ready to hopefully deliver on all the awesome training you guys have provided.
I'll just add, Kelsey, it is blowing my mind what you can see with the naked eye on the moon right now. It's just unbelievable.
Kelsey, and to the whole Lunar Science team, all of you, all the work you put into this, we're just grateful. Can't wait to get going. And thank you for the tipper, for Carol Crater, and for Integrity. We can see them, and we've imaged them, and can even see with the naked eye. Quite impressive. Thank you so much.
Beautiful words, you guys. Thanks so much. And I got video of the science team right now, and they are all absolutely buzzing. Looking forward to today.
Okay, we're heading into the timeline. Cheers, guys.
Of the pre-lunar flyby science conference with Dr. Kelsey Young. Young has served as the Artemis Science Flight Operations Lead, getting the crew ready. And we're live in Artemis Mission Control in Houston, but we are not the only room monitoring today's flyby. As you heard Young mention, in this same building and just down the hall, a multidisciplinary lunar science team supports the Artemis II crew in real time, including experts in lunar geology, impact cratering, volcanism, polar science, imaging, and visualization. There are two integrated facilities, and the first is the SIR, which is what you have right here. That's the Science Evaluation Room. They are embedded within Mission Control to provide science input during live operations like what we see today. Additionally, and not pictured, we have the Science Mission Operations Room, a back room that processes data, evaluates imagery, and supports rapid analysis. Our science officer on console in Mission Control Houston serves as the primary interface between the science team and the flight controllers, ensuring science priorities are represented during mission execution. Again, today, that's Dr. Kelsey Young, who will be speaking with the crew during the time they're behind the moon. We will be speaking with her once the crew is behind the moon and out of communication with Earth.
Thank you, Gerard. Thank you so much for the €3.
Closest to the camera.
Boycott, thank you very much. Appreciate your support.
To her left, NASA astronaut Reed Wiseman. To his left, Canadian Space Agency astronaut Jeremy Hansen. And all the way in the back, NASA astronaut Victor Glover, our Artemis II crew.
Okay, not sure why they brought the lights back up again. Maybe just to test what they were supposed to do before they actually do it. I don't know. Anyway, is everything with NASA, there's procedures on top of procedures. It takes forever to get anything done. Ben Solo, thank you for the €6. Big J, thank you for the $5. Boy, you guys are great. Thank you, thank you, thank you.
507 miles away from Earth.
These super chats make a big difference, folks. Thank you so much.
You may also hear the Orion spacecraft referred to today as Integrity. This was named by the Artemis II crew. It is
Integrity crew, we have Reed's family in the viewing gallery. You're welcome to say hello.
Well, whether you're being serious or you're kidding around, that is awesome to hear. Thanks, Jenny. And hello to Ellie and Katie. I don't know who else is there, but it's great to know that you're in mission control right now, following along. We are having a blast up here, and the view of the moon is absolutely amazing.
I'm seeing a lot of hearts come out of the viewing gallery and even more smiles. Thanks, Reed.
Ian, thank you so much for your generous support. Thanks for all these super chats coming across today. Big help. Thank you so much.
Copy heart, copy bracelet.
that call from Capcom Jenny Gibbons, Canadian Space Agency astronaut and Artemis II backup crew member, letting Reed Wiseman know that he has family here to support him today in the Artemis Mission Control viewing room.
Thanks, Bill. Thank you so much for the $5 Australian. Really appreciate it. Yeah, it's awesome that these super chats have been coming in today, guys. Quite a few of them. You guys have been awesome today. Thank you.
Flying today. However, the Artemis crew members named their Orion spacecraft Integrity, so you will hear calls to this entire crew with the name Integrity. They say that the name Integrity embodies the foundation of trust, respect, candor, and humility across the crew and the many engineers, technicians, scientists, planners, and dreamers required for mission success.
Oh, wow.
This view live from the outside of Orion as we continue. Preparing for our lunar flyby, now less than 5 minutes from surpassing the record set by Apollo 13 astronauts for the farthest humans to travel from Earth. This will not be the farthest that Integrity travels today. They will continue until they reach approximately a distance of 252,760 miles. That would be about 4,105 miles farther than Apollo 13. However, these numbers are our targets, and we will get confirmation on those numbers as soon as we possibly can and share them with you all.
Hey, Ritz Lion, if they offered me a seat up there, yeah, I'd have to take it, even though there's no way I could possibly be on a mission like this, but yeah.
Audio recordings. To get a little more detailed, Reed Wiseman and Jeremy Hansen will be up first to capture imagery and record audio on the portable computing devices. You hear those referred to as PCDs, while Victor and Christina serve as the support members. The crew will switch windows and roles halfway through their shift, and 1 hour and 5 minutes later, Victor Glover and Christina Cook will be the next crew members at windows 2 and 3 to take photos and make annotations, while Reed and Jeremy take on those support roles. There are 5 viewing blocks, and the crew will swap out with each one. During 2 of the blocks, the 2 support members will also be able to enjoy their midday meal.
Thank you so much, Easy. Really appreciate it. Once again, guys, keep in mind the data necessary for the spacecraft to function is what's taking priority. So we may not get this high-res imagery live.
Or gotten any specific ones. If they have issues with their camera or any other operational items, the other part is an actual description of the moon. This task is done by one of the support team astronauts, so that's not the crew currently taking photos or making annotations, but they do have windows 1 and 4 that they can float up and provide that information from. If you watch the entirety of the flyby, you'll also notice the crew will be photographing some targets multiple times to get observations in different lighting conditions. This is due to Orion changing their location throughout the flyby.
Well, we'll see. The way they're talking, we're going to be getting a lot of much better images here soon. So fingers crossed.
Years to do because of solar and spacecraft positioning. This crew has studied the moon extensively, and they're also familiar with what the science team calls the Big 15. These are 15 features that they've memorized, so at any time, they'll be able to see 5 of those and help orient themselves and where they are around the moon. Those targets are diverse and complex in their geologic history, and observations of them could help answer some big-picture science questions. If you've been following the mission, you can see that the configuration of the cabin is a little bit different than what it looked like on launch day. After ascent, the crew were allowed to reconfigure their spacecraft, and you can see that they've taken down seats. They have also taken away footrests. This gives them more opportunity to move about the spacecraft. Orion itself has 330 cubic feet of habitable volume. That's about the size of 2 minivans and is 60% more cubic volume than the Apollo spacecraft. We are standing by.
And yeah, they're using a wide variety of cameras here, guys, and a lot of them are handheld. Low light, starlight, infrared, IR, all kinds of cameras. I mean, and also to put it into perspective, I don't know if any of you guys watched the private spacewalk, as it was called, that was on a Crew Dragon mission. That was a SpaceX event, and man, that took forever, and there's many parts of it that was less than exciting. So in order to keep everything safe with these procedures and to make sure that everything's being done properly, there are procedures on top of procedures. It takes time, but in the end, the photos that we get are amazing.
Set the record for the farthest distance humans have ever traveled from our home planet. At that time, over 55 years ago, Lovell, Swigert, and Hayes flew 248,655 statute miles away from Earth. Today, for all humanity, you're pushing beyond that frontier. Integrity, over to you.
Yeah, from the cabin of Integrity here, as we surpass the furthest distance humans have ever traveled from planet Earth, we do so in honoring the extraordinary efforts and feats of our predecessors in human space exploration. We will continue our journey even further into space before Mother Earth succeeds in pulling us back to everything that we hold dear.
But we, most importantly, choose this moment to challenge this generation and the next to make sure this record is not long-lived.
J-Man, it won't be very well illuminated at all because the vast majority of the lit portion of the moon is facing the Earth right now. But they'll be using a wide variety of cameras that utilize starlight, infrared.
Our science team helped us out with a couple of relatively fresh craters on the moon that have not been previously named, and our crew would like to propose a couple of potential names for those items or those areas. And we spent a bit of time this morning looking out the window, and we're able to see them now both with our naked eye and through the long lens. And so we feel this is a good time to send this down, and a special shout out to Kelsey for helping us with this. The first one we'd like to suggest is a named crater in honor of our great spacecraft integrity. And so if you were to look at Oriental on the far side and then draw a line straight up to Ohm on the far side, relatively in the middle is an unnamed crater, and we would like to suggest it be called Integrity in the future. And the second one, and especially meaningful for this crew, is a number of years ago we started this journey in our close-knit astronaut family, and we lost a loved one. And there's a feature in a really neat place on the moon, and it is on the near side, far side boundary. In fact, it's just on the near side of that boundary, and so at certain times of the moon's transit around Earth, we will be able to see this from Earth. And so we lost a loved one. Her name was Carol, the spouse of Reed, the mother of Katie and Ellie. And if you want to find this one, you look at Glushko, and it's just to the northwest of that, at the same latitude as Ohm, and it's a bright spot on the moon. And we would like to call it Carol.
Wow. Emotional moment. My God.
C-A-R-R-O-L-L.
Just hear the tremor in his voice. My God. It's obviously something that means a lot to him. The suitcase, by the way, I think that's their little portable oven. They jam their pastas and other things into that little suitcase. I think that's the suitcase that does that. I'm not sure. I've seen them use it. And it's like a portable oven.
Carol Crater, loud and clear. Thank you.
Bill Alexander, thank you very much. Appreciate it.
As the Artemis 2 crew passed
Thank
the
you
record
so
set
much.
by Apollo 13 for the farthest humans to ever fly from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time, Canadian Space Agency astronaut Jeremy Hansen shared.
We're getting ourselves all put back together now, and we are going to dim the cabin lights and prepare for our science objectives ahead. Thank you.
Sounds good. We're doing the same down here, and you're maneuvering to your observation attitude.
Guys, I've
As we
explained the
pass
Van
that
Allen
Apollo
thing
13
many
record
times.
of
I
the
have a
farthest
video
humans
about
to
it.
ever fly from Earth
I'll
at
put it into
12:57
the
p.m. Central
description.
Time, 1:57
It's
p.m.
not
Eastern
nearly
Time.
the
The
problem
Artemis 2
that
crew
everybody
shared some
says.
poignant words, specifically Canadian Space Agency astronaut Jeremy Hansen. The crew also called down 2 craters not yet named that they would like to name. One, Integrity, in honor of their spacecraft, which they have named. That's near the Ohm crater. Another near Glushko, which is a bright spot, named Carol, in memory of Reed Wiseman's wife.
Right. I had a feeling that was the case, that Reed Wiseman was a widower.
In Mission Control Houston. And now the team and the Artemis 2 crew are ready to begin their lunar flyby.
It's heartbreaking for a man his age to have lost his wife, which, by the way, I know how he feels. My first wife also died at a young age. So, yeah. I hope that they do name a crater after her. I like that view. I think they're using must be using a different filter for that, trying to filter out at least some of the light, some of the bright reflected light. Yeah, for those of you familiar with my some of the previous things I've talked about, I'm a recovering heroin addict, and my first wife died of a drug overdose. So yeah, drugs and the tragedy associated with them, I'm afraid, has impacted my life pretty significantly. So anyway, Commander Wiseman, the fact that he's lost his wife, I was actually unaware of the fact that he was a widower.
We are 4 days, 19 hours,
awful.
31 minutes mission elapsed time of the flight of Artemis 2, our 4 astronauts aboard Orion. Today is our lunar flyby day. The spacecraft is currently about 12,000 miles away from the moon, and you can keep up with the distance from Orion to the moon and Earth by visiting nasa.gov/trackartemis, or you can just stay with us here because we're going to be telling you throughout the day. They are currently 248,834 miles away from planet Earth.
Thank you, Bill. I appreciate the well wishes. Yeah. It's a long time ago, but yeah. Yeah, I like that view of the moon. Sam, I think they're using a camera with a different filter on it, so you don't have quite as much reflected light there. Now that the Orion is beginning to slip behind the moon, you're going to see less and less of it illuminated, because right now the moon is in a waxing gibbous phase, 3 days away from being a full moon, meaning the opposite side of the moon is almost completely unilluminated. Lunar comms blackout, I think, is about 50 minutes. between 40 and 50 minutes, I believe, airborne. And let me find out when Artemis will be going into blackout. Just 1 second.
Coming up next on the crew's timeline today will be their cabin configuration portion. You heard some calls down to Science Officer Dr. Kelsey Young earlier about how they have configured the cabin so far. This is just a little bit more of timelined activity for them if they need to further do so. On flight day 3, the crew had time on their schedule allotted for configuring the spacecraft cabin for how they intended to arrange it today. Of course, they had to take down that configuration for another test yesterday of their Orion Crew Survival System suits. But configuring it on flight day 3 allows them the opportunity to get a chance to see what works for them now that they are in the microgravity environment.
Yes, they should get a shot of the moon and Earth. That should definitely happen midnight, and they are in a very wide orbit. And actually, comms blackout is not scheduled to happen until 6:44 p.m. Eastern time. So it's going to be a while before Orion is in that position. Right now, it's still passing by. There are very few relay satellites around the moon, actually. There's
portion of their timeline.
Oh, my dear
they have been
God.
working that already, as well as potentially during their post-sleep period this morning. The official lunar flyby observations are slated to begin in just about 40 minutes. That's when we'll have the crew at the windows photographing the moon, as well as making calls down about what they are seeing. Again, we are live here in Artemis Mission Control for the duration of the flyby. Currently, the Orbit 1 flight control team is on console. This room is staffed 24/7 from the time before the astronauts step foot on the rocket until the time they splash down and are safely recovered in the Pacific Ocean on flight day 10.
Yeah, there really isn't a full-fledged communications relay around the moon right now. They want to set that up. That's the objective, to do it, but not the case yet. Thank you, Warrior. I appreciate it. I appreciate all the well wishes and such. It was a long time ago. Happened actually back in the late 90s, but very, very sad thing.
Again, this is Artemis Mission Control here in Houston. We are now 11,777 miles away from the moon. We did pass the Apollo 13 record of farthest humans away from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time. That distance, 248,655 statute miles from the Earth, continuing to be exceeded by the crew. They will reach their farthest distance from the Earth around 6:07 p.m. Central Time. At that time, they will be in an LOS, or a loss of signal, with us on Earth, as they'll be flying behind the moon.
Thank you so much, Gerard, for the €4. I really appreciate it. So unfortunately, bopping back to the Simulation, not sure if there's a loss of communication. That does happen a lot as they switch over to new transmitters, new communications dishes in the NASA Deep Space Network. And also the NASA DSN has lost some of its communications capabilities also. And keep in mind, folks, one thing to remember to put into perspective is the fact that Apollo didn't give us any of this. You never, ever got live coverage of these sorts of things aside from the few moments that they were set up for the astronauts to set foot on the moon, that sort of thing. But otherwise, live coverage of these kinds of events almost never happened, and only for a few minutes at a time, generally. So for the most part, we're getting a much more comprehensive coverage of what's going on up there than we ever got, than the average person got to see back in the 60s and 70s. John Morgan, thank you for the $5, mate. I really appreciate it. Thank you very much. Like I say, the super chats have been coming in steadily, and I really appreciate that, folks. This is how I'm able to cover a lot of stuff in person.
As the crew gets into their cabin configuration preparations, we are joined by Dr. Sarah Noble, the Artemis Lunar Science Lead. Thanks for joining us here today.
Yeah, it's quite a day.
Yeah, we are very excited. I can only imagine how you guys are doing over there. So tell me a little bit about yourself and what your role is for Artemis 2.
Sure. So I'm the Artemis Lunar Science Lead, so over the entire campaign, and my job is basically to make sure that as we have this big adventure back to the moon, we actually learn new things about the moon.
Fascinating. So why is the moon such an important destination today?
Yeah, so the moon is a pretty amazing place. It is a great place to learn about basic fundamental processes that happen on like all the planets, like cratering and volcanology. And also it is, part of our Earth-Moon system. And, the Earth recycles its rocks pretty well, right, through plate tectonics and weathering and whatever. Most of the rocks on the Earth are geologically young. But on the moon, we have the entire record that goes back 4.5 billion years since we formed. And so if we really want to learn about what was happening in that period, like the moon is really the only place we can go.
We're also thinking about going back to the moon, and we want to go to the lunar South Pole. So what makes that such an interesting destination?
Yeah, the South Pole is cool, right? It's far away from the places we went during Apollo. It's different kinds of rocks there, some of the oldest rocks on the moon. It's also a place where we think there might be resources like water. There are craters that really never can see the sun because of the low sun angles there, and they get very cold. And we think that water and other things can build up in those craters, and so we're very interested to see what that might do for us.
I'm very interested as well. So for some of our viewers who might be new to this, what does lunar science look like during an Artemis mission?
Yeah, it's pretty exciting for us as we have sort of built this from scratch to try to understand how we can best use the crew to support our science. And so, we've developed a system. We've got a team in place. We've got a back room here in this building called the SIR, the Science Evaluation Room. And there's in fact a back room to that back room over in another building here at Johnson Space Center where we've got our teams of scientists working really hard. They're actually speaking to this room through our science officer. This is now the first time we've ever had a science officer in flight control room, so we're pretty excited about that. So we have a really voice out and up to the crew.
I know, it's been so exciting to hear Dr. Kelsey Young speaking directly with the crew today, now so close to the moon. And we have a live view here of the science operation or the science evaluation room. So this is where the majority of your team is today. Is that right?
Yeah, that's right. This is a big chunk of our scientists. You can see them in there now working hard, trying to get ready for the day. And then again, there's a second room where we have a lot of our data folks, where the data will first come down and they'll sort of sift through the data and get it ready for this team to take.
What's the mood like right now in the SIR?
It is, I would say, giddy. I think we've worked very hard for this. They have done simulation after simulation. They have worked really hard over the last couple of years to get ready for this moment, and I think everybody's just really excited to see. Even already we've had some descriptions from the crew coming down, and it's so great to see their joy and our joy, our love for the moon come through.
Yes, we are in for a real treat today if it's been anything like their observations the past couple of days. So how are the lunar science teams using this test flight to prepare for future missions to the moon?
Yeah, absolutely. This is the way that we are building our foundation for the future, from everything from, how do you train a crew to be a geologist, right? And so, working through that, getting them classroom training, field training, building the science team, building these physical rooms that we are in, designing them, designing the software that the teams are using, and then, figuring out what happens to that data. They're going to take this data and it's going to come down, and how do we get it out to not only our team, but out to the world and the rest of the science community?
Yeah, that's a great point, because when you hear these crew members talk, you would never know that they're not geologists. Your team has trained them so well.
They have been very good students.
Who can blame them? It's a pretty great topic. One more question for you. How does the science that we're doing on Artemis help support long-term exploration and including our sustained presence on the moon?
Yeah, you know what? We have a saying in the Science Mission Directorate that science enables exploration and exploration enables science, right? So you need the scientists, because we are the ones who are the experts in, landing site and doing analysis of landing site and making sure we can find a good place to land, to understanding the properties of the soil so we can, design our systems to manage that, understanding the radiation environment, keeping our astronauts safe, all of these things, right? But, in return, you provide us with opportunities where now we're going to be able to collect this data and collect samples and deploy our instruments and all of that. So it's a symbiotic relationship.
That makes perfect sense. Well, Dr. Sarah Noble, Artemis Lunar Science Lead, thank you so much for joining us here today. Best of luck to you and your team, and I hope that you get to enjoy today too.
Thank you so much.
We are now getting closer and closer to our lunar neighbor. This live view coming from the Orion spacecraft and a camera mounted on one of its solar array wings.
Just so you folks know, right now we're just over 1,000 miles an hour. You may notice that, about 1,700 kilometers an hour or so. At the beginning of the broadcast, Orion was traveling well over 3,000 miles an hour, 5,000 or so kilometers per hour. And the reason we have such a massive reduction in speed is because the Orion is coming to the apogee of its orbit, to the end of its orbit away from Earth. And so it's going to gradually slow down almost to a stop, really, as far as its relative velocity from the Earth is concerned. And then it will begin speeding back up as it begins to make its way back towards the Earth. So you're going to continue to see that velocity drop off bit by bit as the day goes on. And as I said, it dropped down to it was well over 3,600 miles per hour at the beginning of the broadcast, and now it's just over 1,000 miles an hour. Distance to the moon continues to drop off. The Orion will go about 4,000 or so miles away from the moon, 6,000 kilometers by the time it reaches its closest approach. At that time, it will be in a communications blackout. So we won't be able to, there'll be no communications, obviously live streaming, anything like that. It'll be about a 40-minute time frame that the Orion spacecraft will be out of communications with Earth.
Houston, integrity for camera serial numbers.
Ready to copy.
Hey Jenny, these are card numbers for the various positions. For the long lens on the D5, we will have individual cards. Victor's 1008, Jeremy 1019, Reed 1012, myself 1015. For the Z9, we will have one card that is dedicated for today. serial number 1007. For the cabin camera D5, we will have one dedicated card for today, serial number 1022.
All right, Christina, we copy all. Thank you.
We just realized that we have Earth out window 1 and Moon out window 2, and I'm sorry, Earth out window 4 and Moon out window 3, and it gives you the best idea of scale we have had yet. The Moon is about 3 to 4 times the size of the Earth, and it is almost full, and the Earth is just a small crescent out there. It's magnificent. I got a picture of it with the wide lens. Such a majestic view out here.
Amaze, amaze, amaze. Thank you, Reed.
Yeah, it's interesting. You're right. The elapsed time has frozen for some reason. But everything else is dropping off. And as far as the distances are all concerned, keep in mind, Orion's going past the moon,
about today. Commander Reed
not
Wiseman
to
calling
the moon.
down their view right now. Obviously, a little bit different than what we can see from the solar array camera. They are looking through the windows of the Orion spacecraft, able to see at the same time Earth and the moon. You also heard NASA astronaut Christina Cook calling down some of the cameras that they will be using today. The crew is in that cabin configuration portion.
Oh, wait. The elapsed time hasn't frozen, guys.
Observation period to start.
It's days, hours, minutes.
Just about 20 minutes.
So you're not going to see that number change. You're going to see the number change once every 60 seconds. But that's it. Days, hours, minutes. And also, Matic Entertainment noticed that as well before I noticed it. For a moment, that didn't make sense to me.
On
like, wait a minute,
Orion's
no, it's
distance
hours
they are
or
currently
days,
traveling
hours, minutes.
1,071 miles per hour, 249,159 miles away from Earth, 11,293 miles away from the moon, and continuing to grow closer. At closest approach to the moon today, the spacecraft will be just about 4,070 miles away from the lunar surface. This will be during our loss of signal with the crew as they travel behind the moon, and we will await their return to get the official number for you for how close they come to our lunar neighbor.
Folks, I think I know why this is the case. I do believe that our producer has put all of the times and distances and everything for us at the bottom of the view. This is not how it's showing up on the NASA coverage. So the reason that we're seeing all of this is because he actually did a cut and paste on that down there so we can see distances, speeds, all of that. Thanks for that, producer. Ride the Liger, thank you so much for your support. I really appreciate it. Thank you, thank you. Thanks, everybody, for your super chats today. You've made a big difference.
Inside the cabin today, the lunar targeting package is the primary tool guiding the crew observations and consists of two key components. The lunar geography review helped the astronauts study major lunar features in advance and help learn how to orient themselves during the flyby. Because, of course, the moon is not actually labeled like it appears here when we look at this map. The lunar targeting plan provides a detailed timeline of observation targets, background science context, and specific instructions for the pictures the crew should take, as well as the verbal descriptions that will be helpful to the science team reviewing them later. This is a screenshot from their lunar targeting package and a screenshot specifically of that lunar.
For attitude.
Go ahead.
We are in final attitude now for the lunar flyby. Would it be possible to pitch the vehicle down 5 degrees? That would allow us to get the D5 long lens flush and have the least amount of window distortion.
We're checking.
That call from Christina.
Travel
Cook, NASA
Malta,
astronaut
thank you
and
so
mission
much for the
specialist on Artemis
€5.
2.
Thank you, thank you, thank you.
The Orion spacecraft is positioned in a specific attitude to allow the crew to best see the moon outside of their windows today for this imaging opportunity. That call was a request for a potential attitude shift just slightly, another 5 degrees, to give them a better view and to give them a better opportunity to use their long lens camera. They'll also be using that lunar targeting package we were discussing. I am following along with that real time, so I'll be able to share with you exactly what targets the crew is looking at and when. They also trained with a lunar science passport. It's a little reference guide used on Earth to reinforce recognition of key lunar features. It is not on the flight, but it was a significant study tool for the crew to get them ready for launch. The apparent size of the moon will change throughout the flyby, and it'll appear roughly like a basketball held at arm's length at the crew's closest approach. That reinforces the need for careful planning and practiced observation techniques.
Houston, integrity for timeline.
Go ahead.
So you can see the moon is continuing to shrink more and more as Artemis is slipping behind it.
That we start observations when expected. We are showing in Optimus that observation time starts in about 15 minutes, and in LTP that our first target, discussion 1, starts in about 29 minutes. Can you confirm you'd like us to start discussion 1 in 29 minutes at 1900 GMT?
Christina, we are tracking that discussion 1 should start at 18:45. That's 15 minutes from now.
These are all live images, folks. The ones we're looking at currently.
Okay, copy all. It may be a granularity issue with LTP, but understand that we start that observation in 15 minutes, and I bet when we get there, the green line in LTP will match the start of the white band for discussion 1. I think it's just a matter of the labeling and the granularity. Thanks for confirming.
Copy, and we'll look into that a little bit more on our side as well. Christina, can you verify for us that your green line is moving on the timeline page of your LTP?
We'll see some of it live, yes. But unfortunately, because the moon is waxing gibbous, most of it is not lit right now.
Of the white visible bands, it fully makes sense now, so I think we are all set. We'll look forward to starting some observations in about 13 minutes.
Bill, thank you so much.
Christina.
Really appreciate it. I didn't hear if the 5-degree pitch down was approved. I think it was, but I'm not positive. I don't see why it wouldn't have been approved. And yet, most of the dark area that you're seeing of the moon is the dark side, because coincidentally, the vast majority of the moon that is lit right now is facing the Earth. The moon is waxing gibbous, only 3 days away from being a full moon. So only a small percentage of the, probably about 10%, 12% of the far side, dark side of the moon, whatever you want to call it, is currently lit. So all of the dark area that you see right now, all of that is the dark side of the moon, plus a little bit besides, a little bit beyond the terminator point. All of that should be the dark side of the moon. As Orion makes this very wide orbit around the moon. And again, this is one of the reasons why they're taking all of these photographs, is because they really get to see the entirety of the moon during this orbit, the entirety of the dark side. Even the stuff that's in shadow can still be seen with starlight, camera lenses, that sort of
We are
thing.
expecting the crew's observation time period to start in about 10 minutes. First, they'll be conducting a warm-up, warming up to their science observations of the moon. They'll be discussing with each other, helping each other orient using the major landmarks that they've studied, asking what is familiar.
If we roll left, port 5 degrees, that would get the moon closer to the left side of window 2.
NASA lifted off during the optimal launch window, and it had nothing to do with what phase the moon was in at the time.
It's pitch and roll, or one or the other?
Because during Artemis 1, much of the dark side of the moon was actually illuminated during that particular orbit when the unmanned Artemis went around the moon.
Had the pitch been put in already?
No, we need a little while longer to talk about it.
Earth may be hidden behind the moon, or it may be just from a different perspective. Keep in mind that Earth is very far away and quite tiny from this distance.
Where it is in the window is changing, so maybe these fancy little adjustments aren't worth it. It's going to continue to move in the window. Or is the spacecraft going to keep the moon at the same point of the window if we adjust the attitude? I assume the previous.
The Earth is in front and kind of to the right of them, actually,
center of the moon
from our perspective. You won't get a chance to see the Earth until Orion is getting closer to completing its orbit, until it's closer to apogee, which it isn't right now. It won't reach apogee until around 6:30, 7 o'clock, something like that, Eastern Standard Time tonight, or this evening. Yep, very good point. Earth will come up over the moon a short time before loss of signal, because that's when the moon and Earth will be lined up in the same perspective.
Orion and Artemis Mission Control here at Johnson Space Center in Houston, Texas. They are in the center of your screen, seated at the CAPCOM, or Capsule Communicator Console. That's Jenny Gibbons, Canadian Space Agency astronaut, and Artemis 2 backup. She was also the lead Capcom for Expedition 63 aboard the International Space Station. The crew is requesting.
And yes, that's a very good point, Love This Nation. Earth will come into view as a crescent.
The moon, our priority for today.
The same way as the moon will look from the dark side.
Discussed on the ground before they are put into work aboard the spacecraft, so the team is taking some time to do so. You also heard Gibbons reference that we are into dead bands. Dead bands are essentially keeping us in the lane in which we're traveling. minutes. If you're familiar with lane assist in your car, very similar in this case.
By the way, any times I give you, just adjusted 5 hours ahead for GMT. UK time is 5 hours ahead of Eastern Standard Time.
We are now 10,870 miles away from the moon, traveling 1,066 miles per hour and 249,390 miles away from Earth. Again, we recently surpassed the Apollo 13 distance record of farthest humans have ever traveled. And upon calling down some words during that milestone, Canadian Space Agency astronaut Jeremy Hansen noting that he hopes that this record that they are setting today is soon broken by future explorers.
That's probably not going to happen anytime soon, by the way. The whole idea that the record they set today is going to be broken. It will be broken by future explorers, but there isn't going to be an Artemis mission that requires this kind of orbit. Future Artemis missions are going to be orbiting much closer to the moon so they can facilitate landings on the moon. Originally, that wasn't going to be the case because they had these huge near rectilinear halo orbits planned, but there isn't anymore. Would I go? Yeah, definitely. Definitely I'd go. And you're welcome, everyone. Those of you who are thanking me, appreciate it. Happy to answer questions to the best of my ability, but I don't want to be constantly talking over the NASA commentators. So I'm trying to get my comments in as best I can. So yes, the longer we continue to watch this, the smaller the moon is going to appear, the more the lit side is going to pass outside of our frame of reference, our perspective. And again, that's because the moon is currently in a waxing gibbous phase, 3 days away from full.
Expecting that to start in just a few minutes when the crew will begin a warm-up discussion preparing for the day. They will be capturing images along while discussing what they find familiar about the moon and what looks unexpected to them.
The moon is actually a bit further away from us. Not much, but it's gradually getting further and further away from Earth as time goes on. Not closer. And the distance is based on Orion to Earth. That's it. Just distance from the ship to the Earth. Thanks, Sam. I appreciate it. Yeah, I don't know. 826 Jonah 826. I really don't know if Lunar Starship is going to be doing that job. They just delayed the launch again to May for the first launch of the version 3 Starship. And that's just to get it into space.
Again, just minutes away
there's
from
so
the
many
initial
other things
start
that
of
need to
lunar
be done to
flyby,
it
or when it is
to make it ready
timelined
to
for
land on the
departure.
moon.
We are currently 10,000.
Thanks so much, Mark. Thank you for the $5. Really appreciate it.
Side of your screen coming from the camera on one of Orion's solar arrays. other conversation points while the crew are getting ready for their flyby today. They'll be looking to orient themselves using major landmarks and annotating their observations along with their discussion. They'll have 10 minutes for that warm-up discussion.
Thank you for the answer there, person, on the whole thing on the moon. Again, this distance, it seems like it's close, but if you take, their photographs were recently made of Earth from a distance of 10,000 miles, 16,000 or so kilometers. And Earth seems very, very far away from there if you compare it to what Earth looks like from the International Space Station at a distance of only a few hundred miles off the surface of the Earth. And so if you're looking at the moon, just much, much smaller than Earth, it's not the same.
Features that they're seeing. We just had a huge moment realizing that Hertzsprung is about the same size as our incredible Oriental. We're really excited about this target that's kind of new to us. We're orienting on things like how we talk about albedo, finding some of the prevalent things that we're used to from all of our training, and just overall taking in this view. We also are noticing that the moon is still getting noticeably bigger as we go, even when you're watching it continuously. It's great to see these two guys get warmed up.
We love the report, Christina. Thanks. And you nailed it on why we added Hertzsprung. As you'll see in the prompts, we're looking for comparisons to the comparatively much older Hertzsprung compared to the younger Oriental. Great words.
The reference they're making to the Hertzsprung crater. Hertzsprung is on the far side of the moon. Again, there are precious few human beings who have actually looked at this crater in real time. It's a very big impact crater, again, on the far side of the moon.
As they begin their observation period and lunar flyby. NASA astronaut Christina Cook reporting
and not
their
visible
Basin.
from Earth.
The team here is looking for centered images of the basin at a full zoom, and they're hoping that the astronauts can image and describe the inner and outer rings. This is considered a degraded basin with a floor, rings, and ejecta compared to a younger Oriental basin. We spoke earlier with Julian Gross, the Artemis curation lead, about some of the terms we will hear the crew use today. One of those just called out, that's albedo, looking at surface brightness, or the amount of light a surface reflects. A few more terms that we hope to hear today during the crew's sit reps or situation reports include embaying. This refers to one feature that surrounds another. That usually is a higher relief feature.
Houston Integrity, one report from the crew at the windows. We can actually see the moon and Earth at the same time right now. It's interesting because the Earth looks way brighter, so the Earth itself seems to have a much higher albedo than the moon. We think this is independent of our eyes focusing because, of course, the Earth is much smaller than the moon in our view. So you could think that your eyes focus for the darker sky, and that it means that it only has apparent brightness more than the moon. But since we're seeing both in the same view, we do think that this can be inferred as the Earth as a whole has a higher albedo.
Great observation, Christina, and reminder that as you're starting to look for those subtle color and albedo variations on the moon, the relatively bright albedo Earth might make those a little bit difficult, but as your eyes continue to adjust, we expect you to start to see more nuance on the moon. Thanks.
Great call. Thanks for the reminder.
We're all going to be experts in lunar terminology by the end of the day. Another one we expect to hear is mare. These are dark regions paved or filled by volcanic deposits. You also can hear them called seas, oceans, lakes, or marshes, or other bodies of water. Again, we are live in Artemis Mission Control, but on the right side of your screen, that is the Science Evaluation Room. Team members who have been preparing for this day for years. The crew has significantly darkened the cabin of Orion. This allows them better views outside the windows and fewer reflections from inside. They reported being able to see the moon and the Earth out the same window at this time. We are really hopeful to get those photos. Right now, this view on the left side of your screen coming from a camera mounted on one of the solar array wings on Orion outside the spacecraft.
Thanks for pointing that out, Mike. Albedo is simply a description
zoom lenses
of the reflectivity of a given object. Different objects in space are more reflective than others, and they have what's called an albedo rating. The moon has a pretty high albedo. It's a fairly reflective and bright object. The Earth is even brighter, has an even higher albedo, but there are many other objects in space, many other objects in the solar system that have much lower albedos, much more difficult to see. And also, the stars don't disappear when you're physically in space. What happens is, number one, the cameras have to be dialed down in order. Otherwise, if you had the cameras to where you could see the stars, the moon would be so bright because of its albedo that you wouldn't be able to see any surface features. So you have to adjust for that. But also, in addition to that, you have to keep in mind that the sun is always out when you're in interplanetary space, when you're doing a moon mission, unless you're talking about that moment when you're passing behind the moon and the moon is obscuring the sun from your view. The sun is always out. Can you see the stars during the day when the sun is out? No, you can't. And so that's why the stars are difficult to see in space unless the sun is behind the Earth. If you're on a nighttime side, for example, of Earth, which the ISS is on a regular basis, but when you're going to the moon, you can't see the stars very well, at least not through a camera.
In color, albedo, topography, and texture. They also want the crew to
and Artemis is reaching the end of its orbit, apogee. So that's why it's slowing down.
Of course, a reminder that some of the items that the crew, or some of the landmarks the crew are seeing today, is the first time that humans have ever laid eyes on those portions of the moon.
As I say, when they pass behind the moon, there'll be very little albedo reflectivity from the moon, and there'll be no sunlight either. So they may be able to get some really good views of the stars back there.
Observation reminders and science sit rep reminders.
Integrity. We have a sit rep. The targets that are being discussed right now, it's the far side, near side comparison, and hearing some great discussion of browns and greens in the Aristarchus Plateau and how those disappear as you go toward the North Pole, and then over to the far side, you lose the color. You've got Jeremy in window 2, Reed in window 1, having a great discussion. Christina's under window, I'm sorry, Reed is in window 3. Christina's under window 1, documenting the discussion. And we've got the lights completely off in the cabin. There are some LEDs that we cannot put out that do provide some light scatter. But we have all of the internal lights off. And are letting our eyes adjust as best we can. The window 4 view, you only get about a third of the moon. Tycho is going to go over the horizon soon, and you can see Aristarchus, and then you start to lose the view as you go to the west in Oceanus and Procellarum. So far, the team is on the plan, and the long lens is being put to good use, and recordings are being made, and internal documentation of the configuration and the observations is ongoing. Science, do you have any questions for us at this time?
Integrity Science. Victor, very glad that you provided the first formal science sitrep, as these were indeed your idea. One follow-up question, any relationship between those browns and greens you described? Do you see them blending into one another, and do you see any topography associated with either color?
I don't want to bother the window team. I just heard that, overheard that, and so I'm sorry I don't have that detail yet. I will eavesdrop and see if I can pick that up. I will try to answer that at some point. I also heard a comparison of the albedo in Aristarchus, that crater, the very high albedo spot. You can see it on the near side. There is a feature called, I believe, Burgess alpha, that is equally or maybe higher albedo. I apologize for the gaps. I'm trying to listen and talk at the same time, but I will try to get some more information to correlate those colors from Aristarchus for you.
Understood, Victor, and good call to not bug the window team. Really like the brightness comparisons to Burgess A. Really helpful for the science team. Keep them coming. Thanks.
I also heard a discussion about the albedo of Grimaldi being a 10, and how many of us, when we were a little further away, saw that as the darkest albedo, and that the bigger Mare off to the west, to the east was still dark, but maybe a 7-8. We still think that, but you are seeing color variation, albedo variation inside of Grimaldi as well, and that even on the west side there's still a very dark part of it. But it is still the darkest. It is just not as uniform as it looked when we were farther away. We're starting to differentiate the striations of albedo inside of Grimaldi.
Copy all, Victor, and you read our mind. Superlatives like darkest, biggest are really, really helpful for us, so keep those coming.
As we were just mentioning, the crew is slated to perform these science sit reps. They are prompted to do so by an icon in their lunar targeting plan. That one coming down from NASA astronaut and pilot of Artemis 2, Victor Glover. As we discussed, the Capcom is usually the only person in the room speaking with the crew, the capsule communicator. However, today, the science officer, Dr. Kelsey Young, she is the Artemis Science Flight Operations Lead, is speaking with the crew during the flyby to ask any questions that the team may have. To her right is Trevor Graff. He is one of 3 science officers. Those would be Kelsey Young, Trevor Graff, and Angela Garcia, who will also join us later for an interview.
And Houston Integrity was able to, Science Integrity was able to get a view out of window 1, which is a beautiful view. I can see the entire moon that they're looking at. We left the T-shirt up there, so I was kind of peeking through the opening in the makeshift shroud there. And once I was able to get 2 eyes on it, what jumped out at me was Vavilov. It's just peeking out of the Terminator. It's clear of the Terminator now, but it just really jumps out because it's still got the low light, the low sun angle. And so where the, Vavilov has that impact over the top of another crater, where the 2 craters intersect on the eastern edge. So on the side closest to Oriental, where the 2 crater rings intersect, the shadow there is the highest peak in the interior of Vavilov, and so you can see that terrain is, there's some real variation in the terrain there, that there's a nice peak where those peaks intersect, where those rings intersect, and we'll get a picture of that.
Love the description, Victor, especially the comparison and relationships you just described about topography. And if it's easier for your observations, do feel free to remove the T-shirt.
They're giving us some overlays on the topography here. That's cool.
Yeah, absolutely. We will do. Thank you.
How about that?
Those calls coming from NASA astronaut Victor Glover. As we discussed, the crew is working in pairs at the windows. Right now, taking photos are Commander Reed Wiseman and Mission Specialist Jeremy Hansen. Serving as their support team are pilot Victor Glover and Mission Specialist Christina Cook. You're hearing those calls from Victor Glover as he is on that support team, and he is tasked with providing the science sit reps, while the 2 crew photographing and making annotations of the moon are in windows 2 and 3. Windows 1 and 4 are available for the support crew to fly up to, obviously look at the moon themselves, and provide these science situational reports. The view on your screen is part of the lunar targeting package, and it's something that the crew can reference as they are flying by. But this is an animation.
Okay. Dadgummit.
You also heard Glover mention Oriental. Oriental is a major feature that the team is interested in today, and it's known as the Grand Canyon of the Moon. Until this mission, the Oriental Basin had never been seen in sunlight by human eyes. Oriental Basin and its surrounding ejecta could fit within a straight line distance from NASA's Johnson Space Center, where we are at today, to Kennedy Space Center. This a live view in Artemis Mission Control in Houston, Texas, where the teams are monitoring all systems, not just for today's flyby, but on the spacecraft themselves. Again, this is a test flight, our very first flight of humans on the Orion spacecraft. This team has been this team has been monitoring the entire time of the mission, as well as we have been live the entirety of the mission, and we will be continuing to do so all the way through splashdown and crew recovery from the Pacific. This is a visualization
dropped down
from
to
Arrow,
less
the
than
Artemis
10,000
real-time
miles
orbit
from the moon at
website
this
that you
point.
can also access at any time by visiting nasa.gov/track Artemis, showing us that we are now under 10,000 miles from the moon, 9,948 to be specific, and continuing to
this
count
is
down.
a visualization. Looks like we're switching transmitters
Our
again.
closest approach to the moon today should come about 6:02 p.m. Central, 7:02 p.m. Eastern. However, we will be out of contact with the crew at this time as they begin transiting behind the moon. At that time of closest approach, the distance from Orion to the lunar surface will be about 4,070 miles. Of course, these are estimates at this time, and we'll be sure to provide you with the official numbers once that closest approach has been reached.
There's certain craters, the Oriental Basin that they were just describing, TR1. I would say that that's a good one
This shot
for them
live
to be
inside the Orion
photographing.
spacecraft, where our 4 crew members are continuing with their lunar flyby activities. They have just begun those activities really about 20 minutes ago, so we've got several hours of moon view opportunities. This is still a live view inside that capsule. However, you can see just how dark they have turned down the lights. Actually, they've turned them all the way off.
There we
There
go.
are a few LEDs that they cannot power off, but turning down these lights gives them better views outside of the spacecraft's windows while they photograph the moon. This also prevents any reflections from inside the spacecraft bouncing up on the windows and interfering with their photography. As we were previously discussing, the crew members are serving on teams, the first team being Commander Reed Wiseman and Mission Specialist Jeremy Hansen at the windows photographing what they see. We heard reports earlier that they could see both the moon and the Earth in the same view, and we are looking forward to seeing the moon and the Earth in the same view as well. That Earth set coming up in just a few hours. While Wiseman and Hansen are at the windows photographing, Glover and Cook are serving as support crew. They are able to assist with cameras. They are also providing those situation reports, letting us know how the team is working inside the spacecraft, what they're seeing, and how they're feeling about it.
Well, the thing of it is that the objective of this mission was not to really study the moon from orbit. It was to test Orion, and to test Orion in interplanetary space, not in orbit.
Crew at the window will switch
Because
roles.
interplanetary space is different.
Pictures, and the other will be making annotations on their PCD, that's portable computing device. Both of those crew members at the windows are recording audio of what they see. They are putting on headsets and recording audio into their portable computing devices. Obviously, we are not hearing this right now. This is going to be sent down to the science team, and they will be able to analyze that at a later time. What we are hearing, though, and will continue to hear, are those science sit reps a few times every block. Once this block is complete, about 40 minutes from now, we will have the teams switch. That means pilot Victor Glover and...
Science integrity, looking at a window one. I think I may have misreported earlier saying that it was Tycho going over the horizon. That was Copernicus I was referring to. Apologies. It was Copernicus is what is farthest bounding to the east, and that is now like on the horizon or just past it. And the Korolev is now a few degrees from going over the horizon. And then, you know, next it'll be Aristarchus Plateau. And so on the west, we are getting a much better view of the Terminator. Looks like we have about 80% illumination of the moon. And Vavilov and one Vavilov diameter to the west is where the Terminator is right now. And so other features are starting to peek out there. The center of the illuminated part of the moon is to the lower part is Oriental, and just around Oriental, a lot of light structure is starting to show up. A lot of high albedo, similar to the feature, I cannot remember, Burgess Alpha and Aristarchus type high albedo in the ring. So when you look at the interior ring and the external ring, it's almost as if the edges are starting to dry up and turn white. If it was something that was wet and got dry, the edges would be the part to dry first. You just kind of outline all the topography in the interior of that wall is like it was dusted with chalk or is starting to dry, or maybe dusted with snow. If this was the Earth, I would say there was snow dumped on some of the ridges on the interior of the rings of Oriental. Also, an interesting part of the discussion that I heard between Reed and Jeremy is that from Glushko to Grimaldi, there are two dark features there that look like commas, but in the wrong direction. But there's also a lot of interestingness, just a lot of geometry and squiggles and dots and lines that are starting to stand out as more small features come into view. And there also is a lot of variation in albedo.
Matthew, thank you so much. No, I don't remember the Golden Spike Company.
For example, have on the
I don't know
southern
why.
edge of
I
the
bet I don't.
one, the one that's further to the south, there's a very dark, the one albedo, like the southern and western part of Grimaldi. And the one to the north, closer to Glushko, is also that same dark albedo. And then around them there are some very high albedo spots just to the north of the southern one, and just to the west of the smaller one to the north. Very high albedo, almost approaching the 10, a 9 or a 10, like Aristarchus. And lots of little bright spots are just starting to pop up in this view. To the north, as you look up,
Yeah, they got loads of 4K cameras, guys.
Very distinct crater with a lot of a very defined central peak that is also 3 in albedo, and all of that area past it, going to the horizon, gets lighter and lighter, and is very, very high albedo. And I will go look and find the name of that feature if I can look that up. And then to the south, really getting some interesting geography and topography in the South Pole Aitken Basin. And the view of the South Pole is quite amazing. We've got some Terminator there, as well as the limb view, and there is a very distinct crater right at the South Pole. And I'm going to go look up, I don't believe that is mistaken, but I'm going to go look up the name of that one because it's also giving a lot of good topography due to the shadows that I'm seeing. But that's I was trying to bound the view that I'm seeing for it and got distracted by all of these interesting albedo variations that are popping up in the interior. But that's the view that we see just a Vavilov diameter to the west beyond is where the terminator is. Just beyond, I think Copernicus is the easternmost feature that we can see. A very nice ringed, very nice structure crater to the north with a great high albedo central uplift to the north, and the south is dotted by a very characteristic crater with a lot of terrain, shadow features, and I will go try to find some landmarks to put names with those. Any questions for the observation team?
So, you know, they've already done an unmanned orbit of the moon and brought it back. They've already done that. That was Artemis 1.
Especially interested in your descriptions of the dark patches. You compared the comma-looking features to the albedo you see in Grimaldi and noticed that you're starting to see those color differences popping out. Any observations you want to make, especially when you get on, you know, the PCD in a little bit, would really help us tease out the differences in those dark mare deposits. Great description, Victor. Keep them coming.
Absolutely will do, and I know you've got descriptions on both of the window observers right now as well. Keep them coming.
I believe that dark patch at the bottom is Oriental, right at the center of the moon, as you can see it. Its lower center is the Oriental Basin, I think. Just an enormous crater formation on the dark side, the far side of the moon. Right now, most of what we see in this image is stuff you can't see from Earth, or it's slipping around behind the far side of the moon. So most of what we see is
team. NASA astronaut and pilot of the Artemis 2 mission, Victor Glover, calling down a situation report, noting several different features on the moon and such descriptions, even saying that it looks like snow on some of the peaks. Obviously, we do not expect that to be snow, but referencing that as some of the lighting on how it looks to the Artemis 2 crew from their current position.
And we're going to get all of these photos later, guys. It's all this 4K stuff. I can tell you, I don't upload my videos in 4K because it gobbles up way too much bandwidth and takes forever.
The team is slated
and
to be
most of my footage isn't in
positions
4K anyway.
now.
So I don't see why they should be sending 4K video to us
have been at
from a
2 and
quarter
3,
of a million
one
miles
taking
away.
photos, one making observations and annotations on their portable computing device. At this time, we also anticipate that they are looking at a crater duo. One of those is Glushko, and the team is and the other is Ohm. The team is looking to know the extent of Glushko's ray system and how its rays differ in the Mare versus the Highlands. They also want the team to compare the ray systems of Glushko to Ohm. Ohm is considered a young crater. And if you've ever seen a photo of the Richat structure, it's also known as the Eye of the Sahara. It's 40 kilometers in diameter, and that could fit within Ohm's interior. The team is specifically interested in descriptions of that ray visibility, including the color, albedo. Remember, albedo is the brightness or the surface reflection, and the reach. Again, I am using the same lunar targeting package that the crew is referencing on board right now. This helps keep them on time as well as prompt them for when they need to make a call down to the science team and report what they're saying. It also gives them reminders of when they need to swap positions at the windows. Additionally, I'm using the Artemis 2 Lunar Science Passport developed by Amber Turner and the Artemis 2 Lunar Science team. Now, this passport did not fly with the crew, but they used it extensively as a study guide here on Earth. So a lot of the descriptions and comparisons you hear today are developed directly by the science team. We are now 4 days, 20 hours, and 43 minutes.
Science, integrity, that crater to the north, that is, it's like we've got one in the north that looks like just a textbook crater, and one on the South Pole as well. The one on the north, I think, is Pythagoras. And what I wanted to highlight about that is it is either a very distinct central uplift or just a very defined area of high albedo. If a majority of the crater, especially the floor of the crater, is, say, an albedo of 5, this center, and gosh, only a tenth of the diameter of Pythagoras is an albedo of 2, maybe 3, but it is very bright and it stands out. And then between that crater and the actual, what is the horizon from here, there seems to be another crater right on the horizon, and right on the edge of that is another patch of that albedo. It seems to be between the two craters. It's hard to tell from this grazing angle, but there is another spot just further north beyond Pythagoras. Between the two, I can draw a picture of this one and show you where that very high albedo, again another 2 albedo surrounded by 5 and most of the area bounding it.
Integrity science, thanks for that. We agree with the Pythagoras assessment. And as a follow-up to your previous report, the SIR had questions about topography comparisons between the North Pole and the South Pole of the Moon, if you're willing to provide words on that.
Topography comparisons, absolutely. And if you have any idea what... if you draw a line between Pythagoras and the western edge of the outer defined ring of Oriental, it intersects a beautiful textbook crater on the south. I would love to know the name of that. The topography differences, now the South Pole has a little bit of a benefit that it has more of the terminator, and I can see a little more shadowing there, but there's a nice crater right at the South Pole, so that's the main thing defining the topography there. Seems to be quite a bit of elevation change. I can see some very jagged shadows, a 90-degree just to the west of that crater at the South Pole. I can see a very distinct change in the shadow directions, indicating, I don't know, a very high wall or a very deep canyon just to the west of that. And in the north, it seems to be that from sort of the edge of the mare that's dark, which is maybe 1 Pythagoras diameter south, if you draw a ring about that, maybe the top 7 degrees of the moon, and just draw a ring around that, the near side is an albedo of 5 and looks quite smooth from here. And then along the same edge of the mare, the edge of the mare that kind of Grimaldi's just outside of, Glushko is just outside of, Carroll Crater is just outside of, and you start to see the stark differences between the darker 7/8 and the 5s and 6s the 4s and 5s. If you follow that line up to the north, that line is also where the change in topography happens at the North Pole. The line defining the light and dark on the edge of the mare that you can see from Earth. Draw that line, roughly the midpoint of all that, straight to the North Pole. And on the side facing the Earth, you see smoother topography and dotted by Pythagoras and its next door neighbor crater. And then on the far side, you see a lot more cratering and a lot more topography. And again, the far side has the benefit of a little terminator there, but I am seeing a variation in the topography. It seems to be more jagged and a more challenging place to find a place to land and to even traverse in the south. All around the South Pole, and at the North Pole, it seems to be it would be more challenging to translate on the far side of the North Pole compared to the near side of the North Pole around Pythagoras.
Copy all, Victor. You really help paint a contextual picture
Thank you,
of
Robert.
what you're looking
Thank
at.
you.
We really appreciate the way that you're guiding us into the areas you're seeing by drawing comparisons between recognizable features. Thanks for that.
Thank you so much, Robert.
Kelsey, another little science sit rep moment, something I just heard from the window team is the more I look at the moon, the browner and browner it looks. I thought that was an interesting observation. The two observers have been on timeline, no hardware issues. They did start to talk a little bit about another feature that you'll hear more about on the recordings that they call the handprint. That was at the end of their Glushko and before they moved into their current target. They thought that was worth chatting a little bit more about. And they're preparing to switch after this.
Houston copies and concurs.
Hey, Houston Science, actually Houston and Science Integrity, another just observation from the human. My eyes have shifted a little bit since I've been up here. I've been wearing my reading glasses to look at the PCD. Well, this is a very taxing event on the eyes, looking out the window and seeing the very bright moon, then coming back inside to the dark cabin and trying to work cameras and microphones and logistics and lunch and those kinds of things, and then looking at the PCD, which is dimly lit. It's just been an exercise. It is a difficult thing to manage it. I'm up and down on the glasses and then having to wait as my eyes adjust when I come back in. As soon as I look back into the cabin from looking out the window, I can feel my eyes adjusting, and I just have to work through it as they adjust.
Appreciate that report, Victor, and know that we are prepared to read you up targets from the ground if that would give you the ability to keep your eyes focused on the moon and not having to swap between that and the PCD. Just let us know.
Folks, I'm stepping away from the camera for 5 minutes. I'll be right back.
Yeah, we appreciate that, Science, and we will also do that for the window teams, and we'll back each other up that way as well. But we appreciate that. We may take you up on that. Thanks.
Continued detailed descriptions from the Artemis 2 crew aboard Orion. Again, this is a test flight, the first time we've flown humans aboard this spacecraft. So every detail, even that it's difficult to look outside the window and then back at the PCD, that portable computing device, every single detail is appreciated as we prepare for future missions. Glover also mentioned that he is now wearing his glasses now that he's in space and that his eyes have shifted a bit. This is something that happens when our astronauts go to space. There is a fluid shift from the lower half of your body up into your head, and that can cause changes in your eyes. It's something that we have seen over time for some crew members, especially now that we have been living and working on the International Space Station for over 25 years. Again, it's clear that these Artemis 2 astronauts have undergone extensive lunar science training, including classroom instruction, fieldwork, and high-fidelity simulations. Training expeditions even took place in analog environments like the Icelandic Highlands and the Kemasassen impact crater in Labrador, where crews practiced identifying and describing geologic features under varying conditions. Additionally, here at Johnson Space Center, Orion mock-ups were used to rehearse crew choreography, including three-dimensional space management with an inflatable moon globe to simulate the flyby. And while on Earth, the crew also used that small lunar passport that I mentioned with descriptions, photos, and prompts to help them study the features we hope they'll see. Now, this is a view from their lunar targeting package at this time, helping them determine what they're seeing on the moon, as well as on the left, keep up with what their next target will be. As you can see, we have got a long list and an exciting day ahead of us. It's now been 4 days, 20 hours, and 53 minutes since Orion launched atop the Space Launch System rocket from Kennedy Space Center in Florida with our 4 crew members aboard: NASA astronauts Reed Wiseman, Victor Glover, and Christina Cook, and Canadian Space Agency astronaut Jeremy Hansen. The Artemis 2 crew passed a major milestone today when they passed the Apollo 13 distance record at 12:57 p.m. Central, 1:57 p.m. Eastern. That Apollo 13 distance record was 248,655 statute miles from Earth.
And Houston, another observation, whole moon. When you look at the moon, something I've never seen in photographs before but is very apparent, all the really bright new craters. Some of them are super tiny. Most of them are pretty small. There's a couple that really stand out, obviously. And what it really looks like is like a lampshade with tiny pinprick holes and the light shining through. They are so bright compared to the rest of the moon.
We copy, Christina. Thank you. Looks like you guys might be doing it, but remind you to swap positions at the window and take your SD cards with you. We're loving everything that you're calling down, so keep it up.
Again, Orion previously surpassed that Artemis, or the Apollo 13 greatest distance from Earth by humans. That was 248,655 statute miles from Earth, and Orion now 250,294 miles away from our home planet. The spacecraft is 9,033 miles away from the moon and growing ever closer. At its closest approach, it'll be about 4,070 miles away, and we will make sure we confirm what that distance ends up being. This is an approximation and an estimate ahead of that moment. We're anticipating them to make that closest approach at 6:02 p.m. Central, 7:02 Eastern, when they are in a loss of signal, transiting behind the moon. They will be the first humans in over 50 years to fly behind the moon and lose contact with Earth. We will regain that contact about 40 minutes later as they reconnect to the Deep Space Network, emerging from behind the moon, and we will look forward to seeing an Earthrise. Again, the crew is currently in their position swap portion on their timeline. This allows crew members the opportunity and the experience of all roles necessary during today's flyby. Right now, those 2 crew members at the window have swap positions. Again, the crew at the windows swapping positions. Right now, that crew is Commander Reed Wiseman and Mission Specialist Jeremy Hansen, while Victor Glover and Christina Cook serve as their support flyby crew members. That's why you are hearing Victor and Christina during those science situation reports. Those voices will change in about 30 minutes when they take a turn, taking photos and making annotations while at the window.
Bill, thank you so much. Really appreciate it. Thanks so much. And have a good day at work. Oh my God, we just got 5 memberships gifted by Eric Bro. That's so kind. Thank you so much for doing that. The things that happen when I step away for just a second. Thanks very much for doing that, Eric Bro. So you folks will get access to some early release content and exclusive stuff too. Very nice to have gifted that. So Orion is a dip beneath 9,000 miles away, about 14,000 kilometers or so away from the moon, and its speed has dropped down to only 1,041 miles per hour as it closes in on
Houston,
the
integrity.
end of its orbital
An
path.
observation or a little bit of descriptive nature on something that we saw on the first day we had good moon views. This was when we saw more of the near side, and the ground helped me out with identifying Mare Imbrium. Mare Imbrium, when you have the western limb also in view, looks completely different than the normal view we have of the near side. It is the most striking feature of the western limb view that we had, and the mountain chains that form its eastern side are very prominent, but they actually stand out more than I'm used to seeing even on the western side, and the whole thing just feels like a big bump. It actually looks like a large healing wound with a high albedo forming the mountain chain around the impact basin. And I just don't think I had enough chance to describe how striking it was on that western limb view as we were coming in a couple days ago.
Christina, science, absolutely love that, especially since that's a feature that all of us here on Earth can observe from home. So I'm sure tonight everyone's going to be going out and looking for evidence of that beautiful topography you just said. Thanks for those words.
Okay, so yeah, you can see it is Oriental Basin, that little grayish black dot at the bottom center of the moon. That is a very sizable crater on the far side of the moon. And again, something that cannot be seen from our perspective. You get the Copernicus Basin to your right, that huge gray area. That is a very recognizable part of the side of the moon that faces us. But the Oriental Basin and this vast majority of what you're looking at right now is not usually visible, or just not visible, period, from our perspective here on Earth. And once again, very seldom, well, they've never had this kind of opportunity. Astronauts have never had an
The view on your
opportunity
screen coming
to
from
see the far
Orion,
side
a
of the
camera
moon
mounted on the
in
spacecraft's
this
solar array
comprehensive
wing.
of a view.
Toward the right of your screen,
Mike, thank you
the
so much.
near
Really
side
appreciate
is
your
the
support.
hemisphere we see from Earth. That is identifiable by those dark splotches, which are ancient lava flows.
Science integrity. A question and a comment. Question is it possible that we're seeing a Schrodinger basin from this vantage point in the Terminator at the South Pole? And the comment is the rays coming out of are less distinct. We are not seeing the bright rays coming out of it, but the sort of 9 o'clock wedge that is formed by the change in albedo from the interior portion that is to the northeast to the surrounding lighter mare that's 270 degrees to the west. That 90 is very distinct and interior. You got some great descriptions from the two at the window about the colors in there, but in that darker part, in that wedge, you've got some really interesting color, even though the rays, the distinct difference in the albedo almost look like rays, but it's not the rays coming out. It's the just change in that albedo.
Integrity science.
Trip 77, that's
very
possible.
Intriguing. Those
Could
color
be.
rays coming out of rather than sort of albedo. And as answer to your question, we do not think you can see Schrodinger. It's in darkness as of now. But thanks for that description, and it sounds like the pair at the window's got great descriptions that we're definitely going to dive into tonight.
Okay. If you could help me, I would still love to know what it is. There's a very nice crater. You're going to likely have a lot of pictures of it. What would be right in the Terminator at the South Pole or close to the South Pole where it's intersecting the Terminator right now?
Yeah, Victor, we're assuming you're talking about, kind of if you're looking at the Terminator, it's basically like 70% down from the North Pole. Is that where you're looking?
Contact, yes, that is where I'm looking.
Integrity Houston, that is an enabled caution for wastewater dump required. We have hit our limit. As expected, no crew action.
Copy, no crew action.
You are.
And integrity science, we're trying to figure out what you're looking at there. Is it like right on the Terminator, or is it in the eliminated portion next to the Terminator?
While we wait for a response from the crew, the Terminator is that difference between day and night, or brightness and darkness, that you see on the moon. We see this from the International Space Station as well, looking down at Earth.
And science from integrity, excuse my space orientation adaptation. If you draw a line between Glushko through the center of Oriental, and then another line from Glushko through the southern tangent of Oriental, that line would almost perfectly intersect tangentially the crater that I'm talking about, and it is on the Terminator. So yeah, I think I'm not looking at the South Pole. I was a little twisted.
That line description was really helpful. I have eyes on the SIR right now, and they are actively discussing lunar geography. We will be back with you shortly.
The Terminator is the dividing line between the day side and the night side, the area that's illuminated on the moon and the area that is not illuminated. So there's this very distinct point
integrity
to
science.
where
We
it
believe
turns
that's
from day
Zeeman
to night,
crater.
essentially. And on the Terminator, you can see details much more clearly with the naked eye.
We believe that that is Zeeman crater.
Zeeman. Okay, and can you say the first letter? I may be pronouncing that wrong. What's the first letter of that word?
Zulu. It's Z-E-E-M-A-N.
Copy. Thank you for that. Yes, we've got a great view of that. And when I went back to the window just now, the view has completely changed. Our trajectory is taking us to a new view, and I'm looking more into Vavilov. I've got a nice, great view into Vavilov. I'm actually away from the window right now, so I'm going to go try to give you some bounding words on the view that we're seeing. But I've got to get back to a window in a minute.
Zeeman crater, by the way, that they're talking about is close to the South Pole. It's also on the dark side, or the far side of the moon. It's 184 kilometers in diameter. It's a massive crater.
Again, when you hear calls
and again,
down
it lies
science or from science,
close to
that's
the
Dr.
lunar
Kelsey
South
Young,
Pole.
the Artemis Science Flight Operations Lead here at a console in Mission Control. You also hear communications with the crew from Canadian Space Agency astronaut Jenny Gibbons. She is the Capcom for today. She is a backup Artemis 2 crew member. Those calls from pilot Victor Glover asking about a feature he was seeing, specifically a crater on the moon. Meanwhile, the team here in the science evaluation room was actively working together to determine which feature he was describing. The teams at the window have continued to move through their targets, including Ohm, Aristarchus Plateau, Reiner Gamma, and we are preparing for the cabin and window teams to swap. That's when we'll hear more from Reed Wiseman and Jeremy Hansen when they take on these support roles, while Christina Cook and Victor Glover are at the windows photographing and annotating. As we briefly mentioned, if you look towards the right side of the moon, essentially, this live view coming from a camera outside the Orion spacecraft, and if you look on the right side of the moon where you see those dark patches.
Wow, yeah, I wish I had some more time to just sit here and describe what I'm seeing, but the Terminator right now is just fantastic. It is the most rugged that I've seen it. From a lighting perspective, there are little islands. There are islands of terrain out there that are completely surrounded by darkness, which indicates some real variation in terrain. Up to the north, there is a very nice double crater. It looks like a snowman sitting there, you know, in the 5-10 degrees below the pole in the Terminator. And then on the southern edge, there's almost like a hole. It looks like a hole, and it's the diameter of Vavilov size, just blackness, and then a wall of bright, and then it goes back to the black beyond the Terminator. So there's just, it looks like there's just a gigantic hole right there, 1 Vavilov diameter east of the Terminator. And as you go south, the Terminator is not a nice smooth arc. It's just jagged. There's almost a 110-degree turn in the shadow as opposed to the nice smooth arc, again indicating some really interesting variations. And I'm sure we'll get some photos of that. And then one of the craters further to the south of Vavilov, maybe halfway down to the South Pole, is not only a very, looks like just a deep hole, and then there's like two island rays pointing off to the west and north that indicate very high ridges and very deep canyons coming up out of that crater. So again, just some really interesting visual illusions going on with the shadows there. Like I said, there look to be islands out beyond the terminator because some of the things, maybe even a Vavilov diameter into the terminator are catching sunlight on the peaks up to the north and to the south. It's very, very interesting to see.
Integrity science, oh my gosh, that was an amazing picture you just painted. I glanced over at the SIR video and I literally saw fist pumps in the air. Those types of observations are things that humans are uniquely able to contribute, and you just really brought us along with you, so thanks for that.
That's awesome, Kelsey. Did you get a sit rep updating you on a slight change in logistics for PCD use?
Christina, this is Houston. We did not, but we will take it now.
Delay is a couple of seconds. If the total turnaround is about 4 seconds per communication.
So in other words, the one at window 2 went to window 3, and the one at window 3 went to window 2 when they swapped rather than staying at the window. We'll plan on all observers keeping the same PCD for all observations.
Copy, Christina. That makes sense to us, and good plan. We are coming up here on a cabin and window team swap. Let me know when you're ready for a quick vehicle status.
You're welcome, Roland. Thanks for watching. Hey, sometimes the Terminator has people to take out on the moon, I suppose, as well as other places. Okay.
As you heard, science.
Go for the vehicle system update.
Howdy, Reed. We don't have much for you. We just wanted to let you know that toilet right now is no-go for use as we stick with the predetermined limit for now. All crew members, please use CCUs. Otherwise, Orion is looking very good. And you have 15 minutes in this handover time where we expect Victor and Christina to switch to the windows and you and Jeremy to be in the cabin assisting. Let us know if you have any questions.
No questions at all, and they're in the swap right now. The first thing I'll tell you, I floated up to the docking hatch window and just what I'm going to call the Mari around Oriental just looks so different out the docking hatch right now. It's quite a bit darker. It's the same darkness, if not a little darker than Grimaldi, but it's cool after just being in the 400 mil for the last half hour. Looking up close, I got pictures of everything Ike was just describing on the Terminator. It really is a fascinating Terminator. And then Oriental just looks so dynamic right now. It's very three-dimensional out the docking hatch compared to what I was just looking at through the 400 mil.
We love it. We are getting a sneak preview from one of our SAW cameras at what you're looking at, and we see some of what you're describing. We cannot wait to see your photos. Thanks.
Yeah, Jenny, I wish you had some longer lenses on the solar array so you could see the whole moon, but man, it is, or the up-close moon, not the whole moon, but it is just fascinating here. It's so cool.
All right, MPO and INCO, take notes. We want a zoom lens on those saws next time. Thanks, Reed.
As the crew gets ready to switch positions from the window crew going back to the support crew and the support crew flying up to the windows. This view inside the room, Capcom Jenny Gibbons speaking with the crew, Canadian Space Agency astronaut. The crew has continued to provide excellent descriptions of what they are seeing on the lunar surface. In this picture, or in this live view actually, from Orion and a camera mounted on its solar array wing, if you look at the dark portion on the right side of the screen, those are visible from Earth. That's considered the near side. Those are ancient lava flows from a time early in the moon's history when it was volcanically active. And if you look towards the left, there's that dark, large crater that appears to the left of those lava flows. That's Oriental Basin. It's about 600 miles wide, and it straddles the moon's near and far side. And this mission is the first time that humans have ever been able to see this with their eyes in the daylight. Again, you hear conversation about that terminator. You have a great view of that as well. That's the difference between light and darkness on the moon. Victor Glover explaining that as a very jagged looking terminator due to the peaks that they're seeing and the craters that they're seeing as they prepare to cross over the far side. You also heard science officer, the Dr. Kelsey Young, Artemis Science Flight Operations lead, sharing with Victor Glover that his responses are truly something that only human eyes can discern or provide. So we've previously discussed how having humans observing the moon on this mission is being combined with lunar robotic data to help us maximize what we know about the moon. So part of that data comes from the Lunar Reconnaissance Orbiter, or LRO. This orbiter provides the robotic foundation that makes Artemis 2 lunar science possible. LRO has been orbiting the moon for 17 years, which makes it the longest operated lunar orbiter in history. And it's also the only American spacecraft dedicated specifically to lunar science and exploration. Artemis 2 lunar observations are designed to complement data like the detailed surface images from LRO. So while LRO provides those detailed high-resolution maps of the moon's surface, the Artemis 2 crew adds human observations that focus on regional context and relationships between features, giving scientists a larger geologic picture. Now, this combination of robotic and human observations strengthens lunar science. LRO delivers precise and repeatable measurements over long periods of time, while the Artemis 2 crew contributes real-time visual descriptions and context that robotic instruments alone cannot provide. The best description I've heard while preparing for this mission is to compare the difference in looking at the moon with your own eyes on Earth and trying to take a picture with a camera. The camera truly never does it justice, and it's much easier to describe and perceive what you're seeing with your own eyes than to take a photo. These Artemis 2 astronauts can rapidly scan wide areas and adjust their focus in real time, as well as describe relationships between features. The crew will also observe the same regions multiple times under changing lighting conditions during the flyby and provide perspectives that would take robotic missions years to accumulate. During the Artemis 2 mission, LRO is also attempting to observe some of the same lunar features that the astronauts are studying. Collecting this data simultaneously highlights how different instruments and human eyes provide complementary information about the moon. This LRO data plays a direct role in preparing for future Artemis missions. Its measurements of topography, surface temperature, composition, radiation, and lighting conditions are used to assess hazards, identify safe landing sites, and locate potential resources such as water ice near the lunar South Pole. This mission, Artemis 2, represents the point where years of robotic preparation are paired with human exploration for the first time in the Artemis era. So together, LRO, the Lunar Reconnaissance Orbiter, and Artemis 2 are demonstrating how NASA moved from mapping the moon robotically to exploring it with humans. We are laying the groundwork for future Artemis missions and sustained lunar operations. A check-in with Orion. We are now 4 days, 21 hours, and 22 minutes into the flight of Artemis 2, our crew aboard the Orion spacecraft. We are now 8,153 miles away from the moon, 250,742 miles away from Earth. The spacecraft is traveling at 1,030 miles per hour.
Hey, Houston, the professional science update giver is now in seat 2. That is where Victor is, and Christina is nestling into seat 1 with the long lens, and we're just getting ourselves oriented here. It's a cool view in the cabin. It's actually a cool view to be off the camera now and looking at my crewmates getting up to their observation post and looking in. It's super fun.
Copy, I'll read. We like it.
As we heard confirmation from NASA astronaut and commander of Artemis II, Reid Wiseman, they are now switching positions of the support teams and the observation teams. So initially, Reid Wiseman and Jeremy Hansen were at windows 2 and 3 in the Orion spacecraft, taking photos and making annotations in their PCDs, portable computing devices. They were also giving audible descriptions into their PCDs, wearing headsets with microphones and providing recordings that the science team will be able to listen to later. We were hearing from NASA astronauts Christina Cook and Victor Glover as they made observations as part of the support team. Now, as these teams are swapping, we anticipate hearing more from Reid and Jeremy as they'll be on the support team, while Victor and Christina will be at the windows taking photos and making annotations.
Hi there folks, Jordan's just going to have to step away for about 45 minutes to an hour. His microphone just gave up, but he also needs to step away and get some food, so he'll be back with us in probably about 45 minutes to an hour. We'll just keep the stream running in the meantime, and hope you're enjoying. Thanks very much.
And Jenny, for the science team, if they can mark this time, I just covered up window 4 to block out the ambient light from a very bright planet Earth. And it'll be interesting to see if in the data Victor and Christina see any differences from me and Jeremy with that window blocked. It's a lot darker in the cabin now.
Copy, Reed. We're taking note, and we'd be curious too.
We are live in the Artemis mission control room during the lunar flyby of the Artemis 2 crew, the first humans to fly by the moon in over 50 years. Orion launched 4 days, 21 hours, and 30 minutes ago atop the SLS rocket, Space Launch System rocket from Kennedy Space Center in Florida. Our 4 crew members inside the spacecraft are transitioning their positions. The cabin and window teams have swapped. Currently at the window, we have Victor Glover and Christina Cook, NASA astronauts, and serving as support, Reed Wiseman and Jeremy Hansen. For our crews at the window, they are using handheld Nikons with an 80 to 400 millimeter zoom lens. There are also GoPros on each of the solar arrays on Orion, and that's where this view is coming from right now. We have an interior camera of the crew as well, but they have dimmed the cabin lights. They've actually turned off the cabin lights to allow them to better see outside of the spacecraft. This also helps prevent any reflections from lights inside the spacecraft reflecting onto the windows while they are photographing the moon. We talked a little bit about the views and the cameras being used on the Orion spacecraft. And again, we do have GoPros on the tip of each solar array wing. Now, the bandwidth is a little bit limited because having a crew on board, we do have to downlink a lot more data. That includes their environmental control and life support system. We are not the only data, this view that you see, coming down from the spacecraft, and so we do rely on sharing some of that with the other flight controllers in mission control. This helps the team monitor all systems aboard the spacecraft and ensure the safety of our astronauts. We are standing by for a situation report from the crew aboard the spacecraft. They've been imaging the whole moon. There is now a new crew at the window. That would be Victor Glover and Christina Cook. And so being it's their first time since they have moved up to the window positions, they have a chance to orient themselves and describe and take pictures of any color or albedo variations across the surface. Reminder, albedo is the brightness or reflectiveness.
Integrity science for a science sit rep when you're ready.
Houston Integrity, we have no external view of the moon right now for the floating crew members, so my only science sit rep is that we have Victor in window 3 doing observations and Christina in window 2 with the long lens.
Integrity, we copy. Are the shrouds still on windows 1 and 4? And if so, would you consider trying to get a view through one of those windows?
We cannot take the shroud off of 4 because the Earth is too bright and it's impacting Ike's peripheral vision. And then I can get a grazing glimpse out the docking hatch window. I can see Oriental south down to the South Pole. And the primary thing that I see from Oriental right now is just the long trenches that come out. And, you know, when you come out the north side of Oriental, the ejecta kind of boulders across the northern half of the far side. But coming out the southern half of Oriental, I just see those large, here they look like gorges. They're almost like rain when it comes down the Grand Canyon and fingers off into the desert, kind of what it looks like. Also, Burgess Alpha is extremely bright. It's the brightest thing that I can see. Even brighter now than Aristarchus, which is heading off to the Terminator. It's almost impossible now to see Aristarchus, the thing that Jeremy and I looked so much at. I can just barely see the crater rays from Ohm, and I would say for albedo right now, I would go back to Grimati is still extremely dark, especially in that southwest corner, and there are parts of Oriental and the outer ring of Oriental that reach that same level of darkness, especially the rings of Oriental reach the same level of darkness as Grimati. And then south of Grimati, Jeremy and I were noting a few other just really dark areas of cratering, mare there, and those have that same darker albedo. But Burgesshoff is the brightest, and Grimati is the darkest.
Integrity Science, that was a great description. Thank you, and thanks for the docking window geometry to give us that description. Any comments before you go on the annular ring in Oriental?
The annular ring, which I think everybody kind of describes as like a pair of lips or a kiss on the far side of the moon from here, is very circular in nature. The northern part of it is wider, darker. The southern part is much lighter. It is very neat looking, and but it is far more circular than I remember it looking in our training. The darkness of the northern side of the annular ring is the same darkness from here out this docking hatch window as the center mare in Oriental. Not quite as dark as Grimati, but it is probably only because dust and lunar regolith has kind of impacted over time.
Reed, that's exactly what we were looking for. Thanks so much. You have heart hands coming out of the SIR.
Say that again, Kelsey.
Just saying that the SIR was really excited about that. That annular ring was something we were really eager to hear about, so thanks.
Yep, you bet. And now Victor and Christina are moving on to Oriental. I got them situated over there a little bit late.
That was NASA astronaut Reed Wiseman, now providing a science sit rep as he is away from the windows most of the time. He is working as the support person along with Jeremy Hansen in the spacecraft, as Victor Glover and Christina Cook are now at windows 2 and 3, able to photograph the moon. Christina and Victor are also providing recorded information to their portable computing devices, that's their PCDs, and the science team will have access to that at a later time. They will then review it and compile all of this data to help further our understanding of the moon. One of the items you heard mentioned was Oriental Basin. This has been a very exciting opportunity for the crew. They have all been very excited about seeing Oriental, as well as the science team has been looking forward to it. It is known as the Grand Canyon of the Moon, as we discussed earlier. From the pictures, the science team is hoping that the crew will take centered images of the entire basin and surrounding craters in a single frame, but also use those 80 to 400 millimeter zoom lenses to create a mosaic entire basin. With their unaided eyes, the science team is hoping the crew will describe southern dark annular ring, which you heard Reed just describing, as well as any color, albedo, texture, or topography across the mare patches and ring mountains. Science team reports that the observations will be used to study the geologic evolution of the youngest lunar basin and to inform formation hypotheses for the annular ring. And again, another fun fact about Oriental is the diameter is the same distance between Johnson Space Center, where we are today, and Kennedy Space Center, where the crew launched on April 1st. This live view from the Orion spacecraft on the Artemis 2 mission, now 7,373 miles away from the moon, 251,130 miles from Earth. Again, the Artemis 2 crew passed the Apollo 13 record of the humans farthest from the Earth today at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time. That distance set by Apollo 13 was 248,655 statute miles. We have clearly passed that, and we expect to pass that by about 4,105 miles. That will be when the spacecraft reaches its farthest distance from the Earth. It could be around 252,760 miles, but again, these are approximations and our targets, and we will make sure to report back the final numbers once we have them. We have some refined times of when we expect to have Earth set of Earth behind the moon while Orion flies behind the moon. That would be about 5:41 p.m. Central, 6:41 Eastern. The spacecraft would make its closest approach to the moon at 6 o'clock Central, 7 Eastern, and that would be about 4,066 miles. And then at 6:02 p.m. Central, and the spacecraft will reach its farthest distance from the Earth. We anticipate that'll be about 252,755 miles, which would be 4,111 miles farther than Apollo 13. We would see Earthrise again at 6:21 p.m. Central Time, and a few minutes later, regain communications with the crew. Currently aboard Orion, Victor Glover and Christina Cook are the two team members conducting lunar flyby observations, meaning they are using the Nikon cameras to photograph the moon, and their PCD, or the portable computing device, to conduct annotations. They are both recording information that will be downlinked to the science crew, and tomorrow morning the science team will have a conference with the team while the information is so fresh. They'll be speaking with the crew about their observations and their data collection. Otherwise, most of tomorrow, Flight Day 7, is considered an off day. We are on flight day 6 of the Artemis 2 mission, the first time in more than 50 years that humans will observe the moon directly, providing a critical opportunity to practice how lunar science will be conducted during future Artemis missions. If you're just joining us, the crew is well into their lunar flyby observations, and we anticipate that we will hear from them soon. A few times every hour, they are slated to call down with science sit reps or situation reports. We most recently had one from Commander Reed Wiseman. He and Jeremy Hansen, mission specialist, were first at the windows today to photograph and make annotations of what they were seeing. Therefore, we heard more from Victor Glover and Christina Cook earlier in the day during those first blocks. But now that Reed Wiseman and Jeremy Hansen are on the support side, they are the ones calling down what they are seeing from windows 1 and 4. Earlier, we heard that the Earth is so bright in window 4, they have had to temporarily cover it with a t-shirt. The moon preserves a near-continuous record of solar system history that has been erased on Earth because the moon doesn't have an atmosphere. So things that we experience on Earth, like weather or plate tectonics, don't really apply. So the lunar surface retains evidence of ancient impacts, volcanism, and solar activity that scientists can study today. And studying the moon helps scientists understand how planets formed and evolved, how the moon influenced our own planet Earth's history, and how the sun shaped conditions across the inner solar system. The moon also serves as a unique platform for studying the broader universe. Artemis science is designed around questions best answered by humans, working alongside robotic systems, combining decades of robotic lunar data with real-time judgment, context, and adaptability that only humans can provide. This mission, Artemis 2, is serving as a proving ground for lunar science operations, which allows NASA to test how science is planned, executed, and supported during a crewed deep space mission ahead of our future Artemis flights.
Integrity, time for a window team position swap. So Victor and Christina, please switch places if you've not done so already, and remember your SD card for the camera.
We're in the swap right now. They're wrapping up their last comments, and they'll switch over and change guards in the long lens.
Copy.
As you heard in that call, it is now time for the team members at the window to swap positions. That means Victor Glover and Christina Cook will be switching roles. One of them has been photographing the moon with a Nikon with an 80 to 400 millimeter zoom lens, while the other was making annotations on their portable computing device. And both are recording audio that the science team will be able to listen to. We are now 2 hours and 10 minutes until we expect to lose signal with the spacecraft as they fly behind the moon. And the next target for the crew is considered a crew choice event. They have the option to focus on any regions or patterns or features that interest them. The science team has asked the crew to capture pictures that illustrate their choice, as well as at different zoom levels, and to describe why those certain features or regions caught their eye. Those recordings are part of what are being saved on their PCDs, portable computing device, that will be sent to the science team for analysis. The crew has been allotted 8 minutes for this crew choice event, and it's also a time for a scheduled sit rep or situation report. So we expect to hear them calling down what they are seeing soon. Something that the crew or that the science team has used to help prepare the crew is a cue card. These ask for a feature ID if they happen to know the type or name, and if it is a target. Of course, in this situation, when they have a crew choice, they do not need to, it may or may not be a target. They want to know the location and the observation style. They've also asked for the geometry of what's being captured, the size, shape, boundary, and preservation, as well as the color and shadow. So the color tone, the albedo, that reflection or brightness, and any shadows or illumination. Next, they're interested in structure and texture. That includes slopes, structures, and textures, of course, and geologic relations, like association to other features, any contact to those features, and of course, their thoughts, impressions, or interpretations. They are interested even in emotions and excitement that the crew may be having. This flyby day has been practiced in many ways, even in sims here in Mission Control Houston. The team also conducted some field work, learning how to look for specific geologic features. They also photographed a large globe, and the science team helped them determine which features they would be targeting and how to look at those. We have a few more minutes that the crew would be photographing their crew choice. Again, this is NASA astronauts Victor Glover and Christina Cook at the windows. They will then move on to another discussion portion. This is for the far side albedo, that reflectiveness, and color that they are seeing. We heard earlier about some browns seen on the moon, which is very interesting, especially here from Earth, where we are just seeing whites, grays, and maybe even black at some points. When they get into that discussion for far side albedo in a few minutes, the theme is looking to know how that color and albedo is, what those variations look like across the far side. On the right side of your screen, the Science Evaluation Room, or SIR, where team members are looking real time at what the crew is seeing. And even earlier, we're...
Houston Integrity, you ready for science zero?
We'll take it.
Okay, the crew has swapped positions. They're in their crew choice. element. I've been listening to both of them for a little bit, and they're really enjoying. They both decided to pick the Terminator, and they're spending a lot of time looking at the Terminator, just talking about the resolution that they can see, the depth of the craters, and the various interesting and unique excavations that they can see. So Victor is on the long lens, and Christina is just looking out the window, and I'm sneaking a peek in T-shirt window. It looks like, I don't have the best angle here, but it looks like Aristarchus is on the limb of the moon now. It's amazing how quickly it changes as we speed around the far side of the moon, stuff that's leaving our field of view, and now we have a lot of the dark side of the moon that, you know, it's missing for us right now, but it would be in view if it was lit at all.
Jeremy, Science, thanks for that sit rep. Do have a question. A few times we've heard you and the other crew describe change during the course of your flyby. Would be interested in future descriptions of more verbosity about how it's changing. Thanks for the great sit rep.
Yeah, Kelsey, sounds good. We are definitely keeping an eye on that. My eyes have just not readjusted. The moon is so bright when you come back to the window. I was just in the interior of the cabin. I've come back to T-shirt window, and it's just overwhelming brightness, and my viewing angle is a bit challenging, so I won't be able to give you great observations from this window. But I will talk about something that I was talking a lot about in my recordings earlier, which was we've been talking about some shades, and so we have obviously the dark and the light gray, and then we've talked about naming some colors, a brownish hue and a greenish hue. And I'll tell you, like right now, Aristarchus, the plateau is hard for me to see from this window, but that had greenish hues to me and was very unique. I didn't see anything like that anywhere else on this side of the moon. And then I see a lot of these, what I would call brownish hue areas. There's a number of them. And they, for example, in the northwest corner of the highlands, to me it looks like the brownish hue is caused by ray or ejected material landing on the highlands, and then we obviously see the ray areas as a lighter albedo, but in between the rays where the deposit would be thinnest, that is what it looks like is causing the brown to me. So I saw that in the northwest side of Aristarchus, or sorry, that dark area of the highlands, northwest side of the highlands. I saw it in the highlands to the east of Glushko, and then I see those same brownish hues west of Oriental, and I drew a contact there on OneNote, but that's a huge region, kind of like a piece of pie with the point of the pie pointing at Oriental and then going up towards the northern side of Hertzsprung. And that is an area that just looks like a different, that brownish albedo.
That was fantastic, Jeremy. We had heard rumors of the green and brown hues, and so you really read my mind on asking about those. Understand they likely didn't have any contact with each other the way that you described them, but please correct me if I misunderstood that. And then last thing, I'll make the same offer we made to Victor earlier. If it would be helpful for us to verbalize any targets so you can stay at the windows and keep your eyes adjusted to the moon, please let us know.
If you got something you want us to look at, Kelsey, you can send it on up.
definitely not looking to interrupt your flow, Reed and Jeremy, only offering assistance if you guys want to keep your eyes off of the PCDs.
Oh, I see what you're saying. Okay. Not really science related, and we definitely learned this at Apollo, but the thing that is just most fascinating, I think, to me and Victor right now is even as rugged as the far side looks, when you look at Oriental and Home, it's rugged. But man, when you look at the Terminator, it is just like impossibly rugged, and it reminds you that the whole far side is that way. And just the Terminator is really bringing out the shadows and the hills and the valleys, and it is just, it's unbelievable. It's like no surface of the Terminator is not marked by meteor impact, and it's just, it is very impressive to look at that, and you realize that that is true across the whole far side. You just can't see it due to sun illumination right now.
Reed, Houston copies, and we were commenting on the same thing. Even from our view, the Terminator looks absolutely alien because there's just so much texture in there that we're just not used to seeing. So thanks for sharing that with us.
There's also, I don't know the name of it, coming out the south-southwest of Oriental, right on the southern Terminator, is just a massive crater. I don't know the name of it. Maybe you can look on the solar array wing video and tell me it's right. It's the southernmost crater you see on the Terminator right now.
We're looking for you. We're loving that picture. Thanks for showing us. And Reed, as an answer to your last question, we believe that that is Chebyshev crater. And the sir agrees with that.
Okay, that picture I was just showing you is an 8X iPhone out the docking hatch for the high grazing angle. It's just amazing.
We love it. Thank you.
This is Artemis Mission Control in Houston, Texas. Mission elapsed time, 4 days, 22 hours, 12 minutes into the flight of Orion. This is Lunar Flyby Day for the crew aboard the spacecraft. Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen are now the farthest people to have ever traveled from Earth. This a live view from inside the spacecraft. They have turned off the lights so they're able to see outside and photograph the moon better with no reflections from inside. And for a very brief moment there.
Integrity Science, thanks for those iPhone views. It's helpful to see what you're seeing.
We very briefly saw NASA astronaut Reed Wiseman showing a picture he took on his phone of the moon. We do expect to get all of the photos that the crew is taking today, and we cannot wait to share some of those with you. But pretty cool in the meantime, just to see one quick shot from what the crew is seeing. And this view from outside the spacecraft on Orion's solar array wing. Orion is now 6,643 miles away from the moon and continuing to grow closer. Again, their closest approach will be about 4,066 miles. The best comparison is if you held a basketball at arm's length. That's about what it would look like to the Artemis II crew at their closest approach. This view showing at the very top, a camera coming from Orion, continuing their flyby of the moon. We have 3 more flyby observation blocks after the completion of this one. Down in the bottom left of your screen, that's the SIR, the Science Evaluation Room, where team members are continuing to work through all of the targets that the crew is photographing today, and they've helped identify some of the craters and some of the other items that the crew has seen on the moon's surface. Down on the right is Artemis Mission Control here in Houston. Those 2 rooms down at the bottom are just down the hall from each other. And we are just a few minutes away from the next cabin and window team swap. That means Victor and Christina, who have been at the windows, will fly to the cabin, the background essentially, and be their support crew for Reed and Jeremy. Reed and Jeremy will move back up to the windows. crew is continuing their discussion portion of the flyby in the lunar targeting package, where it says far side albedo/color. They are looking, the science team is looking to get a good understanding of what the crew can see on the far side at this point, and its brightness as well as any colors. We did hear earlier Canadian Space Agency astronaut Jeremy Hansen reporting that they could even see browns and even greens on the moon. I'm really looking forward to seeing those photos. And in just a couple of minutes, the teams will swap from the cabin to the window. Another rundown of just how this flyby is choreographed inside the spacecraft today. So these activities have been timelined, and there are these 5 blocks of time during which the crew is going to be observing the moon from Orion's windows. Now we are just coming up on the end of the 2nd block, and we'll start the 3rd soon. So at any time during those blocks, 2 members are at the windows working in a pair. One is taking photos from window 2 and has a blue shroud over the window to help prevent any reflections from inside the spacecraft. They are also using an 80 to 400 millimeter zoom lens. And the other astronaut on the window team will be in window 3 using their portable computing device to make annotations. Now, again, both of those crew members are making audio recordings of what they are seeing, and we are not hearing that right now. Those are going to be downlinked later to the science team, who will evaluate them and use that data to inform our understanding of the moon. Those 2 crew members at the windows swap roles.
Integrity Houston, it is time for another swap between the cabin and the window teams. So we have 15 minutes of handover time, and then we will expect Jeremy and Reed at the windows and Christina and Victor at the cabin. I have no new vehicle updates for you, but I do have a photo location for some photos on Ike's PCD, and I want to let you know that Jeremy's family have arrived in the viewing gallery.
Okay, Jenny, we copied most of that. The only thing we're missing is what you meant about the photo location on Victor's PCD. And hello to my family. I think that must be Catherine and Devin that are there. And I'm glad they made it into the viewing room. And we copy. It's time for crew swap. The A team's coming out of the windows and the B team's going in.
Okay, copy. All I meant to pass for Victor's PCD is that there are some late load photos that were requested that are now in his favorite photos folder. And you're exactly right. We have Catherine and Devin here. They give you a big wave, and they're super excited and happy to see part of what you're seeing.
Okay, copy, Jenny. We're not sure what we're looking for in the PCD, but we're going to poke around, and we may be calling you back about that one.
All right, that's no problem, and it's unrelated to flyby.
This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. And as you just heard, Capcom, or Capsule Communicator Jenny Gibbons, Canadian Space Agency astronaut and Artemis II crew backup, relaying to the teams in Orion that it is time for a swap from the cabin to the window teams. We're now at the tail end of the second lunar flyby observation block. Again, we have 5 of these today. Most recently, Victor Glover and Christina Cook were at the windows photographing and making annotations, while Reed Wiseman and Jeremy Hansen were in the cabin providing support, whether that is SD card help, but also science sit reps, calling down any situation reports for what they are seeing on the moon or anything about the vehicle status. With that call to make a swap, Reed and Jeremy will be back at the windows, making observations for what they see at the moon and taking photos. Again, you're watching live coverage of NASA's Artemis 2.
But something that's really awesome up here is we now have the moon and the Earth in window 3 simultaneously, and the moon is a gibbous, and the Earth is a crescent. And I'm guessing in about 45 minutes we'll have 2 identical crescents as we change our position in the universe.
That is pretty darn cool. Thank you.
That's the Artemis 2 crew, the first astronauts to fly by the moon in more than 50 years, reporting that when they look out of window 3, one window, they're able to see both the Earth and the moon at the same time now. Now, obviously, our view is from a camera on the solar array wing pointed at the moon, and we hope to see that view of both the Earth and the moon soon. Some upcoming times for what you can expect. In about 1 hour and 40 minutes, we will have Earth set. And during that time, we will have a view of Earth going behind the moon. Shortly after, just a few minutes later, we will lose signal with the Orion spacecraft. This is tracked as it is going behind the moon and out of reach of the Deep Space Network. At 6 o'clock p.m., the spacecraft will make its closest approach to the moon at a distance of about 4,066 miles. At 6:02 Central, the spacecraft will reach its farthest distance from Earth at about 252,755 miles. Of course, these are approximate, and we will make sure to provide you with the final distances once those are confirmed. At 6:21 p.m., we will have Earthrise from the Orion spacecraft, but we will not have communications with the spacecraft until 6:25 p.m. Central, when we expect to acquire signal with them after they've emerged from behind the moon. Again, you're watching live coverage of NASA's Lunar Flyby for the Artemis 2 mission, first crew to fly beyond the moon in over 50 years. The astronauts inside the spacecraft are switching positions, 2 at the windows and 2 serving in support roles, before they start their third timelined flyby observation for today. We've heard great calls from the crew so far describing what they're seeing, all well trained by the science team here on the ground. Another major milestone for the crew today will be to experience a solar eclipse from their capsule. No one on Earth will experience this solar eclipse. To the astronauts, this will look a lot like a total solar eclipse on Earth, except the moon will be huge compared to the sun. Whereas if you're standing on Earth and looking at a solar eclipse, the moon and the sun appear to be about the same size in the sky. As the moon begins to cover and then uncover the sun, the astronauts will see a partial solar eclipse, so that's before and after totality, and during that time frame they will have to wear eclipse glasses so they can safely view this phase. They also intend to capture images of the sun's corona during the eclipse. This is a rare glimpse at the innermost corona that will only be captured by the astronauts' cameras. During the eclipse, we also look forward to the crew members describing what they will see, which includes unique light features like the shape and size of the corona and potentially even lunar dust. At the same time,
sorry, I stepped away for a while. I honestly didn't expect that things were going to be going this long, but here I am. I am back. I hope everybody's doing well. So let me go ahead and just plow forward. Can we go ahead and mute NASA real quick? Assuming we have NASA saying anything at the moment. Let's go ahead and mute them for a second so I can say my piece, and bear with me for just a second while I get some things queued up here. All right, just a second here. All right, yeah, NASA's, I don't know. All right, yep, I think we're muted here. Okay, we've been getting a fair amount of, I mean, it's been nonstop on the chat, people just saying that this is fake, or that these images are fake, or that, you know, just all of this. Let me tell you something real quick, just from my own personal experience with this entire process. I've met the engineers who built Orion. I've met people who are on the assembly line who built SLS. I saw this rocket take off personally. And I cannot begin to imagine a scenario where they would build all of this stuff and have so many talented people dedicate so much of their lives to building something like this just to fake a mission. Build all of this stuff just to, I don't know, launch it somewhere else, launch it into orbit or something like that, as opposed to sending it to the moon and fake this whole thing. I assure you it isn't fake, and I'm done with this. I've lost my tolerance for this. So it's auto bans from here on out for anybody who says that this is fake. The Earth is flat. I have zero respect for your opinion. All right? There's endless evidence out there to prove that your viewpoint is wrong. And it's so incredibly disrespectful to the people who have dedicated so much of their lives to the exploration of the cosmos, including my uncle, who put his entire professional career over at Cape Canaveral. My uncle was a good man. He was not a liar. And he said we went to the moon. And I take him at his word. So I've just lost my tolerance for that. And as far as the image sucking and all that, yeah, believe me, I've felt that way a little bit myself. But the more I go through this in my head, the more I come to realize that if we were trying to stream 4K video from all of these people's cameras and at the same time communicate, send the necessary data from mission control to the spacecraft and keep everything operational, off of NASA's Deep Space Network, which frankly is outdated. NASA's DSN has not kept up with today's technology. It's just not possible. What Starlink can do from a few hundred miles up in orbit, Orion cannot do from 250,000 miles away. The technology just doesn't measure up. So I've just pretty much lost my patience with all of this. And I just think that it's unnecessary negativity. Granted, I'm saying I think that NASA could be doing a better job on this broadcast. There's no question about it. But the thing of it is we're getting to see the moon, at least from the same viewpoint, at least from the same angle that the astronauts are looking at it right now at this very second. And that's something that no human being has ever been able to do before. Nobody at all. So in any event, yeah, it's not the best quality. It's not great quality, but what we're staring at right now is the moon. This is the same moon that these astronauts are looking at, and we're looking at the dark side of the moon. We're looking at the far side of the moon at this point, an area of the moon that human eyes very seldom see and certainly have never seen on live mission coverage. Could it be better? Yeah, it could be better. There's no question about that. But nevertheless, I don't think it's that bad. I just really don't. So I've said my piece here. Moderators, those of you who are there, you got your directives at this point. I'm not tolerating this anymore, at least as far as saying this stuff is fake and that sort of thing. Criticism of the videos, we can of the videos and stuff, we can, maybe do a warning at first and, and eventually ban if it continues. But as far as this stuff is fake, and this is so obviously AI or CGI or any of that kind of stuff, that's absolute bullshit. I'm just not going to tolerate it anymore. Okay, thanks. And on we go. All right. So I am through with that. And by the way, you know me, I'm totally in favor of healthy skepticism. I believe in UFOs. I think that we're not being told the whole truth about it. Absolutely. And so, there's certain things that I'm definitely skeptical about, but some things I really don't think can be faked. Okay, let's go ahead and bring NASA back online and see what they're saying right now. And thanks everybody for what I had to say.
The experience that I had during Victor and my observation time. It was an incredible experience.
Thanks, Eric. Appreciate your support. Thank you, Eric.
You can see with the zoom lens, even though we have a great visible eye image, there's just a lot of texture that just pops right out at you when you can zoom in. So almost just using it like a telescope, the camera lens. We really enjoyed our discussion time. That was a great innovation on the lunar targeting plan. We were both able to describe a lot more kind of with flow, I would say, when we were talking to each other. And it was also, we sort of were able to bounce ideas off of each other and come to new conclusions. We had, I think, a very successful talking through of some contacts between different color areas, both in the mare and in the highlands, and we identified some really unique texture areas as well. At one point, towards the end of the images of my time in window 3, I just had an overwhelming sense of being moved by looking at the moon. It lasted just a second or two, and I actually couldn't even make it happen again. But something just drew me in suddenly to the lunar landscape, and it became real. And the truth is, the moon really is its own body in the universe. It's not just a poster in the sky that goes by. It is a real place. And when we have that perspective and we compare it to our home of the Earth, it just reminds us how much we have in common. Everything.
Thanks, Mosses. Really appreciate your support. Thank you, thank you, thank you.
Somewhat of a miracle, and one that you can't truly know until you've had the perspective of the other. I'll switch into some logistics stuff. The Peltors, both their batteries stopped providing the active listening, but we have verified they're still recording, and so we are able to have discussion time and hear outside our recordings by just moving the ear cup off of the ear.
Yeah, Rebecca, I'd say that we are being talked down to. That's probably true.
And we're having a really great
They're
time.
talking to what they think is the lowest common denominator.
Thanks, Christina. We copy those logistics for the Peltors, and also thanks for bringing us into the cabin with you with that description.
Right on time. NASA astronaut Christina Cook, a mission specialist for Artemis 2, calling down a science a situation report. Good news, reporting that she and her teammates have been able to capture all targets that were listed. Christina also gave a vibrant description of just how it feels to be there and to see the moon up close and not just something passing in our night sky. Currently, the team members at the window are Reed Wiseman and Jeremy Hansen. Meanwhile,
Integrity cabin team for window shroud.
We're listening. Go ahead, Jenny.
Hey, Victor, we have a temperature constraint on the windows, and the shroud might be getting us close, so we just want to check on the state of window 4.
Thanks very much
shroud,
for the $5 trip. I
whether you
really
believe it's still
appreciate it. Thank you.
necessary because maybe things have changed with our viewing, and if so, we would like to request to have the shroud removed.
Houston, we believe it is necessary. We pulled it
Thank
off
you,
due to the quarter.
Odysseus. Thank you for
Very
the
bright.
tenor.
It
Really
definitely would
appreciate it.
affect, our night vision and maybe comfort. But is there a time? Can you tell us when we would have to take it off by?
Unfortunately, since it's been on for a while, we are going to have to request that the shroud is removed, and we can recommend something that could block the light but just create a bit of distance between the window and whatever is covering it. Something like a t-shirt would do the trick and help.
Okay, we're removing the shroud, and we'll make it work. Thanks.
They're getting close to the moon.
Victor.
We're at 5,700 miles at this point. And also, you noticed that the velocity is dropped to below 1,000 miles an hour at this point. Orion is really slowing down as it reaches the end of its orbit.
On the window would also help.
We can easily point a diffuser at the window, so we're going to start with that, and it's pointing at the window now.
Okay, we'll take that, Victor. Thank you. Please keep us updated.
Rebecca, thank you so much for your generosity. Thanks so much. Thanks to everybody for your super chats today. It makes a huge difference.
That call from Capcom, Jenny Gibbons, CSA astronaut and Artemis 2 crew backup to the crew aboard Orion, letting them know that they will need to remove the window shroud they had placed on window 4.
It will never actually really completely stop, I don't think, as it reaches the end of the orbit.
Cabin and interfering with some of their
it will start to speed back up
out at the moon. This was a request from ground teams to ensure that they are protecting other systems, and the crew has been offered the opportunity to use something else to cover the window.
Thanks so much, I'm Eric. Thanks very much for your support.
And continue with their lunar flyby observations. They have just looked at Glushko crater. That's about when we heard that call down from Christina Cook with that description of everything she had been seeing during her her observation period and what she was seeing at that time. The science team asked this crew to take centered images of the entire crater and their ray system in one frame. They're also interested in knowing the brightness, texture, and extent of Glushko's rays and how they differ in the mare, or that sea area, versus the highlands. Glushko is considered a young lunar crater, and these observations can help understand material properties of those craters.
Science, integrity. First, I wanted to start off with connecting with what Christina said, that it was very moving to look out the window. I had the unfortunate sequence to start looking out the window and then moved to the long lens, and it was hard to speak looking through the zoom because I went straight where Christina went, and I was walking around down there on the surface, climbing and off-roading on that amazing terrain. I also want to underscore something that she said. As we continue to explore, when we actually do go down there to the surface, I know for safety reasons that we would never send someone alone, but I just want to really emphasize how important the discussion time was. When we started to talk, we not only got better science discussion, we got better human connection, and so doing this as a pair, we just learn and grow together, and that's just super important, so thank you for adding that to this plan. Reed just passed me a note that the Oriental Basin annular ring has a similar albedo to the center, but a different color. It has more brownish tones in it, and he said it's very distinct now that he's been staring at it.
Victor, thank you. You got a cheer from science there.
I think they will reach a distance of about 4,000 miles.
On that moonwalk with you, so highlighting how important it is to talk about these things. I also want to let you know that we have Deanna Glover with us in the viewing gallery. She's all smiles.
And they probably won't see any of the Apollo landing sites because all of those were made on the near side of the moon.
We love that we got a hey babe too, and we also have one of your lovely daughters here watching you guys work.
So the little black spot at the bottom right of the moon at this point.
Genesis, Maya, Joya, and Corinne, I love you. And Deanna, I love you. I'm glad you get to be there.
Oh, now I'm forgetting. I'll tell you, I've had a hard time thinking today. Blast. They've been mentioning the crater over and over again, and now I've forgotten.
We've had some really sweet words from the crew members.
Which one it is?
Orion
Apologize,
today, as their
folks.
Families have been able to filter in and out of the viewing room here at Artemis Mission Control at Johnson Space Center in Houston. Victor Glover also giving a great science sit rep and just a description of how it must feel if you were down on the lunar surface while he was looking through that 80 to 400 millimeter zoom lens. He also expressed how important it was to be able to talk through that real time.
Just a second, I'm going to go ahead and
stress the importance of that on future missions, that it not only made their discussions better, but also more human. Glover and Cook are in the support roles right now, not taking photos or making annotations at the windows, but they are also encouraged to have their midday meal at this time. For lunch today, those two crew members
Oriental
have options of beef ravioli, salmon, butternut squash, sweet and savory kale, pickled beets, cherry blueberry cobbler.
Thanks so much, Peter, for being a member.
Artichokes, broccoli, and chocolate peanut butter bar.
Okay, so it's the Oriental crater at the bottom right. And as you can see now, that's close to the far limb of the moon.
Reed Wiseman and Jeremy Hansen will get into their midday meal.
Sorry, they're determined to tell us all about the menu and everything else the astronauts have today.
Again, this is the third of 5 scheduled blocks.
The Oriental crater at the bottom right is on the dark side of the moon, or the far side of the moon. So what we're seeing right now is almost entirely the far side of the moon.
Away from the lunar surface. And again, expecting the crew to get about 4,066 miles away. They are currently 252,050 miles away from Earth, and every mile is a new record, having surpassed the Apollo 13 milestone for furthest distance earlier today.
So that's what we're looking at right now, is almost exclusively at this point, the far side. You can just see the outer ring of the Copernicus crater on the far right-hand side of the lunar crescent, or the half moon as we're looking at it right now. But at this point, for the most part, we are looking at the far side of the moon, and a region of the moon that very seldom we get a chance to see. Granted, we do get a chance to see it, you know, from lunar reconnaissance orbiter images and stuff like that. But still,
we have continued to lose views.
Oh, now she's telling us about it.
Just barely visible over towards the bottom right side of your screen. And then you'll also hear later about that terminator. That's the line between light and darkness while on the moon. It is really exposing some of those craters at this time. A couple of the other features in view right now are Hertzsprung Basin and Vavilov Crater. Hertzsprung Basin is nearer to the center of the moon.
Thanks very much, I'm Eric. Yeah.
Terminator line right now. And Vavilov Crater is just on the outskirts.
Let's go ahead and mute out NASA again so I can explain this, producer. So what's happening with the reason that the quality of this video is not good. I'm Eric really wants me to bring this out, and thanks so much for the super chat, by the way. It's very difficult to send 4K imagery in real time from this kind of distance. I think there's probably ways that they could do it, like they could be periodically sending us a couple of the images that they capture or something like that to give us something to look at as opposed to nothing. I think there's probably room for them to improve, but the NASA Deep Space Network is ancient. It's utilizing a lot of transmission antennas that date back decades and decades, most of them dating back to the time of Voyager. So that really we're not getting any better speed today than we got way back during the time of Voyager. And the Deep Space Network is becoming really overwhelmed with the amount of communications requirements that it has. And so as a result, it is very challenging to deliver us really good quality imagery all the way from the moon in real time. Now, as I say, what they might have been able to do is say, oh, we just got this picture, let's send this over to the viewers so they get to see this, or something along those lines. I think that would have been kind of nice if they could have done that every now and then, but there's no way that they can send us 4K footage from the moon with NASA's deep space network as it is. There's been lots and lots of discussion over the last several years, demands, as a matter of fact, and a lot of articles that have been written explaining just how bad of shape NASA's deep space network is in. It's just not capable of handling the kind of transmissions and the kind of data stream that we have today. And so as a result, it's becoming really overwhelmed. And what they got to do at this point, and again, it's not about the transmitter. It's not about what Orion has. And it wouldn't make any difference if they used a satellite out there or a the James Webb or anything like that. The receivers are what matters, and the receivers are all part of a network called the NASA Deep Space Network, and it handles all of the communications for everything across the solar system, including Perseverance and Curiosity. It sends instructions out to the rovers. It sends instructions out to the Juno spacecraft out in Jupiter, and New Horizons, which is way beyond the orbit of Pluto now, and still to Voyager to this day, still to Voyager. So what NASA needs to do is upgrade the deep space network big time. And unfortunately, they haven't done that. And no one's given them the money to do it. And when they do get money, they always talk about some exciting new mission that they want to go on, because that's what Congress wants. They want big, exciting missions that they can tell their constituents about. They don't want to just build a bunch of new antennas. That's not exciting, but that's what creates part of the problem, is when you're having to justify a bunch of new antennas. That's a hard sell to make to the average taxpayer, but it has to be done. And that's where a lot of the problems lie. So in any event, yes, laser communications are possible, but once again, we are only just experimenting with those right now. We only have a couple of spacecraft that are utilizing them, only a couple of receivers that are capable of receiving laser transmissions, and they're not planet-wide. You have to have a planet-wide network to effectively communicate with a spacecraft that's orbiting the moon, which is what the Deep Space Network was designed to do. But unfortunately, it's outdated. It needs to be upgraded, and it really creates a problem, really creates a serious problem. So that's the biggest issue more than anything else. And yeah, to answer your question, Josiah, NASA has gotten to me. No question about it. There are many things that NASA should have done differently. Upgrading their deep space network is one of them. Think of all the money that they wasted on the mobile launch tower for Artemis, for the SLS. Hundreds and hundreds of millions of dollars piled into that piece of garbage that's going to be used for, well, now it's going to be used for more launches, just because they're forcing it to. But it has all these problems, all these helium leaks and hydrogen leaks and that sort of thing. It's poorly built, and nobody knows how to fix it, because it was a bunch of different contractors who were involved in its construction, and none of those contractors talked to one another ever. And so there's no comprehensive design for the launch tower that currently launches that SLS rocket. It's really pathetic. And so, yeah, there are a number of examples of things like that NASA does that gets me very angry. And I will talk about those things when they come up. The mobile launch tower is something I talk about pretty regularly. The insane amount of money that was wasted and the incompetence on the part of the contractors. And to add insult to injury, the bonus money that they were paid. That's right. They got paid millions of dollars in bonus money for doing a terrible job. It's just embarrassing. So yeah, there's definitely issues as far as that's concerned. But once again, this is the best they can do with the network that they have. I think there's probably a few other things that they could do to, send us a few of these images that they're capturing right now. bit by bit as they're doing the stream. Maybe they might be able to do something like that. But ultimately, we are going to see those images. They're probably going to send a bunch of them to us here in the next 24 hours. Okay. Well, that's about enough. And you're right. It does work reliably. That is a good point. The Deep Space Network does function. Although it requires the help of some independent transmitters too that are not part of the Deep Space Network, such as the Goonhilly transmitter, which is a privately owned transmitter in Cornwall, UK, which I visited personally. That's a cool facility, and that is not part of the NASA Deep Space Network, but they help support the Deep Space Network with their services. Okay, we can go ahead and bring back NASA at this point, producer. Right. And by the way, we will see better imagery. There's no question about that. We will see some better quality stuff in the future. And Matt, let me tell you, it is deep space for all practical purposes. 250,000 miles is a long way, very long way. It takes a very special and powerful transmitter to even send a radio signal that far, let alone data. So yeah, the DSN is necessary for those kinds of for that kind of communication. If you're just talking low Earth orbit, that's different, but that's 400 or 500 miles, not 250,000.
For some lunar volcanism.
Thank you so much. Boy, I'm sorry. I'm not sure exactly how to pronounce that name, but thank you. And your alarm clock's going off. So yeah, I guess you need to get some sleep, don't you? And thank you so much for your generosity for the 12 euros. It's getting very late in Europe. So I appreciate you hanging in there with me for this historic event. Regardless of what you think about the footage, this is an historic moment with humans that are now currently further away from Earth than humans have ever gone.
And Kelsey, thanks for that. We love lunar volcanism too. How about when the actual crater was formed?
Yeah, we're going to get you an age for Oriental, and while we're getting that, Christina, can you...
Yeah, it seems that NASA's kind of quieted down a bit. I think they're coming to the end of this series of flyby photography events that they have to go through.
Pops out to you about physical relationship between that and surrounding terrain, we'd love to hear it.
But we are getting very close.
Yeah, definitely. They are discussing a contact relationship that could explain some of the color that they're seeing in certain areas. And so it was really about the ejecta of the creation of the basin and understanding the superposition of its ejecta and Mari on the near side or other features. So thank you. We'll take the insight when you have it.
Thank you, Integrity. And I know Jenny wants to get to you with some topics, so I'll leave you with Oriental is 3.8.
So we're down to just over 5,100 miles at this point from the moon. Again, the closest approach is going to be roughly about 4,000. How long do you think it'll be before we actually go back to the moon and land somebody? If I were a betting man, I'd say 2030. I think we're going to be competing with China to land on the moon at roughly the same time.
As is the case with a lot of Mars.
I think 2028 is ridiculously optimistic. Given the fact that Lunar Starship, there's so many milestones it still has to pass, and its test launch just got delayed again to May. So, and that's the version 3, which hasn't flown yet. This will be the first flight of version 3. So you need to get version 3 operating, and then you need to test the Lunar Starship, and you need to get refueling mastered. I don't see how it's going to be doable by 2028. I still think 2030 is very likely going to be, it might be at the beginning of 2030, but I think it's going to be around then before we're going to be ready to land on the moon. And again, one of the reasons is because we went with these really ambitious lunar landers. We weren't satisfied with something that could get the job done simply. Instead, we wanted to go with something that could carry enormous amounts of cargo, enormous numbers of personnel, something that could build a big base on the moon quickly, which great. I think that's a great ambition, and that's absolutely what we should do. But it's going to be tough to get something that ambitious working by that time. But yeah, you know what? July 20th, 2029, 60th anniversary, that would be ideal. If we could manage that, that would be good. That would be a good thing. Yeah, so it's, I mean, I maintain to this day that they made a mistake by not going with the one lunar lander that had passed its preliminary design review in 2021, the Alpaca. It had already passed its preliminary design review in 2021, whereas Lunar Starship only just passed its preliminary design review in 2025, late 2025. Just crazy.
All right, Tina, we found a way that we can reinstall the shroud on the window. We understand it's pretty dark.
So if they had used Alpaca, I would say that we would probably be very close to landing on the moon right now. We couldn't land as much. We could only land a few people, maybe 10 tons of cargo or 5 tons, something like that. Not a lot. Alpaca was a much smaller lander, but it could carry way more payload than Apollo could. So definitely still a step up, but not nearly as ambitious as Blue Moon or certainly Lunar Starship. So they went with the much more ambitious options, and that's great. You know, I applaud them for doing that in some ways, but you know, if you want to get the job done anytime soon, I think they went with I think they made a mistake there. But fingers crossed. Did he give a reason for the launch delay? No. No, he didn't give a reason for what happened. I would suspect that the static fire that they just did, they did a static fire on the booster that like cut off almost immediately. They didn't talk about what happened during that static fire, but it was clearly not a typical static fire. I think something went wrong. And I think they're trying to get that fixed now. It wasn't even a full 33 engine static fire. They didn't even have 33 engines on the booster. It was a smaller number of engines. And man, they barely lit those engines before they shut them down. So I think there is a problem with the propulsion system. And it may be more complicated than they're admitting. And again, shouldn't surprise anybody. It's a big, huge, complicated rocket. I mean, look at SLS, and it's not even reusable. Look at all the crap it went through just to get operational. So I'm not saying SpaceX is doing a bad job or incompetent or anything like that. It's just, you know, NASA took on a big task by choosing Lunar Starship. Thank you, Gary. Really appreciate you joining the advocates. Thank you so much. And you'll get access to some early release content, some exclusive stuff. I'm doing some stuff about, oh my. And then Eric sends 5 gift memberships. You're awesome. Thank you so much, Eric. Thank you. So we got 5 new members, or 6 total. And so all you folks get access to exclusive early release stuff. And also I'm making some things about the space shuttle. Go ahead.
Scale geologic features in one single view.
11 total. So there's a total of 11 that we've added in this stream. That's mind-blowing. Thanks, guys. Really appreciate it. Like I say, I release a lot of early release stuff, and I've got some stuff about the space shuttle that I'm doing now as well, some exclusive stuff about the shuttle, because my uncle and the shuttle were old friends, and so was I, actually. I went out to visit my uncle at the Cape all the time when I was a kid, and I saw shuttle launch after shuttle launch.
The other side of the moon. While they are behind the moon, they will also reach their max Earth altitude as well as their closest approach to the lunar surface.
Yeah, Mike, it could be that but personally, I think what's more likely is that NASA didn't want to have a legal battle with either billionaire.
You have right now is a live
Dynetics didn't have the money for a protracted legal fight. But both Jeff Bezos and Elon Musk had more than enough money to hire a team of lawyers to take NASA to court if they didn't win the bid. I think it's more likely that they gave the job to those 2 guys because it was going to be easier for them, because they knew that it would be a nasty battle in court that would have delayed the entire process. And Dynetics challenged the ruling, but they never took it to court.
Spacecraft Orion is now under 5,000 miles away from the moon. Again, we expect their closest distance to the moon be about.
How about that? You're right. We're less than 5,000 miles away from closest approach. Look at how much the moon has grown, by the way, since we started this broadcast, since we started watching.
Once we receive it.
It's incredible. And again, you can see the dark spot at the bottom right, the Oriental Basin, and it disappeared. When it comes back, we'll talk about that. But the Oriental Basin, which is the dark spot at the bottom right of the moon, all that is on the far side of the moon, on the dark side. So all of what we're seeing right now, when we do see the moon, all of it is, or virtually all of it is far side.
With the condensation hose.
Stuff that humans generally don't get to see.
The hose will allow you to do that if it helps with your lunar flyby.
Astronomers are going to see Artemis close to the moon. No, it's not big enough. It's a tiny little capsule. I don't think there's a telescope in existence that's powerful enough to photograph something that's that small, 250,000 miles away. I don't think, anyway.
The cabin is darkened again, and that makes a big difference for the imagery. And for science, we are now seeing a half moon.
Yes, that's true, Mike. Lunar gravity will start to speed up the Orion.
Thank you, Victor. We're happy to.
So now we can see again Oriental Basin at the bottom right-hand side of the illuminated limb of the moon, and that's on the dark side, or the far side, whatever. I love the term the dark side. It just sounds so cool. So that's on the far side, and I don't even think you can see, you can just barely see it, the tiny little dark ring at sort of 2/3 of the way up the limb of the moon, this tiny little ring, and that is just the far edge of the Copernicus ring, or the Copernicus basin, anyway. So that's still on the near side of the moon, but the vast majority of it is is on the far side. And the far side is so different. It's incredibly different from the moon that we are familiar with. It's pockmarked with lots and lots, mostly smaller craters, has lots of craters, but they're mostly smaller compared to these enormous dark basins. The Oriental Basin is one of the few really deep basins from big impacts on the lunar surface on the far side. A lot of the craters on the far side are smaller.
We are keeping up with
A lot of them are more recent too. It's very interesting. And the reason they're slowing down is because they're reaching the end of the orbit. The orbit takes them out past the moon, and then they slow down and come to almost to a stop, and then loops back, and they start heading back towards the Earth. So they're reaching the end of their orbit. And then once they reach the apogee of their orbit, they'll start to accelerate back the other way.
It is a little rougher and more jagged and starts to get into more loose-looking terrain. And
yeah, once again, there's a lot we don't know actually about the thickness of the regolith on the far side, because only 2 spacecraft have landed there. And both of those spacecraft were sent by China. The United States, actually no Western nation or no other nation, period, except China, not even the Soviets, sent a lander to the far side and successfully landed anyway and did some research. China has far more extensively explored the far side of the moon, at least as far as the surface is concerned, than anybody else. They've had a very impressive space program over the last 20 years.
Or like choppy waves when it's windy out, choppy water, and then it freezes instantly. That's the texture. If you walk down there barefoot, it looks like it would be hard on your feet, like lava. After it's cooled, it would be pokey. Except for right there in the center of Hertzsprung, it looks paved, like a paved road, nice and smooth.
Victor, that's a wonderful description. Going from a paved road to lava reminds us of the Icelandic Highlands. Thanks for that.
In science, another in the interior of the very intact, the interior of the intact crater at Hertzsprung is albedo variation. I think I heard one of the window crew maybe say color variation, but definitely albedo variation. There's lighter patches and slightly darker patches. It's not swirling, it's just patchy. It just has spots that are lighter, and I would say a predominantly darker average area.
Great descriptions, Victor. Thanks. Not swirly, just patchy is really helpful for us.
Yeah, honestly, I don't know. I don't know why it is. It's one of the biggest mysteries as to why the far side is so
really
radically different than the side we're familiar with.
They're on the plan and starting the discussion of the Terminator. And boy, I'm loving the Terminator. I think I know it's not purely a moon feature, but what it does to the features of the moon, to the terrain. I've probably spent the most time describing into my recordings and thinking about and looking at the Terminator. There's just so much magic in the Terminator. The islands of light, the valleys, what look like black holes. You'd fall straight to the center of the moon. If you stepped in some of those, it's just so visually captivating that the Terminator is the most striking thing that I've seen so far.
We've been loving your evocative descriptions, Victor. You really are bringing us along with you, and we're following along with visualizations that pale in comparison to your descriptions. Thanks.
Yeah, good point was made. You can't land on the dark side, far side. Well, You could, but it would be
Integrity Science,
incredibly
one more
dangerous. You'd
question
have to
on
do
a
so
status
without
of
any
what the
communication with
Windows
mission
team
control.
chose to observe for crew choice.
Yeah, if we put a base on the moon, there'll definitely have to be much better communications than what we have today. There'll have to be a much more robust infrastructure of communications built up compared to what it is now, if it's going to function safely and properly.
Window 2 talked about Vavilov, looked for suspended dust, and the Terminator. And window 3 about the experience and about the three-dimensionality of the moon this close.
Wonderful.
And
Thank
another
you,
observation about Oriental.
Thank you, Imeric. I really appreciate it.
The features going off to the southwest, the two large, almost look like scratches in the surface. I don't know if they're rays or canyons or collapsed lava tubes, but two distinct features that are almost parallel going off southwest from Oriental Basin. They are the first thing that made me notice parallax of our trajectory looking out at Oriental. That and in the inner walls of the east side of the crater rings, you really get a sense that we're flying over something with elevation and terrain, and they look different from this orientation.
Love to hear it, Victor. And you had it that those chains are actually crater rays, secondary craters formed from the formation of Oriental.
Yeah, speaking of crater rays, the crater rays that are going off to the north, northwest, that run off toward Hertzsprung and I believe toward Vavilov. I'm not looking at it right now, but those crater rays are very interesting. They're all very small. I know you've imaged this, but they're all small and they look like, you know, a big impact launched rocks and things that made smaller impacts down the way. But something very interesting, and again, you can see this in imagery, but some of them are parallel, and then some of them converge toward the center of Oriental. And then I think I even saw some that maybe diverge, which not diverge, but that are convergent, which indicate multiple large impacts that created a lot of secondary impact crater rays.
Fantastic, Victor. And I'll note that we can infer that you're looking down at your freshly named Integrity crater, which is near the end of one of those beautiful crater rays from Oriental. Thanks for the description.
Yeah, you're welcome. And Integrity is easily identifiable with the naked eye from this point.
Yeah, the moon is a very interesting body in a lot of ways. It's bizarre, quite unique in many ways. It may look like Mercury, but it is so incredibly different from Mercury in terms of density, composition, that sort of thing. It's a very interesting natural satellite.
We've been hearing some great situation reports from Victor Glover, the pilot of the Artemis 2 mission, calling down to the science team, letting them know what he is seeing. And one of those things is Hertzsprung Basin. If you look just to the right of the Terminator, that is the difference between light and darkness on the moon. You can see what he's describing when he says Hertzsprung Basin and how it looks a little bit paved in the middle there. It's almost in the very center of the moon in this view, coming from the Orion spacecraft and a camera mounted on its solar array. We are now 4 days, 23 hours, and 23 minutes into the flight of Artemis 2, and we are standing by for their lunar loss of signal in about 43 minutes. Again, the spacecraft will fly behind the moon, and during that time, we won't have communication with them. They will be out of reach of our deep space network. However, we will regain communication with them approximately 40 minutes later when they come around the other side of the moon.
Currently, Gary, China's looking at actually something similar to an Apollo landing site to begin with, but ultimately they want the South Pole.
The science team is interested in learning about the topography and the color of the lunar surface, and it's already been very interesting to hear that they have seen colors like greens and browns while looking at the moon. Some of the questions that they are hoping the crew will discuss are how do the quantities and sizes of craters and mountains vary along the Terminator, and they are looking for the crew to describe the topography of features along or near the Terminator. They're also looking for more information on any color or tone variations, and they're hoping that the crew will take images to illustrate their findings. Glover reported earlier that the crew has missed none of their targets when they are photographing at the window. We aren't hearing the conversations that the crew is having right now, but these are being recorded to their personal computer devices, PCDs, and those will be sent down to the science team. The science team will have a conference with the crew tomorrow morning to discuss their findings and experience when looking at the moon today. We have a few minutes left.
Yeah, Roland, I think it will be geopolitically fought over.
And if you're just joining us, you're looking at a live view of the moon, our moon, from the Orion spacecraft and a camera on its solar array. Inside that spacecraft, 4 astronauts, Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen, the first 4 people to fly around the moon in over 50 years. This is our lunar flyby day, and the crew has already surpassed one record today. The crew passed the Apollo 13 distance record at 12:57 p.m. Central, 1:57 p.m. Eastern. Canadian Space Agency astronaut Jeremy Hansen calling down that he hopes it's a record soon broken by other explorers. We are live in Artemis Mission Control in Houston, Texas, monitoring the flight of Artemis 2. All of the flight controllers here, each monitoring a different system aboard the Orion spacecraft.
Integrity Houston, we are ready for our cabin and window teams to swap again. We have a 15-minute handover time here, and I have a couple of items I want to read up to you. They'll require you to write something down on your knee boards, so let me know when you're ready.
Okay, Houston, we are ready.
Boy, I haven't the slightest idea, Paradox. It's weird. I can't imagine what could be green.
During this lunar observation shift, we will begin our lunar LOS, so you can expect a call from me a few minutes prior reminding you. And second of all, FIDO just sent us updated altitudes and METs for lunar closest approach and max Earth altitude. Let me know when you are ready to write those down. They differ slightly from Optimus.
Ryan is just over 4,600 miles away from the moon. It's very close to perigee, to lunar perigee.
0 hours, 25 minutes, 34 seconds. And the altitude will be 4,067 statute miles. Maximum Earth altitude will be at MET 5 days, 0 hours, 27 minutes, 39 seconds, with an altitude of 252,756 statute miles.
Really wants to ask for that in kilometers and in parsecs, but thank you for those. That is great. Thanks for that update.
I'll send Fido to work, and I appreciate the metric. Other than that, I have no new vehicle statuses to pass to you. Enjoy your handover time, and we're looking forward to picking back up with you shortly.
All right, we'll talk to you shortly.
Trip? No, I haven't seen those.
Those words called from Capcom Jenny Gibbons, CSA astronaut and Artemis II backup crew member, to the crew working aboard the Orion spacecraft. Had a little bit of a view inside the cabin. As you can see, it is very dark. The crew has turned off the lights, and the light that you were able to see is coming through the window, a reflection of Earthshine and from the moon. The crew is moving into their next observation block, meaning they are taking time to switch cabin and window teams. We've had Reed Wiseman and Jeremy Hansen at the windows taking pictures and making annotations and recording some audio files that will be downlinked later to the science team. Meanwhile, Victor Glover and Christina Cook were in the background serving as support. They were also timelined to enjoy a little bit of their midday meal. Now that we are swapping positions, the support team becomes Reed Wiseman and Jeremy Hansen. They will be in the background helping with SD card swaps, as well as providing those situational reports to the science team. Victor Glover and Christina Cook will be the astronauts at the window, photographing and speaking into those PCDs, portable computing devices, about what they're seeing on the moon. As you heard Capcom Jenny Gibbons call to the crew, this block is also when we will lose communications with the crew. That LOS, or loss of signal, scheduled to be less than 35 minutes from now. We anticipate to be out of signal with them for about 40 minutes, and will regain that communication once they've flown around the other side of the moon. Now, even though the crew will be flying behind the moon, their observation period does not stop. They will still be taking pictures and making annotations of what they are seeing. They'll be looking for the limb of the moon, Earth set, and then Vavilov crater, which we have previously seen. They'll swap positions at the window before moving into a crew choice option. They will get to pick things that are interesting to them on the surface, take pictures, and explain why they find them that way. They'll also be looking for any impact flashes. These are short-lived flashes on the lunar surface caused by impact bombardment. Just before Earthrise, the crew will be looking for lofted lunar dust. This may be lofted just above the lunar surface, and we could only see it just before Earthrise along the dark western limb. Any Earthshine would illuminate potential lofted dust. But once the crew is all the way around the Earth, the brightness of the Earth will wash out any of that dust they might be able to see. These were based on observations from Apollo missions and orbital spacecraft, and so we're very interested to see if the crew might be able to capture some of that lunar dust today. Following that lofted lunar dust target, the next will be Earthrise. We will regain communications with the crew shortly after Earthrise. There will be a short observation break period where the moon is not in view. That's because we are also anticipating the crew seeing an eclipse today. The moon won't be in view because the team here in Mission Control Houston will need to change the attitude of the spacecraft and ensure that its solar arrays are gathering light from the sun heading into that eclipse period. So we will have communication with the crew, we just won't be able to see the moon. However, we will have views during that eclipse time frame. During that time, the science team is looking to know it will only be illuminated by Earthshine at that point, so they want to know what the whole moon looks like overall. But they also want the crew to look
you're
into
welcome,
deep space
Stephen.
and potentially
Thanks for
see
watching.
if they can spot any planets. Once the eclipse is over, the lunar flyby period will have ended. We are live through the whole thing, and even once flyby is over today, we remain live 24/7 on NASA's YouTube.
Go ahead.
Just so you guys know, I've been checking any uploads from the various, from Artemis, the official NASA Artemis, and from the crew, various crew members, etc., to see if any of them are uploading anything to us. So far, Zippo.
Thanks, Jeremy. I hear they are watching, and your family is still here. So thanks for passing that along.
But I know we're going to get something from all of this. Oh, we'll definitely be driving buggies on the moon. I don't know about golf, though. But yeah, there's going to be, I'm not sure if they'll send it down with the first mission. They might. There's going to be both a unpressurized rover design. They haven't decided which one, but there's a number of unpressurized designs that I've seen, actually. I've seen most of the mock-ups of those designs at various space conferences. And then the pressurized rover, the big ambitious rover used to cover large distances on the lunar surface is being provided by Toyota and JAXA, the Toyota Moon Cruiser, as it is called, with a pressurized cabin and lengthy life support capabilities. I think capability to trundle around the moon for a week and support the crew inside. I think they can carry up to 4 astronauts for a week. So yeah, there's very ambitious
sweet and savory kale, pickled beets,
moon transportation.
Pudding, barbecued beef brisket, spaghetti and meat sauce, Italian vegetables, butternut squash, candy-coated chocolates, and maybe even a little bit of coffee.
Still very dark inside Orion while they
some
complete
of
their
the midday meal.
photography. Oh yeah, very nice. So you can get the comparison and views
We don't
there.
have an option for fresh food as there's not a refrigerated section of the Orion spacecraft. So all of this food can either be rehydrated or eaten straight from the package. Just depends on what the food actually is. And for food that needs to be rehydrated, there is information on each package of how much water needs to fill that bag and what temperature it needs to be. We are now 4 days, 23 hours, and 39 minutes, 40 minutes actually, into the flight of Artemis 2, the spacecraft now under 4,500 miles from the moon. We are now also under 30 minutes away from loss of signal with the astronauts. We will regain that communication about 40 minutes later. They will still be photographing
This will be interesting
and documenting
with
what they're seeing while they're behind
Eclipse.
the moon. And we especially look forward to potential Earthset and Earthrise views. As you can see on the left side of your screen, we are streaming this solar array camera view throughout the flyby. And the science team also plans to capture an occasional still photo with the solar array intermittently, perhaps one every 8 to 10 minutes. Still photos represent the highest resolution imagery from those GoPro cameras. So starting 5 minutes before Earthset and loss of signal, the science team will capture a series of photos, one every 30 seconds, to include Earthset, all the way through 5 minutes after Earthrise and acquisition of signal. In order to capture these frequent photos, the solar array camera that we were streaming will need to switch to time-lapse photo mode. So during this time, the streaming video quality won't be as sharp as you have it right now, but we want to ensure that the science team captures the data that they need during these time frames. And we really look forward to seeing those higher resolution images once they're available. But with the view you are seeing right now, we are sharing bandwidth on the Orion spacecraft with every system that is keeping the spacecraft powered and the crew alive, especially the environmental control and life support system. As this is the first flight with crew, this is also the first flight of a life support system, keeping the crew healthy and safe on the way to the moon and the way home.
Well,
on the timeline, we're getting towards the end of the cabin and window team swap period, but it looks like our astronauts, Victor Glover and Christina
Yet
Cook, are
another
already
angry
photographing
advocate.
the
Thanks
moon
for joining.
outside of
Thanks
those
so
windows.
much.
The next target is Ohm Crater, and this is something that they have photographed previously during the flyby. This is a small, complex crater with a prominent ray system, and as referenced earlier, it's the size of the Eye of the Sahara. That Eye of the Sahara is a feature in Mauritania. Seeing this crater more than once throughout the flyby allows the crew to photograph it at different lighting conditions. Those different lighting conditions help expose different portions of the target and can help the science team learn a little bit more about how it formed and what it is today. Again, this view inside the spacecraft as the crew continues photographing the moon outside their windows. They have turned the lights off to allow them to better get photos of the moon, preventing any reflections from coming in from the spacecraft. We expect the crew to be targeting Ohm Crater for another 6 minutes or so before they move into a discussion of the limb. Now, the science team has asked for a science sit rep or a situation report during that time, so we hear calls from the crew.
Theoretically, we have some very exciting things coming up here shortly. Once we come out of loss of signal, loss of communication, we'll have Earthrise. That should be fairly spectacular. Depending, but it should. And then after that, the solar eclipse.
If you've been following along, at the start of the day, we did have much more of the moon visible. And even just an hour or so ago, we could see about
Thank you,
half of the
Pebmets.
moon.
Thank you so
We are now
much.
continuing to see more of the far side and that darkness where the moon is not reflecting light from the sun. Earlier, we were also able to see some of those darker portions, that old lava flow that we often see on the near side of the moon and that we can all see from Earth. That has mostly gone away. We are now just seeing very little of Oriental. That's down to the bottom right of the moon. You can see just a small dark portion near the limb. We are now about 18 minutes away from loss of signal with the Orion crew. Again, we use the Deep Space Network to communicate with the crew members when they are this far from Earth. This is the first mission since Apollo when we have had humans on the Deep Space Network. As you recently heard Capcom Jenny Gibbons call to the crew, we expect their closest approach to the moon to be at
Thanks so much,
MET, or
Bobert
mission
or
elapsed
Bobert.
time of 5 days,
Thanks so much.
25 minutes, and 34 seconds. At that time, their altitude would be 4,067
Yeah,
statute
I'm
miles
certainly
above
hoping
the
to
Earth's
do
surface.
moon mission streams as well. More and more of them as time goes on.
Just over 2 minutes later, they will reach their maximum distance from Earth. At mission elapsed time, 5 minutes, 5 days, 27
Big Bad
minutes,
Vlad,
and
thank
39
you
seconds.
so much. Really appreciate
The
the
altitude at that time
$10
would be
Canadian. Thank you. Thank you.
252,756 statute miles. These are our latest numbers, and we'll make sure to verify and confirm those once those milestones have been achieved. Obviously, we will be without communication to the spacecraft at that time. So once we regain communication, we will make sure to find out those numbers and report those to you.
You can see some light coming into the craft now. Thank you so much, Matt. Thank you. Really appreciate the €3. And I'm honored. Your first super chat on a live stream. Thank you. Yeah, at this point, we're definitely seeing the far side of the moon and nothing else.
Checking in on the lunar targeting package, the crew is now in their discussion of the limb, seeing the limb of the moon.
We have about 15 minutes to loss of signal, LOS, as they're going to keep saying during the broadcast.
We are expecting
15 minutes, and then after that, there'll be 40 minutes where there'll be no communication.
About 40 minutes later.
With Orion.
A milestone worth mentioning that this day marks the first time in more than 50 years that humans will observe the moon directly, a critical opportunity to practice how lunar science will be conducted during future Artemis missions. I've continued to reference the lunar targeting package throughout this broadcast, which is the primary tool guiding the crew observations, and that consists of two key components. The first of those is the Lunar Geography Review, which helped the astronauts study major lunar features in advance. That also helped them learn to orient themselves during the flyby. The Lunar Targeting Plan provides a detailed timeline of observation targets, background science context, and specific instructions
channel
the crew should take,
will remain
and
live
descriptions of what will be
during that
helpful
loss
to
of
science
communication.
viewing those pictures
I
later.
will probably be
That's
taking a
what we've been
rest. As a
tracking
matter
in
of
real
fact,
time
I
and
may
what
be
the crew
taking
is
a rest
using
here
right now
shortly.
to
I
keep
did
up
not
with
get
their next
any
milestones.
sleep last night, virtually zero, for various reasons. But in any event, it's possible that I'm going to take a bit of a rest here through loss of signal, and then I'll come back for immediately after that time for Earthrise. And just to be clear, the loss of signal will be over with. Let's see, Earthrise will be expected. Signal reacquisition will take place at 7:25 p.m. Eastern Standard Time. That'll be 12:25, 25 minutes past midnight UK time. And then at that point, we'll see Earthrise almost immediately thereafter. And then there will be an eclipse about an hour after that. So I will definitely want to be around for both of those events. So at this point, producer, I am going to go ahead, even though I know I took a break not that long ago. Like I say, I am dragging at this point. So I'm going to take a bit of a break prior to the just a few minutes prior to loss of signal. We're only 12 minutes away from loss of signal, and I don't think anything all that exciting is going to happen between now and then. With signal reacquisition at 7:25 p.m. Eastern Daylight Time, 25 minutes past midnight UK time, and at that point, I will be back for reacquisition of signal and Earthrise, and then we'll deal with Earthrise and then the eclipse. Hopefully, get some spectacular views at that point. See you on the flip side.
All right, cabin is still full of excitement. We've got Christina in window 2, Ike in Victor in window 3. Reed's actually been trying to get some images out of the docking tunnel. We can see the Earth and the Moon and part of the Moon out of the docking tunnel, which is pretty good. And I'm just grabbing some footage right now with our interior cameras.
Copy, Jeremy. We'd like to know what camera Reed is using and also the status of window 1. Looks like there might be a shroud removed.
Okay. Reed was using the Z9, and the T-shirt shroud is still on window 1, but we took the camera out of it. So maybe that's what you're noticing. But when I looked in there, I saw a lot of sunlight reflecting around.
Copy. That makes a lot of sense to us, Jeremy. I want to remind you, coming up on this LOS, that we'll take sit reps in the blind. And as more and more of the moon is in darkness, we will take any report you have on impact flashes.
All right, Jenny, you have to say again your last. There's a lot of conversation here, and I was on the other side of the cabin, so I missed all of it.
Look out for impact flashes, and we'll take sit reps in the blind.
Okay, impact flashes, sit reps in the blind. We got it. And yeah, just so you understand what's going on with window 1, there is light coming through the outer hall from window 2 into the inside of window 1, if that makes sense. Like I can see the inside of the vehicle when I look between the 2 panes of glass.
Copy.
You're getting your first live look at Orion, the moon, and the Earth. Everyone in this picture. This is a live view from the Orion spacecraft. Currently aboard Orion, 4 crew members, Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen. And on the Earth, all of us, all of humanity. You can see the moon is starting to get a little bit dimmer as the astronauts are going to pass behind it. Now 6 minutes and 26 seconds away from that loss of signal. Again, we will be out of communication with them for about 40 minutes until they come around the other side of the moon and we can re-establish contact.
Integrity Houston, you are 6 minutes from your 40-minute lunar flyby LOS. From all of us, it's a privilege to witness you carrying the fire past our farthest reach. Thank you. Godspeed.
Thank you for that, Jenny. And thank you to all of you for allowing us the immense privilege to be on this journey together. It's quite amazing. And as we go on this journey, thinking about the NASA mission to explore the unknown in air and space, to innovate for the benefit of humanity, and to inspire the world through discovery. And as you've gone along on this journey with us, hopefully we're doing just those things. And as we get close to the nearest point to the moon and farthest point from Earth, as we continue to unlock the mysteries of the cosmos, I would like to remind you of one of the most important mysteries there on Earth, and that's love. Christ said in response to what was the greatest command, that it was to love God with all that you are. And he also, being a great teacher, said the second is equal to it, and that is to love your neighbor as yourself. And so as we prepare to go out of radio communication, we're still to feel your love from Earth, and to all of you down there on Earth and around Earth, we love you from the moon.
Houston copies. We'll see you on the other side.
We will see you on the other side.
Poignant words from NASA astronaut Victor Glover, and a little bit of a love letter from the other side of the moon all the way to Earth. Glover touching on the teachings of Jesus, including to love your neighbor as yourself. We are now less than 3 minutes away from loss of signal with the Orion astronauts. The Artemis 2 crew will be out of signal for about 40 minutes as they are on the other side of the moon, continuing their work photographing the lunar surface, and they will reemerge, and we will also get this view on the other side. Just about a minute and a half now until we lose communication with the astronauts aboard Orion on the Artemis 2 mission. Now 5 days and 6 minutes since their launch on April 1st. Again, we'll be out of communication for about 40 minutes. And this really beautiful view of a crescent moon and a crescent Earth. How great thou art. "30 seconds now until we expect loss of signal. And we have confirmation of loss of signal of the Orion spacecraft as it flies behind the moon. We expect to regain communications with them in another approximately 40 minutes. This was expected as their spacecraft is now out of direct line of sight with Earth and behind the moon. And this is a poignant moment as it's the first time in over 50 years that we have humans completely unreachable by anyone else on Earth. No matter how distant or secluded, we could reach anyone living on Earth, but while the crew flies behind the moon, it's simply impossible to make contact with them. This is a live view inside the Science Evaluation Room here at Johnson Space Center and just down the hall from Mission Control. This team has been monitoring the flyby all day as the team has continued capturing targets on the lunar surface. We even got to see this team in action as they were helping the astronauts identify some of the features they were seeing on the moon but not expecting. There will be a couple of milestones during this loss of signal. The first will be when the astronauts make their closest approach of the moon at MET 5 days, 25 minutes, and 34 seconds, when we expect they'll be 4,067 statute miles above the lunar surface. Their maximum Earth altitude will be reached just 2 minutes later at 5 days, 27 minutes, and 39 seconds, when their altitude should be approximately 252,756 statute miles. Once those milestones are reached and we have confirmation, we will report the official numbers. Throughout the Artemis 2 mission, astronaut voice, images, video, and vital mission data must traverse thousands of miles, carried on signals from NASA's powerful communications systems, the Near Space Network and the Deep Space Network. Let's learn a little bit more. We are now about 33 minutes until we expect to regain communications with the astronauts aboard Orion. And in the meantime, I've got Dr. Kelsey Young, Artemis Science Flight Operations Lead, here with us. Thanks for joining me, Kelsey.
Thanks for having me. This is such an exciting day.
Oh, no kidding. It has been so cool to hear you communicating directly with the crew. And I know that you have been preparing for this for years, so I am so excited for you and for your team. So just to get into that background a little bit, tell me about your background and what you've been doing on console.
My background is as a field geologist. Actually, I studied impact cratering in the field for my PhD, so all these descriptions of impact craters have me just absolutely swooning. How I got into this, though, is, during my PhD, I got an internship at NASA and ultimately never left to integrate science into flight operations. So we developed the Science Officer Console, for which this is the first mission we're supporting. We developed the Science Evaluation Room that's right upstairs, and so it's so gratifying to see this operation structure come to fruition, especially on a day like today.
I would have to imagine so. And we've got a great view of the Science Evaluation Room right now. Is there anything that has stood out to your team so far?
Absolutely. So as you might have heard in some of the press briefings and content that, we've been putting out, color and albedo were really exciting targets for us. We've heard several amazing color descriptions so far. Just to highlight maybe one of them, we heard about greenish and brownish hues near Aristarchus, which is actually a feature that we can see here from the near side. And those greenish hues could actually tell us something about the volcanic evolution of that area. So you can bet that the science team is going to be prioritizing downlinking those images and the crew audio that we didn't hear that went into those recordings to learn a little bit more.
Wow, that is fascinating. I was hearing those colors and very interested just from a personal standpoint, because looking at the moon from, 250,000 miles away, we don't see green or brown. So just hearing that, them being so close and getting to see that, fascinating. And I know very exciting for you. So what are you expecting to see in the upcoming portion of the flyby?
The upcoming portion is actually going to be really exciting. So right now, as we speak, while folks in the room are kind of taking their stretch breaks and everything, the crew are still hard at work. They still have targets to image and describe during this LOS. But when we come out, the first thing, of course, we're going to hear about is Earthrise. We're really looking forward to hearing about the crew's experience with something that we can connect with and that, Apollo 8 brought us such amazing images from. But then we start to get into describing the Terminator, as well as looking for things like lofted dust, which tell us about the modern lunar environment. Then the vehicle's going to orient away from the moon for an hour and then pivot back for the eclipse observations, which is a whole different set of science observations that we're really looking forward to.
It's kind of nice that the crew will get a little break in there, because they have been hitting it hard today with photos and videos and annotations. What are you hoping that the crew sees coming up? Is it that lunar dust?
Oh my goodness, that's a hard question to answer. I mean, we've already gotten such great descriptions. I mean, the Terminator seems to just be like one of their favorite things to look at and describe. So I feel like, that was something we were looking forward to. I feel like we've really gotten some great descriptions. So absolutely, I'm looking to the human moment of Earthrise. Lofted dust is an exciting one, and lofted dust will be a target for them in the right around the time of Earthrise, but again in the eclipse period. So I'm really looking forward to seeing. I mean, they've already highlighted just in the course of their flyby so far how the moon has changed, and this is going to be even more dramatic change to go from their end of this kind of lunar illuminated piece of the flyby into the eclipse time frame. And I can tell you they're going to be experiencing a very different moon during that time, and I can't wait to hear what their observations are.
Yeah, that's absolutely fascinating, and what a privilege that we get to do that on this mission, because that's not always the case. If we had launched on a different day other than April 1st or 2nd, we wouldn't have gotten to see that eclipse. Is that right?
That's correct. April 1st and 2nd. I will say, I was asked a lot in the weeks leading up to the launch, well, what's your favorite day? And my answer truly was, there is no bad day to launch to the moon. We were going to get great science out of it no matter what, but it's a really neat opportunity to, bring the sun into the picture, bring different planetary bodies into the picture while still literally keeping the moon in center stage.
Fascinating. So what differences are we looking for at each site? We're hearing a lot of different terms. We're looking at craters. We're looking at mare. What are the differences that you're hoping to see?
We do have, as you highlight, kind of different prompts for each target. That's what they're looking at in their lunar targeting plan, which I know you've been showing. And we have even different prompts for the person with the, the really long lens on the camera versus the people with the unaided eye. And you've heard the crew talk about, oh my goodness, when I go from one to the other, I can really detect different nuances. And that's something that we experienced in simulations, but hearing them actually, see it for real has been really gratifying. But we're looking for different things based on the target. Sometimes we're looking for color. Sometimes we're looking for texture. For the Terminator, we're looking at kind of what texture and morphologies pop out to you and what kind of diversity you see along the Terminator. You've heard, Victor especially make some comments about future impacts for exploration. So already I think that their descriptions in this first part of the flyby have told us something scientifically, but also about future surface missions.
Well, it was so interesting to hear Victor talking about he was imagining in his mind's eye being down on the surface and walking around. That was very cool to hear. And when we're thinking about targets, I know some of them are determined based on the launch day because that determines the lunar illumination. So the ones that we're looking at today, how and why were these selected?
Such a wonderful question. This really gets at at the heart of some of our really highest priority science questions. Illumination conditions is a big one, right? So of course we need the targets that we're interested on the lunar feature to be illuminated by the sun in order to view them, but the timing in which they see them during the flyby enables us to ask different questions. So you heard in the pre-flyby crew conference talking about, well, the same pair, Reed and Jeremy, will get to actually look at Glushko crater twice, and that looking at it from different illumination angles allows us to understand that feature better and connect color and albedo with topography and morphology. Then you have other craters where you want to look at it with the sun shining on it obliquely versus straight on, and that tells you something different about the scientific objective that drove the target being on the targeting plan in the first place.
We've talked a little bit with the viewers today about what the crew is able to capture in this short time frame of those craters in different lighting conditions could take years for something robotic to be able to do based on attitude maneuvers and where the sun is at. So can you just talk a little bit about the importance of having both the robotic operation and having the crew?
Absolutely. We definitely don't want to minimize the impact of orbiting spacecraft. Lunar Reconnaissance Orbiter is the one that's often referenced. Data from LRO and its payloads have really been instrumental in getting us, frankly, to this point for Artemis 2 and future missions. But the human experience, the crew observations that we've already been hearing about, it is such a perfect complement to the orbiting spacecraft data because they are able to have this unique perspective. They are far enough away where they can make these contextual observations. You've already heard it. How many times have we heard the crew and their science sit reps say, if I track this feature from all the way up here in the northern hemisphere down to the southern hemisphere, here are comparisons I can make. That right there is not something we had the ability to do with the Apollo missions, and it allows just literally in the blink of an eye to synthesize observations that it would take, a really significant effort to coordinate with different orbiting platforms, and they're making it like that.
Wow. It has been very, very exciting to hear all of their calls so far. And so I've heard they were able to capture every single target so far too. Is that correct?
I think that's correct. And I think it's important also to remember that, and I know the science team is anxiously awaiting this, we've been hearing from the crew members who are not at the forward windows, right? Those crew who are, really in the thick of the observations, they are recording minutes-long observations per target on their crew tablets. We will be getting those down starting here in a couple hours, and that's going to contain really meaty science information that we haven't heard live yet, and that's going to form the basis of my conversation with them tomorrow morning, where we're going to have a really deep dive into the science and absolutely nerd out about what they were able to do today. One of the most gratifying things for me today is hearing multiple crew members say, thank you for putting the discussion times in the targeting plan, because when we have had the ability to put multiple brains on a problem, we have elevated each other. And I'm looking forward to them, sleeping on it overnight and then us actually being able to really, truly have an elevated science discourse tomorrow.
Well, we're looking forward to it too, and I cannot wait to hear everything that you guys get to learn overnight from some of those audio recordings and just everything that they'll be able to share tomorrow. So, Kelsey, I know you are very busy. You've done a great job today, and thank you so much for joining us for this interview.
Thanks for having me. It's such an exciting day.
We are now expecting acquisition of signal in about 24 minutes. As a reminder, the Orion spacecraft has flown around the other side of the moon where they are out of contact with our deep space network. And we just heard confirmation here in Mission Control Houston that we have reached the closest point of our destination to the moon at MET 5 days, 25 minutes, and 34 seconds. And we anticipate the spacecraft's altitude is approximately 4,067 statute miles above the moon. We're continuing to track what the crew is doing while around the other side of the moon. They are continuing to take pictures of the of the moon, the Earth now out of sight. What they're in right now is a crew choice event. The science team has encouraged them to find interesting features on the surface, to take photos of those, and describe why they were interesting. Something else that they'll be looking toward next, just momentarily, will be impact flashes. They've got a few minutes allotted to look at the darkest portions of the moon. They're interested in short-lived flashes on the lunar surface because these would be caused by impact bombardment. After their impact flash targeting, the team is interested in if the crew can see lofted lunar dust. This would only be visible just before Earthrise. Now 20 minutes until we expect to regain communications with integrity and the astronauts for Artemis 2. We're live in Mission Control Houston at NASA's Johnson Space Center, but there's a team over 750 miles away also monitoring today's operations. And of course, just like us, they are in LOS, or loss of signal, with the spacecraft. This is LUCA, the Lunar Utilization Control Area, and it's joined by LISA, the Lander Engineering Support Area, which are twin control rooms that will support missions and operations in lunar orbit or on the moon's surface in real time at NASA's Marshall Space Flight Center in Huntsville, Alabama. The Luca and Lisa are right next to each other and just a short walk away from the SLS Engineering Support Center, which is used during launch, and the POIC, where science on the International Space Station is monitored. Luca primarily supports Artemis science operations, while Lisa will provide engineering support for landing astronauts on the moon. During this mission, Artemis 2, teams in the Luca will use the facility to support first-of-its-kind science operations to better understand the deep space effects of microgravity and radiation on the crew's physiology, immune systems, and ability to complete various tasks. The data from these science operations will inform future crewed flights to the moon. For future crewed missions to the moon, members of the NASA Human Landing System Mission Insights Support Team, a group of engineers, safety leads, flight operations experts, and technical authorities will work in the LISA. There, they will monitor lander systems in real time and be involved in key decision-making processes throughout the mission. Teams are using the LISA during Artemis 2 to observe mission operations and using the opportunity to inform and prepare for future crewed landings to the moon's surface. We now expect to regain communications with the astronauts aboard Orion in about 17 minutes. In the meantime, a little overview of how our crew members flying by the lunar far side at an altitude of between 4,000 and 9,000 miles are testing the capabilities of the Orion capsule. Artemis 2 visualization lead Ernie Wright has simulated views of the flyby using detailed topographic maps of the lunar terrain and photorealistic lighting scenarios. The Artemis 2 crew members have been using these visualizations to prepare for this historic mission, which is paving the way for future exploration of the moon's surface and beyond.
So the most exciting thing to me about Artemis 2 is just the
This live view in the Science Evaluation Room, or the SIR, here at Johnson Space Center in Houston, Texas, just down the hall from where we're at in the Artemis Mission Control Room. Teams continuing to monitor the flyby. The crew continues their observations of the moon, even though they are out of touch with Earth. We expect to hear from them in 12 minutes and 26 seconds. Again, this is approximately 40 minutes loss of signal while they are out of reach of the Deep Space Network. Right now, they are imaging, or attempting to image, lofted lunar dust. Throughout our coverage, we've talked a lot about the science and engineering behind today's lunar flyby, but we also spoke to the crew about what the moon means to them and how they see its place in human history.
I remember being a little
You're looking at a live view inside Artemis Mission Control here at Johnson Space Center in Houston, Texas. We are currently out of contact with the Artemis 2 crew. This was a planned, or not really a planned, but a tracked loss of signal that occurs when the crew flies behind the moon. We use the Deep Space Network to communicate with the crew, and when they are behind the moon, they are out of reach of that Deep Space Network. And when you consider our nonstop communications during the time in which we live, this is even more striking. For the Artemis 2 crew, they're only currently communicating with each other. Now, we expect to regain those communications in under 9 minutes from now, and we also are hopeful for a view of Earthrise. Despite being out of communication, the crew is continuously capturing imagery of their predetermined lunar targets. Now about 7 minutes, 25 seconds until we anticipate regaining communications with the Artemis 2 crew aboard Orion. In the meantime, Artemis 2 lunar science deputy lead Marie Henderson is trained these astronauts to capture and document their views of the lunar surface for all of us to enjoy back here on Earth.
I cannot wait to hear their voices.
We are now 4 minutes and 28 seconds until we expect to regain communications with the astronauts flying aboard Orion on the Artemis 2 mission. They are now flying behind the moon. While behind the moon at an MET, or mission elapsed time, of 5 days, 25 minutes, and 34 seconds, we expect this was the point in which they made their closest approach, 4,067 statute miles above the lunar surface. We're live in the Artemis Mission Control Room in Houston, but we are not the only room monitoring today's flyby. As you can see, this is the SIR, the Science Evaluation Room. It's in the same building and just down the hall. It's a multidisciplinary science team supporting the Artemis 2 crew in real time, including experts in lunar geology, impact cratering, volcanism, polar science, imaging, and visualization. You can see the SIR here. That's the Science Evaluation Room. It's embedded within Mission Control to provide science input during live operations like what we see today. But additionally, the Science Mission Operations Room is a back room that processes data, evaluates imagery, and supports rapid analysis. We also have our science officer, Kelsey Young, here on console today. She's serving as the primary interface between the science team and the flight controllers, ensuring science priorities are represented during mission execution. Coming up on 1 minute and 36 seconds until we contact Orion. Meanwhile, aboard the spacecraft, the crew has continued executing their lunar flyby tasks. As we discussed earlier today, these activities have been precisely timelined, and this is the fourth of 5 blocks of time during which the crew will be observing the moon from Orion's windows. At this time, pilot Victor Glover and mission specialist Christina Cook are observing the moon at windows 2 and 3. One crew member is in window 2 with a blue shroud over the window, taking photos and using an 80 to 400 millimeter zoom lens, while the other astronaut is in window 3 using their portable computing device, also known as a PCD, to make annotations. And both of those crew members are making audio recordings of what they are seeing. They are wearing headsets connected to their PCDs, and those audio recordings are being sent to the science team tonight. We are not hearing those live. However, we have been hearing quite a lot of great descriptions from the crew who have been serving as the support. Right now, the support team members are Reed Wiseman and Jeremy Hansen. Those team members are providing science sit reps, situation reports, calling down a few times each hour to discuss what they're observing. And even though we're out of contact with them right now, they are still conducting those science sit reps as they'll be available once they come back around the moon. The situation reports include how the crew is positioned, any missed targets, or anything unexpected they saw. They're also including lunar target descriptions, any hardware issues, and their emotions and reactions. Again, we are standing by to acquire signal from the Orion spacecraft. We're in the Artemis Mission Control Room at Johnson Space Center, getting our preliminary contact with Orion, that acquisition of signal coming after a 40-minute loss of signal, during which the crew was flying behind the moon, out of contact with anyone on Earth.
Folks, just returned. I'm only just now checking the status on the reacquisition of signal.
We are getting our first views from Orion after the loss of signal. Orion has come back around the other side of the moon, and that little crescent that you see is Earth, over 252,000 miles away. With this transit
We got it
complete,
back.
the flyby continues, but Orion has also technically begun its journey home.
We begin in orbit, and we have the Earth. Unfortunately, not Earthrise.
Right now, the crew are getting a few moments to enjoy and take photos of Earthrise for themselves, and we expect to contact them shortly. But we do have good signal coming from Orion.
But so we did not have communication at the time that Earth emerged from behind the moon. We missed that. Obviously, the astronauts caught it, but we had not reacquired signal in time, near as we can tell. So right now we have the distant crescent Earth, the same crescent that we saw the moon.
The Orion spacecraft, all 4 astronauts now back on the other side of the moon and in contact with us on Earth. Their tasks for lunar flyby did not stop as they went behind the moon and out of contact with us. We anticipate
I'm sorry,
that time
producer, are we do we have NASA live as well?
Flashes, short-lived flashes on the lunar surface, which would be caused by impact bombardment and potentially even lofted lunar dust. Right now, of course, they are getting pictures of Earthrise. After this target, they will get a short observation break. It's about an hour long, actually.
Houston, integrity, comm check.
Integrity, we have you loud and clear. How many?
Communications reestablished. That's a reassuring thing.
To hear from Earth again. To Asia, Africa, and Oceania, we are looking back at you. We hear you can look up and see the moon right now. We see you too. When we burned this burn towards the moon, I said that we do not leave Earth, but we choose it. And that is true. We will explore, we will build ships, we will visit again. We will construct science outposts, we will drive rovers, we will do radio astronomy, we will found companies, we will bolster industry, we will inspire. But ultimately, we will always choose Earth. We will always choose each other.
Integrity from Earth, our single system, fragile and interconnected. We copy. Those of us that can are looking back.
And unfortunately, I can't look back because we have an overcast sky here. We've had rain for hours and hours here in Florida. Not that we could see it anyway, because the moon would not be visible in the United States. Yeah, I guess our moderators might have taken a break too. All you fake moon mission people, you're not welcome here. Get the hell out.
Back with the astronauts aboard Orion. Christina Cook calling back to what she said just before translunar injection burn, that with this burn, we do not leave Earth, we choose it. The translunar injection burn served as not only what put them on this trajectory to fly around the moon, but what also committed them to splashing down in the Pacific Ocean on flight day 10. At this time, the crew is entering an observation break. We expect this to last about an hour. And it's probably a welcomed break following their very, very busy day taking pictures, making annotations, making audio recordings, and communicating all of the wonderful things that they are seeing on the moon. This observation break is also partially due to the fact that we will be entering an eclipse later. This will be the first solar eclipse that humans have seen from the moon. The astronauts will need to wear eclipse glasses for the first 2 minutes until the sun is completely covered by the moon, and then they have additional targets that the science team is hoping that they will photograph. We will have communications with them during that eclipse time frame. Because of that eclipse, Orion's attitude must be changed right now so that its solar arrays are in the sun. This will help it charge the batteries needed to power it through that eclipse time frame. This view on your screen is a visualization.
NC Davis, didn't know that. Christina Cook went to your high school, huh?
4,224 miles away from the moon, and that number will now continue to grow, while the number of distance from Earth, 252,699 miles, will continue to shrink all the way until our crew is back home.
So what we can anticipate for the next hour or so, the Orion is going to continue on its trajectory back towards Earth, and the moon is going to slip in behind it and eclipse the sun behind Orion. And it is our hope that we're going to get to see this, that they're actually going to show this this phenomenon for us. It should be very interesting. And then it's quite possible that we're going to see some stars, or they will anyway, and they'll be able to see some very spectacular stars with only Earth shine illuminating space around them and no sunlight. The stars should be amazing.
We have reestablished communications with the crew and the Orion spacecraft, now entering a little bit of a break while they are out of visibility, or the moon is out of their visibility. The spacecraft will be reoriented to view the moon ahead of an upcoming eclipse. This current attitude maneuver helps charge the solar arrays and batteries aboard Orion that will power them through the eclipse.
Oh, beautiful. Beautiful. That was earlier, by the way. They're now showing us that as Earth was setting behind the moon, as Orion had already entered into communications blackout. So he didn't get to see that live. Okay, so it was earlier in the stream. Okay, thank you. I appreciate that, producer. So you got an opportunity to see the Earth setting behind the moon. Apparently, that was happening in the stream.
Control, all of your flight controllers and your flight director have flipped their Artemis 2 patches around. We are earthbound and ready to bring you home.
That's great.
So we're waiting for the eclipse, but it's going to be an hour or so before
See the light of day as we
that happens, I believe. Yeah, a little less than an hour. By the way, I just pulled up that shot myself. Wow. Yeah, that's lovely.
A very special moment just now in mission control. Ahead of the crew's flight to Kennedy Space Center and during one of their last sims or simulations here, they visited the mission control team in Artemis Mission Control in Houston and brought us each a patch. Everyone in the flight control room has had these on their signifiers at their console. On one side of the patch that you've probably seen is the moon with the Earth behind it. Now that we've passed behind the moon and we are returning home, the flight control team has instructed everyone in the room to switch their patch around so that the Earth is closer and the moon is behind us. We are really looking forward to seeing the Artemis 2 crew, and the Capcom Jenny Gibbons did call that update up to the crew that the flight control team here has turned their patches around as was instructed by the crew during that last sim, and we are counting down the days until they get home. They are now 5 days, 1 hour, and 3 minutes mission elapsed time into the Artemis 2 mission.
So at this stage, about 55 minutes or so before we have the eclipse, they're going to reorient Orion to where it can face the moon again. They have completed extremely important milestone. The most challenging milestone, of course, yet to come, and that's reentry, and that's days away. That is most probably going to be the most problematic part of this mission, the one that has the most questions. But thus far, everything about this mission up to this point has gone as close to flawlessly as you can imagine. The whole toilet issue, though, it's a good thing. I mean, this is one of the reasons we have humans on this mission, is you can't test a toilet without humans to test it. And if you didn't have a properly functioning toilet, if you had a toilet breakdown on a Mars mission, that could kill a crew.
Artemis 2 science
Very
officer.
likely
Thanks for
kill a
being here,
crew.
Angela.
It is an honor to be here. What a day. Everyone's been buzzing. I can't contain myself. So it's been a really awesome day.
So you're sitting on console at the science console now. Have you been in the SIR earlier today?
There's a lot going on. So I went here first, then I'm going to go there after.
We moved it, and we are in bias tail to sun.
Thank you. Thank you.
Okay, Houston, you're coming in loud and clear, and copy. We're in bias tail to sun now.
You may notice that our producer changed the patch at the top of the stream to the return patch as they were describing it.
And integrity, just so you know.
Derek on top of things as usual.
We flipped our patches. Jeremy, we heard you call down, but you were clipped, and then we briefly lost comm. Glad we're back.
And Matt Professor's definitely right about that. There are loads of incredible images during the lunar flyby that we didn't see any of it. So we'll be seeing it soon.
That you, the MER, and Mission Control have flipped your patches around, and that side of the patch is getting to see the light of day. Thanks for sharing that with us.
Our pleasure.
Okay, Angela, so can you tell me a little bit about your role supporting Artemis 2 and the science preparation for the mission?
Yes, so I'm one of the 3 science officers. So Kelsey's been on console all day. I'll take over kind of closer to the end of the day. And then Trevor Graff is on the planning shift. And so it's the 3 of us in this 24-hour cycle supporting the mission. And so the science officer console is a brand new console to Mission Control. And it's not every day that you get a new discipline incorporated into Mission Control. So it's been such a significant milestone for us. And it's just a testament to like the commitment that the Flight Operations Directorate and NASA have, that they're going to be integrating.
Thank you so much, Eric. Yeah, in celebration of the real Fantastic Four. I agree with that. They are Fantastic Four.
Yeah, so I'm on the operations team, but I'm also on the training team. So all the incredible training and shout outs that you've gotten today, it warms my heart. It warms everybody's heart in the science evaluation room. I promise you that. But so all the classroom training, the field training, the mission simulations, right? We were a part of all of it, and that is what we did to get the crew to be. They are a part of the science team, and they are the forefront, that nice edge, and they're just been doing such a great job today.
I know. I imagine that you have to be pretty proud of them. Their reports have been fantastic. So I would like to know a little bit about how you have developed procedures for this crew. What kind of science activities are they carrying out inside the spacecraft?
Yeah, so the procedure development has been a unique challenge. I would say the exploration science that we're doing is inherently pretty flexible, and operations is, I'd say, inherently has more structure and rigidity. And so to marry the two and to operationalize the science that we want to get done has been a challenge. But I think we've been able to go through these processes and create good products at the end and have a good plan. And yeah, it's been really great. What was the second part of your question?
Just what kind of these science activities that they're performing, which of those have you really had a hand in?
Yeah, so a lot of the procedures help organize what the crew is doing in the cabin. And I know we've talked a lot about what they've been doing, and they've been doing a lot, and it's been a little dark, so I can re-explain what some of those things that they're doing. So the observation blocks are about an hour long, and the crew is organized, the 4 crew members are organized into 2 pairs of 2, the window team and the cabin team. And the lunar targeting package that you've been showing up and that the crew have on their handheld tablets is really the instructions for the window team. So the window team, the 2 crew members are looking out the window. One has the camera with the long lens, one has, they're just looking out the window with their unaided eye, and they're taking these detailed observations. And then halfway in that observation block, they do the window team position swap. So that's what Capcom's been calling out, and they'll switch positions, so each crew member has a chance to have that long lens. And then that's just what the window team is doing. There's also the cabin team, where they also have duties that they're doing. We're asking a lot of the crew in this time. And then the cabin team, they have the interior camera, and they're taking images inside the cabin. They're also supporting the window team, where, you've heard some call outs where looking out at the bright moon and then looking inside the dark cabin and looking at their LED screen is a lot. So the cabin team is also helping support, target, and guide the window team into specific targets on their plan. They're also helping call out these science situational reps. So they're looking out a different window and listening in to what the crew who are really down and in the science on the window team are doing, and they're giving us insight. And those recordings that the window team is doing are going to be uplinked or downlinked overnight, and we're going to be able to chew on that data. But yeah, they're helping. They're doing a lot, and so making sure we have a plan that's flexible, but also make sure that we check off all those boxes was really important.
So tell me a little bit more. You talked earlier about the analogs that the crew has done. What kind of analogs or environments were really useful for this?
Yeah, so for procedure
there were
challenges,
images
you
from
have
the
so many
Artemis
different
1, but this is going to be
environments that you
far
can do.
superior
You have
because the
classroom, like
astronauts
we
had
said, we
lots
have,
and lots of
you have the Orion
really
mock-up,
good
you have
cameras.
simulations,
We
and
just
for
haven't
use
seen
for
the images yet,
developing
but
the
once they
plan,
start
we
uploading
have
those
to do it in
things,
a
they're going to
tiered
look
approach, because
pretty
each of
cool.
those different analog environments helps us answer a slightly different question and has a little bit of a higher fidelity. So we would start with the classroom. So we would get we would just get into a classroom, we would put all the hardware on the table, and then we'd almost role play of like, you be Victor, you be Reed, you be Jeremy, and I'll be Christina, and like, let's just do the plan how we think we should do it, write that down, and then just keep iterating on that, and then
Integrity Houston for a tag up pre-forward link LOS in place of the Flight Director Conference.
Okay, Jenny, we're ready.
All right, crew, I'm going to roll through a couple of topics
Guys,
here.
the only thing that we're banning for is if somebody says that this stuff is fake.
For your toilet maintenance.
We don't have it. We have zero tolerance for that. And also, as far as complaining about the quality of the imagery and that sort of thing, I get it. It doesn't look good, but the reason is because the NASA Deep Space Network is outdated. It needs to be upgraded. They have good cameras, they have good transmitters on Orion, but unfortunately, the NASA Deep Space Network is lousy. And so as a result, the quality of the images that we get, and like I said, we understand the frustration with that, but it's just been hours and hours of those comments. We do know that that the images are substandard because of the NASA Deep Space Network and its limitations. We do know that they don't look that great, but enough's enough. We understand, or we've it's just, let's talk about something else. That's the main thing.
Okay, Houston, we copy all. Thanks for those words, Jenny.
All right, just a quick call up to the crew ahead of a forward link LOS, meaning that we won't be communicating with them, but we will be receiving their communications and data during that time frame. So Angela, we were talking about analog environments. You were telling me about the classroom and getting in there and pretending who's Victor, who's Reed. Tell me more about this.
Yeah, it works pretty well. So you're going to do the plan how you expect it to be, and then once we finalize that plan, we'll give it to a completely new group of people and have them practice it, and then they'll be like, these steps.
Well, they're always in danger, runner, just to be clear. There are a number of things that could be dangerous. If there's a solar storm, they'll have the danger of high radiation levels. Solar particle event could be very dangerous for them. They have a solar shelter to protect them, but they'll have to go through a lot of procedures to defend themselves from radiation, and then they'll be in the greatest risk when they're entering the atmosphere, because there is some question as to whether or not Orion's heat shield is 100% reliable. NASA has a good plan to make sure that it survives the re-entry, but there is some debate as to whether or not it's going to hold up. So that's going to be a tense moment, but that's days away.
Same target, but something that one person sees could be completely different than something another person notices. So we also know that Artemis 2 has traveled. They're now on their way home, but they traveled farther from the moon.
Okay, yeah, let's go ahead and mute NASA for the moment. Somebody just asked for a recap, and I'd be happy to provide that. So we're muting NASA, And in terms of a recap of what's gone on, we've watched the lunar flyby. We saw, I didn't see it. I had to back up to see it just because I took a bit of a break and napped for about half an hour. Ironically, I was listening to Apollo 13 while I was sleeping. So I just kind of had that in my ear while I was asleep. But anyway, Earth is just very close to the limb of the moon with these matching crescents, because the moon and the Earth are being similarly lit, of course, by the sun. So these narrow little crescent Earth and narrow little crescent moon with the Earth setting behind it. There we go. Actually, our fantastic producer is showing that to us at the moment. It's just a very, very beautiful shot. And so we got an opportunity to see that right before there was a loss of communications for 40 minutes while Orion was behind the moon. And now and of course, also Orion passed the Apollo 13 record and went further from Earth than any human rated vehicle ever has. So the 4 people on the Artemis 2 Orion have just set a record. It's an amazing thing. They've ventured further out into interplanetary space than any humans ever have. And then Earthrise, we didn't see that. Communication was not restored in time for Earthrise to become visible, apparently. I'm sure the astronauts got some good images of all of this. So that's probably pretty cool what they managed to see there. But in any event, now we are waiting for an eclipse as Artemis begins its journey back home. Its trajectory is taking it in such a way that the moon is going to slip in front of the sun. And so we're going to have an eclipse of the sun, and therefore the moon will be faintly illuminated by earth shine, but that's it. And in addition to that, we're also quite possibly, depending on how the cameras are set up and everything like that, but it's very possible that we may see some very spectacular stars. The astronauts definitely will. When the sun vanishes, when the sun disappears, when we have that eclipse take place, which, by the way, that eclipse is going to last for close to an hour, apparently. Simply because the moon is so much bigger in the astronaut's view compared to the size of the moon with a traditional eclipse. So there'll be a long period of time where the sun's light will be completely extinguished and there will just be nothing but stars. It could be a very interesting thing to see. Of course, as I said, also there'll also be earth shine, reflected sunlight from the earth, but that's very, very faint, of course, compared to sunlight. So it all depends on how the cameras are set up, but the astronauts definitely are going to see brilliant stars, far more brilliant probably than any stars they've ever seen, and probably more brilliant than most humans alive, well, almost all humans alive today have ever seen, given the fact that most of the Apollo astronauts are no longer alive. So all of this could be very interesting indeed. So we've still got, and by the way, that will conclude the broadcast when the eclipse is complete. So we've got a very exciting moment coming up. And again, that eclipse will be taking place in approximately 40 minutes' time. by the way, if you're interested, I did release a UFO video earlier today. The government is hiding 46 UFO secrets from us. That video is doing pretty well, actually, not necessarily in terms of numbers of views or anything like that. But it's 20,000 or so since I released it. But the view time is very good. People who are watching it are really liking it and watching for a very long time. So, and again, the reason it's 46 secrets is because Representative Paulina Luna in U.S. Congress sent a letter detailing 46 different pieces of UFO footage that the military supposedly has. And she is demanding the declassification of all 46. And by April the 14th is the deadline that's been set. So we'll see. But in any event, I've got details of all 46 incidents. Okay, well, Mad Professor, here's the situation that's going on with the heat shield and what NASA thinks went wrong with it before. They haven't really done any upgrades, just so you know. There's no real substantial changes that have been made to the heat shield. Had they done that, it would have delayed Artemis 2 probably for at least another year, if not longer. And NASA wasn't prepared to accept yet another delay, and neither is much of anybody else. And so what happened was originally the idea that, and I've had a hard time understanding this over time. It's taken a little bit of research on my part to finally get this right in my head. The original idea was to skip Orion multiple times off the atmosphere, and the idea was to bleed off speed bit by bit rather than plunge Orion into the atmosphere where the heat would increase rapidly. And so as a result of that, what happened is when they were skipping the tiles, there ended up being heat trapped in the tiles during those skip maneuvers. And so actually heat was building up more and more and more between every skip maneuver instead of the heat dropping down because of how the tiles were arranged in the heat shield. As a result, the shield actually sustained more damage during re-entry than if it had just plunged directly through the atmosphere. So the new plan pretty much does a much more direct re-entry into the atmosphere so that it doesn't suck up that kind of slow burn heat that damaged the tiles so much. But all the models, all the mathematical models and simulations show that things are going to work out just fine. But you don't know for sure until you actually do it. So there is an unanswered question there, and it's a little frightening.
As the distance from Earth shrinks, now 252,523 miles away.
And yeah, that's a good way to put it, Roland. Skip equals exponential damage. There's supposed to bleed off speed and reduced damage, it actually increased it. Thank you, Matt Professor.
Both of those moments came while Orion was flying in their loss of signal time frame behind the moon. The crew also set that new record today, beating the Apollo 13 record of distance from Earth. This is an animation or a visualization that you can track anytime, day or night, by visiting nasa.gov/track Artemis. This shows you how the spacecraft is positioned as well as their distance and velocity, now traveling 930 miles per hour. During this break in their time today, the crew is working on a couple of other tasks. Some of those include their National Geographic timeline test. National Geographic was selected through a competitive process by NASA to help tell the story of Artemis 2. So you've seen the crew with some GoPros inside the cabin, taking videos and pictures, and with other cameras as well. National Geographic plans to leverage its portfolio of media assets, including magazines, social and digital content, and television programming for engagement opportunities. Throughout the flight, the crew has been timelined a little bit each day to film from a shot list provided by National Geographic, and that includes their morning routine, talking with their families, exercising, and just their overall thoughts about the mission. And I cannot wait to see that footage.
It's the slingshot effect of the maneuver that allows them to pick up speed. They're actually using the moon's gravity to their advantage.
Teams on the ground reporting that the spacecraft is looking good and that the power aboard is good as well, all setting us up in a proper position before Eclipse.
And just so you know, I'm actually listening to the NASA feed directly, and the volume is very similar. I've got it turned up to max in my headphones, and it's not that loud. And we have approximately a half an hour before an eclipse takes place. Solar eclipse. Yes, that's his objective. He wants to try to land on the moon twice in 2028. Preferably once with Lunar Starship and once with Blue Moon, but twice with whatever vehicles are available. That's his goal. I'm almost positive that that's not going to happen, but great to have ambitious goals, I suppose.
Coverage for today. They will resume their flyby momentarily in about 30 minutes once they get into their observations during that solar eclipse. Now, the moon is our nearest celestial neighbor, orbiting Earth at less than 250,000 miles on average. When our astronauts venture there for future Artemis missions, they'll target landing sites near the lunar South Pole. There, ancient rocks, minerals, and trapped water ice will not only provide resources for human explorers, but they may also contain clues to the formation and evolution of our planet and the solar system. Let's learn more about the lunar South Pole with this video featuring Dr. Kelsey Young, Artemis Science Flight Operations Lead.
Okay, we're probably going to have some music here. So, yeah, we got music. Okay, so we can't have let me see if I can relate some of what they're telling you, though. Yeah, that's one thing that they're telling us about, and this was necessary, is that all the Apollo missions were in the same region of the moon. And the reason for that is it required the least amount of fuel, number one. They were really pushing it on fuel with the LEM and everything to get it down, get it back to rendezvous with the Orion, etc. Low lunar orbit was better around the equator. And of course, all the landings had to be executed on the day side of the moon, number one, to where you could see. But in addition to that, temperatures, it had to be daylight. It could never be night. But in addition to that, communications are only possible on the near side of the moon. Now we're going down to the lunar South Pole. Everything is radically different down there. There was a massive asteroid impact at the lunar South Pole that really changed the geology of that part of the moon as near as we can tell compared to the rest of the moon. In addition to that, because of the way the shadows, and there's been some debate over this lately, but the way the shadows work at the lunar South Pole, there are regions of these craters at the South Pole that never receive sunlight, and so therefore should have billions of tons of exploitable water ice. We do know that there is some water ice there. We've had a probe fly directly through it, and the way we did that is we had an Atlas rocket launch, and then the upper stage separated from the probe. The upper stage turned around and separated from the probe, and then the upper stage crashed into one of these dark craters, one of these shadowy craters, and kicked up a whole bunch of debris. And then the probe flew through that debris, and in the split second that passed before the probe smashed into the moon and was also destroyed, it analyzed the material that it was flying through and discovered that yes, indeed, there was water ice, that our guesses about there being water in these shaded areas were indeed correct. But we don't know how much water is there. But we know that it has to be there in at least some kind of considerable quantity for this to have taken place. A very ingenious way, by the way, to look for water on the surface of the moon without actually having to land on the surface of the moon. Instead, you just crash into the moon and create a puff of debris that the probe flies through. Like I say, an innovative way of doing it, and it did work. So that's going to make it's going to be very different.
And of course, throughout today, you've likely
that part of the moon is going to be very different compared to the areas that we looked, which was mostly equatorial. Yeah, I don't know. I think it's likely. I mean, Europe's working on putting one up right now. Also, Rocket Lab's working on one for orbiting repeater. SpaceX, Blue Origin is focusing a lot on that. So it may not be that long. I think it's possible that we'll have orbiting communications infrastructure set up around the moon before we even actually manage to land there. So yeah, M Brand, I think it's possible. Accuracy of trajectory now following the gravity assist. There'll probably be a little bit of a burn required to retune the trajectory to make sure that they re-enter properly. But just to be clear, there was a scheduled reorientation burn heading out after SLS delivered Orion onto the trajectory, and then the ICPS pushed it onto that TLI, translunar injection. They had a scheduled burn to make a course correction, which they thought they would need, but it turned out that they didn't. SLS had delivered them into the proper trajectory, bullseyeing it. I mean, it was really, really, really accurate. And so it's possible that after this free return trajectory, it's going to be quite accurate as well. But I'm pretty sure they're going to need at least some kind of burn in order to get into the proper reentry corridor. And of course, at this point, we also want to try to get them home fast, as rapidly as possible. Given that we have that toilet malfunction, it can't be all that comfortable for them. So we probably want to get them home as soon as we can. So yeah, we'll see what ends up happening, but that's what we got going right now. All right. Currently, make sure, we are approximately 23 minutes or so away from solar eclipse. Yeah, Roland, they did save some fuel because it wasn't necessary to do the burn. And Brand, thank you. I appreciate I really appreciate the super chat. Thank you very much. And yeah, it's any sort of communications repeater on the moon. It's complicated. I mean, Starlink satellites won't do it. Their transmitters don't have the range. Starlink transmitters are designed to go a few hundred kilometers, maybe a couple thousand, not 250,000 miles. So you got to, whatever you put into orbit around the moon has to have a pretty damn powerful transmitter. So yeah, a little over 20 minutes. This should be interesting. I have never seen a solar eclipse in space, not live. Yes, NASA already has the budget necessary for the next moon mission. So they definitely have the necessary money to get the job done. That's already funded. They actually have Artemis 3 through 5 funded at this point. The SLS rockets, the lunar landers, everything necessary to carry out. Well, Artemis 3 isn't going to land on the moon, but Artemis 4 and Artemis 5 are also funded.
Artemis 2. In this view on the screen, you can see the crew starting to even look through some photos that they may have captured today. We really look forward to sharing these photos with you as soon as we possibly can. And the best way to keep up with those is to follow NASA on social media. You can do so at NASA, and for this mission specifically, at NASA Artemis.
Yeah, I'm looking forward to seeing those photos too, guys. Why don't you send a few over? There should be some very spectacular stuff. Thanks, Trip. Yeah. Right now, they have it funded. Something. I wish I knew more about the difference, the advantages for low band and high frequency communications.
As they were, this is a tracked event that occurs at times, but they could still provide communications down here to us, and we are obviously still receiving their video and their data.
Yeah, Roland, don't worry. I've been posting about the Artemis mission regularly on my channel, just not necessarily videos, but just posts on my YouTube channel. And I've been posting photos on a pretty regular basis. So the moment we get some of these new high-res photos from Artemis, I'll definitely make sure to share them with all of you folks. That's that next big event that we're waiting for. Less than 20 minutes now, presumably. Yeah, here's the thing. I mean, Orion may not have to ever go to low lunar orbit. Orion was never really designed for those sorts of things. It's not an Apollo clone. It's more of an interplanetary ship designed to rendezvous with ships designed to land on various bodies. Orion originally, the first mission Orion was supposed to do was an asteroid rendezvous, not the moon. So it wasn't supposed to go into an orbit around a body with substantial gravity and then blast its way out. It's just supposed to approach an asteroid and capture it. Nick's Backyard, thank you very much. I appreciate it. I'm afraid I can't talk about the alien-human hybrid program. So yeah, Orion was under ideal circumstances anyway, was not supposed to have the delta V necessary to reach a low orbit. And the idea was the near rectilinear halo orbit or a higher orbit to rendezvous with the space station. Now that it's not doing that anymore, it's almost definitely going to be delivered to a lower orbit, but we'll see what ends up happening. But yeah, that's the problem. Orion, we keep changing the mission. And I have to admit, I'm not a big fan of it. I like the idea that we want to put a base on the moon soon. That's great. But I really think that it was always a better idea to put the majority of the responsibility for lunar operations on the lunar ship, lunar starship, Blue Moon, Alpaca, something along those lines. Make that ship responsible for the majority of the maneuvering, not Orion, because Orion was never really supposed to do that. Orion is supposed to carry the maximum number of crew members into cislunar space or into the vicinity of a destination. So it's going to be a little bit more difficult now to use Orion in those applications to bring it down to a lower altitude, to a lower orbit, although it almost certainly will, because they past Artemis 3, they're going to be using Centaur 5 upper stages instead of the ICPS for SLS, and Centaur 5 has 2 engines instead of 1 and bigger fuel tanks. So with those bigger fuel tanks, Orion should be able to enter into a more aggressive orbit than originally. Although Centaur 5 is a poor replacement for the exploration upper stage on the Block 1B version of SLS. It will be able to carry a couple extra tons, maybe 2, maybe 3 extra tons. Probably just 2, I would say. So, get Orion maybe to a little bit of a better orbit, that sort of thing. But it will not have the enormous performance improvements that the exploration upper stage would have given it. Once again, we are waiting for, and you can see it on the displayed anyway on the animation. The sun's getting closer and closer to the moon.
You can visit this for yourself at nasa.gov/track-Artemis, and you can watch as we continue to grow closer to Earth and farther away from the moon. It's all seemed to happen so fast so far, and we're coming up on splashdown now in 3 days, 23 hours and 31 minutes.
Orion has continued to slowly pull away from the moon. It's almost 5,000 miles away at this point. Speed is increased to 933 miles an hour, but still slowly picking up speed right now. And we're very close to that, to the moment of that eclipse. I hope that they're able to turn the ship around to where we can get a good view of that as it happens. We are, we're about 12 minutes away, roughly, from the moment of eclipse. And you can see right there as I mentioned before in this animation here, the sun is getting very close to the lunar horizon. So we should be getting an eclipse here pretty soon. And again, once the sun disappears, again, depending on how the cameras are set up, we might get a really good view of the stars. Or maybe not. I don't know. It all depends on how these cameras are set up. One thing for sure is the astronauts will be able to see it, and they'll probably photograph the hell out of it once they see it. Nope, as we've talked about that, there are no communications relay satellites behind the moon currently. I've heard that China has one, but China is not integrated into the NASA Deep Space Network. I think they're waiting for another antenna to pick up the communication. The Deep Space Network has a series of antennas that shift from responsibility from one antenna to another as the Earth rotates. So I think the reason they're showing an animation is because they're waiting for the antenna to pick up the next antenna to pick up the signal. That's what I'm hoping anyway. I'm hoping that there's not a problem with the communications or the cameras. They're still reorienting Orion to face the moon and the sun at an appropriate time for this eclipse. Yeah, man, Professor, I'm uneasy too. I mean, I feel pretty confident that they have a good plan. But, then again, you don't know until you actually do it. So there was an argument made that we should test it, do Artemis 2 like another Artemis 1, test it with nobody on board just to be safe. If we had done that, it really would have put the entire program behind, because we had to test this spacecraft with people on board. And we see one of the reasons, just the toilet is one reason right there. Without people on board, we never would have known that the toilet was having all of these problems. And wastewater dumps are pretty damned important. We need to, whatever issues came up with it, we need to make sure that those get fixed in the future. I mean, yeah, you can store it and stuff like that, but if you're talking about longer duration missions, that's going to be a real problem, because the life support systems on Orion recycles a lot of this stuff.
Forward link LOS with the spacecraft. We're not able to send commands or communications to them right now. However, they could send them to us, and we do get spacecraft data. This is tracked as we are on the Deep Space Network. This is the network that we use to communicate with the spacecraft now that we are so far from Earth, over 252,000 miles.
Okay, apparently because they're pointing at us, that's why.
Coverage. The crew still have a very important and very exciting flyby milestone coming up when they will see a solar eclipse from the moon, the first humans to ever do so.
So let's hope that we can get a signal from Artemis. Hopefully they haven't forgotten about us.
Is space weather. So since the Apollo 16 and 17 missions, there were some solar eruptions near that time frame that could have been dangerous to our explorers. Over those 50 years since those storms, the data, technology, and resources available to NASA have improved, enabling advancements towards space weather forecasts and astronaut protection, which is key to NASA's Artemis program to return astronauts to the moon.
Across our planet.
Okay, we have music there, so we've had to cut that out real quick. So yeah, a point was made by Teefs, and he's not wrong that a longer distance was traveled, and the reason a longer distance was traveled is because Apollo 8, if that's what he's referring to, orbited the moon several times. Now, it wasn't 55 years ago. That, in any event, most of the Apollo missions traveled that far, and that's because they orbited the moon several times in low lunar orbit. This was a simple free return trajectory orbit, just a single orbit and come back. So that's all there is to it. It was just a different mission configuration. Had they decided to put Orion into a lower orbit and orbited the moon for a while and brought it back that way, they probably could have. They just didn't. So once again, if we're talking about, however, the distance from, if we're talking about the difference from Earth to the moon, or rather the distance from Artemis to the moon, this mission traveled a bit further. And yes, it is in deep space. It's in interplanetary space, actually. Oh, here we go.
Hour and 54 minutes since we launched.
All right, so we've got a live view, but they're not showing us the sun. They have lots of cameras on this thing. So hopefully they'll bring up the camera that's oriented properly.
Change the attitude of the spacecraft to help charge the batteries aboard. We use the solar arrays to gather energy from the sun and store it in the batteries. That way, when we are not in the sunlight, we have those batteries to continue powering Orion. Now we're doing so because the Artemis astronauts are about to experience a solar eclipse from their capsule. And this is a solar eclipse that no one else on Earth will experience. This eclipse is about 54
Now, this could also be interesting.
A lot like a total solar eclipse on Earth, except the moon is going to be huge compared to the sun. Unlike when you watch one on Earth and the moon and the sun appear about
This could also be interesting. I'm wondering if they're going to have the capsule and the cameras pointing away from the sun and away from the moon. And if that happens, if we get an eclipse under those circumstances, then we may see stars pop big time.
The moon covers and uncovers the sun, which is before and after totality. So, much like us on Earth, they will have eclipse glasses so they can safely view that portion. The astronauts will also be using cameras to capture images.
I don't know. I'm interested to see how they're going to orient this. Okay, so they're orienting it. Looks like they're definitely pointing it
Saturn, Mars, and Mercury
towards the sun.
They can identify what part of the sky they're looking at. This can help train future Artemis astronauts on what part of the sky they're seeing.
Oh, wow. Okay. Maybe. What are we going to get here?
Instruments for navigation and orientation.
Yep, it looks like they're going to take a shot at this. Looks like they're going to try to put this on camp. Yep, there it is. You can just see the moon or the sun above the limb of the moon, I believe. Oh, my God. Yeah, we're going to see how this works, but this could be really spectacular.
Confirmation from teams here in the ground that we have reached the eclipse attitude, meaning Orion is in the proper position to observe it.
Okay. So we are pointed in the right direction, folks. Let's see what we see. This could be interesting.
The astronauts' break during this observation period is now over, and we are resuming their lunar flyby observations. The first of these is sunset. This is the solar corona that we'll be looking for. It's the outer atmosphere of the sun. The science team is also interested in if the astronauts can see polar plumes. These are thin streamers that project from the sun's north and south poles. Additionally, they're interested in seeing if the crew can witness coronal loops. These are arcs close to the sun's surface. And something else that we've previously mentioned is lunar dust. This is dust from the moon that is lofted above the lunar surface and illuminated by the sun. It was reported visible by Apollo astronauts.
We're approximately 2 minutes away from the sun disappearing from view. This could be very interesting. We'll see. I don't know. Mad Professor, according to them, no, this is not a common thing. I don't know. We'll see. We're about 1 minute away, supposedly. Again, this is just an approximation, but you can see the Orion is barely illuminated at this point. There it goes. Just glowing over the horizon now. Oh, come on. Why did you give us an animation, for God's sake? There we go. Wow.
You're getting a live look from Orion as the crew observes a solar eclipse from the moon.
We're just waiting to see what
Eclipse is
happens when
only
it
visible to the crew
disappears.
on the spacecraft. It's not visible to anybody on Earth. The science team is interested in several different targets for them during this time frame. And we're personally looking forward to getting those images as well. Again, during the beginning portion of this eclipse, the astronauts will need to use eclipse glasses just like we do from Earth to safely view it. Once the moon has completely covered the sun, they'll be able to take off those glasses for almost an hour. Totality on Earth during a solar eclipse lasts only a couple of minutes. So this opportunity gives them a chance to look out into deep space and to look into see if there are other planets nearby.
Okay. So we're waiting for... We just have a little bit of a glow left now. Be interested to see if we can see anything aside from utter blackness. Depends on how the cameras work. Because the stars should be amazing. But then again, amazing only if we were looking at them with our naked eyes. I'm really not sure how well these cameras will pick them up. Fingers crossed.
What you're seeing right now is the solar corona. That's the outer atmosphere of the sun. And the science team is very interested in any images that the crew can capture of this. They're hoping that they'll take pictures and describe the visibility, color, and shape of the solar corona as a whole and its substructures, those plumes and streamers.
Science integrity in the blind. This is continues to be unreal. The sun has gone behind the moon, and the corona is still visible, and it's bright, and it creates a halo almost around the entire moon. But when you get to the Earth side, the Earth shine is already shown. I mean, almost seconds after the sun set behind the moon, you could see Earth shine. The Earth is so bright out there, and the moon is just hanging in front of us. This black orb out in front of us, in front of now, not the blackness, but the gray that blends and drifts into the blackness. We can see stars and the planets behind it. And Christina is in window 1, Reed is in window 2 with the long lens, and Jeremy is describing it in window 3. And it is quite an impressive sight. You can still see the horizon lit up brighter where the sun set on that side of the moon. It is bright, and Earthshine is very distinct, and it creates quite an impressive visual illusion. Wow, it's amazing.
Yeah, regrettably, these cameras don't seem to be able to pick any of that up. They'll definitely be able to photograph what he's describing. And also there's Earthshine shining into the Orion capsule too, because of course Earth is behind us from this perspective that we're looking at right now. I'm just waiting for the corona to disappear and see whether or not the stars take over if the camera adjusts to the lack of light. Yeah, let's hope so. Hopefully they'll make an adjustment in the cameras to allow us to see more stars when there's no longer a corona to look at.
Mission. Orion is now 252,125 miles away from us all on Earth. We're here in the Artemis mission control room in Houston, Texas. And what you had just before we lost that view quickly was the corona of the sun peeking around the moon as the astronauts are entering a solar eclipse for this portion of the lunar flyby. We're now over 5,500 statute miles from the moon. That closest approach today was just about 4,067 statute miles away. And teams in the room beginning to get a little busier and filter in and out as we are stepping through a handover. The Orbit 1 team is handing over to Orbit 2, who will continue monitoring lunar flyby and all of the systems aboard the Orion spacecraft.
Well, it's because we've circled around the moon and the Earth is behind us from that perspective. The Orion is now between the moon and the Earth. Right. Yeah. Hopefully they're going to adjust these cameras and give us a view of stars. We'll see. It's hard to say if these cameras are capable of it. Like I say, eventually we're going to see it one way or the other. Eventually we will see all this, that they'll definitely capture all of that. Because as strange as it may sound, you don't get to see stars very often when you're in space because the sun blots them out. And the sun is always out unless there's something in the way, like a planet or the moon. And if you're flying interplanetary between the Earth and the moon, 99% of the time, the sun's out and messing with your view. Let's see. Boy, I'll tell you, I'm not interested in watching Mission Control any longer. But they may be doing another transition of signal. Okay, so it's vanished, but unfortunately, I'm not seeing any stars. Just seeing utter blackness, sadly. We'll see. Maybe they can make an adjustment to it.
You're getting your last few views of the solar corona as the moon begins to take center stage and completely cover the sun. If you see that bright dot up near the top left of your screen, we think right now that that may be a part of the spacecraft, but we'll be sure to correct that if we end up figuring out later that it is something else entirely.
And of course, the moon should be obscuring a lot.
It has been an absolute honor to join you here today for the lunar flyby of Artemis 2, the first time humans have flown by the moon in over 50 years. I'm Leah Cheshire Mustachio, and I'm excited now to hand over the
game is shifting around in the windows, and we are transferring settings on a camera to pick up Earthshine. And it is amazing. The brightness where the sunset is still bright. I think there may still be corona visible, but that part of the horizon is still lit brighter, and you still have a distinct Earthshine.
I don't think it's very likely at all, Mad Professor. I mean, once again, all Lunar Starship has to do is just be functional enough to get to orbit and then dock. But I don't know if we're going to be in a position by next year to where we're going to be comfortable enough for Starship to dock with Orion, especially with people on board. I don't know. But yeah, that's unfortunate. Just utter blackness. The cameras just are not
don't talk when the crew is
adjusted
talking, so
properly.
I wanted to give Victor Glover a moment there to call down what he was seeing now that the moon is covering the sun. A really amazing time during today's lunar flyby. Again, thank you so much for letting us help tell this story today. I am Leah Cheshire Mustachio, handing it over to my friend Anna Schneider at the PAO console as the Orbit 2 team comes to join us. So thank you so much, and I hope you all enjoy tonight. Anna, you can take it away.
Thank you so much, Leah, and it's been a joy listening to your coverage over the last several hours. So as you mentioned, the Orbit 2 team of flight controllers is currently making their way on console and completing a shift handover with the Orbit 1 team of flight controllers. The Orbit 2 team tonight will be led by Flight Director Diane Daly, and she is currently handing over with the Orbit 1 flight director there on your screen, who was Flight Director Jeff Radigan. The Artemis 2 crew currently on board the Orion spacecraft. It continues to observe the eclipse that they are witnessing. There's about 43 minutes remaining in that eclipse period.
Well, I'm afraid I'm about to guess that we are not going to see anything else except utter blackness from the cameras. I was hoping, let's see. Nope. It's weird that we have that light source in the upper kind of left.
Control. You are currently seeing a live view of the solar array wing cameras on the Orion spacecraft. We spoke with our science team, and they did determine that that dot in the distance is Venus.
Oh my God, Venus. Then why is it that dim? I guess just the cameras are not very well set up for that sort of thing. Beautiful. Yeah, I don't think the Blue Moon Mark II is going to be ready for a rendezvous in orbit either, but maybe it might be ready. Yeah, so I mean, we can kind of see stars, but man, we should be able to see them so much better than that. Clearly these cameras are not designed for that. Yeah, BJ Turon, I don't know if I'm convinced that that's Venus either. Well, let's see. I wonder where Venus is right now relative to, I don't know.
Let's see, not a huge change in here, just an update. The camera settings for Earthshine are challenging. This one's challenging to capture. What we're seeing, we're just not picking up on the cameras. And after all of the amazing sights that we saw earlier, we just went sci-fi. This has, it just looks unreal. You can see the surface of the moon between, I guess, the Earthshine. I guess Earthshine. You can actually see a majority of the moon. It is the strangest looking thing that you can see so much on the surface.
Hello.
This is Artemis Mission Control. You were just hearing some communications called down from NASA astronaut Victor Glover, currently on board the Orion spacecraft. They are currently observing an eclipse. There's about 39 minutes remaining in that eclipse period.
Currently, we are in a forward link LOS, or loss of signal, so the crew can communicate down with...
He's seen 2 meteors, science.
What did he
So we
say?
are in a forward link loss of signal. We do expect to regain signal in about 3 minutes, and at that point, then the ground can communicate back up to the crew on board the Orion spacecraft. In the meantime, the crew can continue to communicate down to the ground. The ground is just unable to respond, so they are continuing to provide some science observations during this eclipse period.
Mad Professor, in my opinion, the first space station to replace ISS will be the Star Lab. Star Lab has passed a number of its design reviews already, and the mock-up is in the astronaut training room. Although they have other plans to put these replacement modules adding on to the existing ISS. So I don't know. There's a lot of confusion as to what they're going to do to replace the ISS, but I feel that Starlab is going to be the replacement. So in any event, yeah, I don't know. 2 meteor. I mean, that's very bizarre. There should be no meteors at all visible to these folks unless they saw them going through Earth's atmosphere. But at that huge distance, I can't imagine that they would have, unless they think they saw meteor impacts on the surface of the moon, that they saw some brief flashes of meteors hitting the lunar surface. That's possible, given the fact that there's no sunlight at all, that any little flash on the surface of the moon from a meteor impact might be visible. That would be crazy. But yeah, I'm very intrigued also as to how little they're saying right now. It makes me wonder, are they seeing something and they're hesitant to say anything until they get a better idea of what they're seeing? Once again, Mission Control cannot talk to them. Okay, I was almost ready to sign off, but actually, Mission Control can't talk to them. All we're going to get is communications from Orion. And that means that if they feel like saying something about what they're seeing, they're just going to say it. If they're seeing something really bizarre, they're just going to say it, and Mission Control will be unable to tell them to stop or to not. I don't know. We could have something interesting happening here. So I think we're going to wait for just a couple. I mean, once again, I don't want to get caught up in a conspiracy here, but I wonder what. I mean, it's very interesting that the feed's been cut. We can't. All we can, we can't see that blackness and that twinkling thing that was supposed to be Venus. Stars don't twinkle in space. But then again, I don't know. We could barely see any stars at all because of those cameras. So I'm not sure what to make of that. Yeah, let me see what he said. All right, I'm listening again. I'm listening to what they just said. Give us a moment. Might take a couple of minutes for me to pick up what they're saying. I rewound about 8 minutes or so.
Science, integrity, and the blind. The glow around the moon is beginning to become a little bit more even. It's not so much distinct just where the sun set on the moon's horizon as we're flying through this trajectory, and then the sun's going to come up out of the other side. I think it's we're starting to see the glow around the moon get balanced out. I still see Earth shine, and the Earth is very bright out there. Still quite an unreal sight.
Integrity Houston, we have that sit rep loud and clear, and we are back with you. How do you hear me?
Hey Jenny, we have you loud and clear, thanks.
Copy. Victor, we're handing you over to Science for some critical questions. Thanks for your reports. Integrity Science, we were loving your science sit reps in the blind, and it should come as no surprise that we have a number of follow-up questions. First, you mentioned Reed observing meteors. Can you speak to that? Were you referring to comets or impact flashes or something else?
Yeah, there was a little bit of giddiness. We have seen 3 impact flashes so far. I saw 2, and Jeremy has seen 1. Undoubtedly, Jeremy saw 2, so that's 4 total. Undoubtedly, quick impact flashes. It was not sun glint off of particulate from the thrusters or the purge tanks. It was definitely impact flashes on the moon. And Jeremy just saw another one. Go ahead with your next question.
Amazing news. I literally just looked over at the SIR and they were jumping up and down literally. If you could describe where on the moon you saw them, please.
So they've all been either on or a bit south of the equator and on the Earth side of the moon. Stand by. All right, so Jeremy has seen them kind of on and south of the equator, kind of spread across the moon, and mine were both south of the equator and just a little bit left of center of the moon.
Incredible news, Reed, and reminder, we have citizen scientists here on Earth looking for impact flashes, so hearing you saw them on the near side means that people saw them too.
Okay, guys, I am still trying to.
This is Artemis Mission Control. We have regained that signal, so the team here in Mission Control was able to call back up to the crew on board the Orion spacecraft as they continue their lunar flyby. Specifically, they are now in that eclipse period. So the science team here in Mission Control was able to ask some questions about some of the situational reports they were providing during that loss of signal. Specifically, they were interested in some of the meteors that they mentioned seeing and those impact flashes, and they did provide confirmation that they did see
at least 4 impact flashes during that lost signal.
Are you still with us, Houston, or do we lose you?
Integrity, I hear you loud and clear. How do you hear me?
Okay, we got you loud and clear. One of the other things I wanted to describe, which was surprising to me, but the entire moon is lit up. It's glowing behind the entire moon. I thought it would look, dark against the black sky or deep space, but the sun is lighting up the entire limb of the moon. You can see the entire perimeter of it, and even now with the sun far behind the moon, you can still make out little bits of topography around the entire limb, just bumps as you go around it. And there's about the glow around the moon, once your eyes adjust, is easily 10 widths or diameters of the sun around the entire moon.
Four impact flashes.
Incredible
That's
to hear, Jeremy.
shocking.
Were you able to actually pick out any discrete features on the lunar surface? And if so, how do they look different than when you observe them in solar illumination?
No, we really haven't been able to identify features on the lunar surface yet. We just see, the topography on the limb. For the Earth glow, we're about a quarter moon, waxing quarter moon, if you will, from the Earth glow perspective, and it's just at a very, just the sight angle. I'm just not able to tell what I'm looking at yet in the Earth glow.
Understood. Thanks, Jeremy.
It wouldn't actually, a normal meteor impact would probably create a bright enough flash to be visible from this distance.
Most of it disappeared behind the moon.
But because we see those kinds of flashes from the surface of the moon through earthbound telescopes, but it's to see 4 of those flashes in quick succession. That's bizarre.
5 o'clock position, there was just this constant stream. It would change in intensity.
That's too many meteor impacts in too short of a time. It's highly unlikely
I only saw 1 plume.
that you would see 4 separate meteor impacts on the lunar surface in just a couple of minutes.
Thanks, Jeremy, and a heads up that we, calculated here on the ground about how long you could see the corona for, and we expect it to start to appear again in the next 11
And
minutes.
also, it's worth mentioning, guys, that Apollo astronauts never saw this. Apollo astronauts have never mentioned seeing a meteor impact ever. And to see 4
Integrity Houston, we're
in
following
quick
along as
succession
well.
like
That was
that.
outstanding. If you haven't already, just reminding you to swap positions at the windows. And that brief LOS we had previously was due to a data
BJ,
change.
yeah, I think that's a very compelling theory. Radiation, well, not just radiation. There's a lot of things that could be affecting eyesight, causing flashes. Another thing that's really, really suspicious, though, is the fact that they haven't brought back a live shot at all. We're just seeing an animated visualization this whole damn time. This is the longest stretch that they've done this during the entire broadcast. We get these impacts supposedly,
one more request for you,
and
while it's still fresh
then
in your
NASA
mind,
cuts
any
the feed.
annotations or sketches you want to make of what you're seeing either around the corona structures you just mentioned or even on Earthshine would be so appreciated.
And where did they see the impacts? Were they clustered in a single area, or were they scattered?
Okay, Kelsey, it's going to be pretty hard to go look at a PCD right now, but we'll definitely try and annotate what we saw.
And if the annotations come in the next block where you're cleaning up your documentation, that sounds like a good plan to me.
They haven't brought back a live feed at all. Not once.
This is Artemis Mission Control. On the bottom right corner of your screen, you can see a view of the Science Officer console here in Mission Control. And we've been hearing that communication between the Science Officer. The Orbit 1 Science Officer is Kelsey Young, and she's been asking questions to the crew, specifically CSA astronaut Jeremy Hansen, based on the observations they've been making during this eclipse period. And then in the upper left-hand corner of your screen, you can see a view of the Artemis Real-Time Orbit website, which provides updates on the velocity and the distance from Earth and the Moon of the Orion spacecraft as it continues to make its way back to Earth. The distance from the Moon will continue to increase at this point. So right now, Orion and its crew are about 6,300 miles away from the Moon and about 251,000 miles away from the Earth.
Yeah, guys, this shouldn't have happened. 4 separate meteor impacts should not have happened in a space of a few minutes. Meteors don't hit the surface of the moon that often. They just don't. This is a really bizarre coincidence to have seen something like that. Reflecting off of what? Off the window? But what? I know. Yeah. But is there light? Well, there's earth shine hitting the surface of the moon. I'm talking the producer, by the way, guys. There's earth shine hitting the surface of the moon, but not bright light. I can't imagine there's anything reflective. Reflective enough to be seen from thousands of kilometers away. Presumably with the naked eye. I mean, I don't think this is any kind of, they didn't have any. Wow. How we went through all of this, everything going exactly as expected. And then all of a sudden, as everything seemed close to wrapping up, we get this. And again, we didn't see it. I'm sure hopefully there's something recorded, and they better show it to us, damn it. They better show us what they recorded. But 4 separate meteor impacts on the lunar surface is just a bizarre phenomenon. Yeah, Earth telescopes might have seen these as well because presumably they had the moon under observation. It'd be interesting to see what they show. Wow. This is really interesting. Yeah, well, how does he know the flashes came from impacts? It's the only thing that...
window teams are, Christina is supporting, and also Xena in window 1. Jeremy's got the long lens in window 2, and the short lens in window 2. And Reed is in window 3, and he has started recordings and is set up to see Corona.
Great sit rep, Victor. That sounds like a good config, and we're showing coronal effects start to appear on your video camera. So in the next few minutes, we should start to hear your observations.
finally back.
This
No,
is Artemis
only
Mission Control. We
briefly.
just heard the crew call down to the team here in Houston, reporting that they have swapped out who is in the windows for the final portion of the lunar flyby. So Christina Cook is in window 1, with Jeremy Hansen in window 2 and Reed in window 3. Reed is focusing on observing corona, which is the solar corona, which is the sun's outermost atmosphere. There is about 18 minutes remaining in the eclipse period.
Science and Houston integrity. I know this observation won't be of any scientific value, but I'm really glad we launched on April 1st because humans probably have not evolved to see what we're seeing. It is truly hard to describe. It is amazing.
Amazing. Thank you, Victor.
And just one more logistics note, we have gone as dark as we can in the cabin. We have turned the DUs all the way as dim as they can go, so you can't see anything on the screens. Every bit of light in the cabin affects the view. You're definitely seeing the brightness go closer. It's definitely brighter on the Earth-shine side, and so we're expecting to see some corona here soon.
We copy all. Excited for what you see next.
Yeah, if there's anything glowing or if it's anything geology based, they should only have they should have seen them for far longer than just brief flashes.
I'm not sure if we talked much about the star field, but we've got lots of stars. You've got the nice glow around the moon, but right off the well, we're upside down now, but from upside down 4 o'clock, right off the edge of the moon, looks like a planet. That line of planets. There's something a moon diameter to the left and something right off the limb of the moon to the right, and then something orange. It looks orange to the right of that, about half the moon diameter. So, but anyway, there are definitely stars. I think some of those planets that you said we might see, we're seeing. And so in unreal view, yeah, the moon in the foreground is one of the darkest things we see out the window, and now it's deep space behind it is kind of dark blue like it looks from Earth, but we can also still see stars. It's quite a wicked view.
Victor,
Mike is doing the best job, and I'm not going to try to add on to what he's doing. It's indescribable. No matter how long we look at this, our brains are not processing this image in front of us. It is absolutely spectacular, surreal. There's no adjectives. I'm going to need to invent some new ones to describe what we are looking at out this window.
This is just absolutely beautiful and inspiring to hear.
Does anybody
Victor,
see something
what
orange?
you're seeing is Saturn and Mars. That reddish object is likely Mars. Good opportunity to look to the future of where we're going.
What are we seeing? Okay, well, we've got the blackness now, and I am seeing. Okay, I need to turn some lights off. Sorry, folks, I'm turning some lights off here.
Okay, and from this vantage point, the 4 o'clock on the Earthshine side is definitely getting brighter, still no coronal structure.
Houston copies.
We aren't able to distinguish which Mare is, but we can clearly see Mare in the Earthshine.
We copy.
You see an orange glow in the center
This is Artemis Mission Control in Houston,
of the
Texas.
blackness.
We have not seen an impact.
Now, that could be some sort of radiation, because we saw
Sounds unlucky, but
something similar
so we'll take it.
on Jared Isaacman's mission into the Van Allen belt. So that could be what this orangish glow is that was at the center of this
Amazing.
of the live view. But yeah, those four impacts, I'll tell you, that's weird. That's, I don't know. I don't know what to make of it. It's very unlikely that we would have four meteor impacts on the lunar surface in quick succession like that.
Neighborhood, you should see Saturn setting behind the moon right now.
We do. We've been watching it track close to the horizon, and it's right tangential to the moon at this moment.
And they're not showing anything. They continue to just cut off the live feed almost this entire time. Why the hell are they doing that?
This is Artemis Mission Control in Houston, Texas. We are currently 5 days, 2 hours, and 44 minutes into the Artemis 2 mission. And we have about 11 minutes remaining in the Eclipse at the latter half of the lunar flyby that the Artemis 2 crew is experiencing on board the Orion spacecraft. We've received several different call downs from the crew and questions up from the science officer here in Mission Control. One of the things that they said that they were able to see is Mars off in the distance, and then the science team also confirmed that they should be seeing Saturn setting behind the moon.
They just saw four in quick succession.
Several different impact flashes, and these are flashes of lights from meteorites striking the surface.
Four in quick succession.
They've also mentioned the solar corona, which is the sun's outermost atmosphere. Here in Mission Control Houston,
there's a fifth
teams
impact.
Have officially completed their handover. So the Orbit 2 team is now leading.
There's a fifth impact
here in Mission Control, and that is being led by Flight Director Diane Daly, and the Capcom here in Mission Control will be Tess Caswell. And you can see there on your screen on the right-hand side is the Flight Director console, and Diane Daly is in the far right of that screen, and Tess Caswell, the Capcom or capsule communicator, is in the far left hand of that screen.
Yeah, the light is continuing to grow in intensity. At about the 4 o'clock position on the, about the 8 o'clock position on the Earthshine side, Saturn has set. Mars is tracking towards the moon's horizon.
Integrity Science, we copy, and we're starting to see it on the vehicle stream. Looking forward to any coronal observations you can share with us.
This is Artemis Mission Control. That view you're seeing on your screen is coming from the solar array wing cameras outside of the Orion spacecraft. And you can see the light starting to come into view as the solar eclipse period is starting to end.
Integrity, still no coronal structure at this time, just continue to grow in intensity.
Lost my feed mysteriously in the middle of all this bizarreness.
Copy,
And now the
Victor.
sun is beginning to emerge from the other side.
You still should have several minutes before the eclipse classes need to go on, and we can send you up a reminder when you're getting close to take your eyes
This
away
whole
from
thing
the
is
D5
just very strange.
viewfinder. But you should be good for several more minutes.
Very strange indeed.
Copy, thank you, and yes, please send up the reminder. Thank you. Okay, we all think we're starting to see something. I believe the most popular term is baby hair. As the light grows in intensity and the horizon on this side becomes very distinct. You can still see Earth shine, even though the sun's brightness is definitely growing in intensity.
Love the description, Victor. I'm sure as the next couple minutes progress, more of those structures will continue to pop out.
This is Artemis Mission Control in Houston, Texas. The Artemis 2 astronauts on board the Orion spacecraft are currently observing an eclipse. And to the crew on board the spacecraft, the eclipse looks much like a total solar eclipse here on Earth, except the moon is much larger compared to the sun, unlike a terrestrial solar eclipse where the moon and the sun appear the same size in the sky.
We are definitely starting to see structure. That baby hair is rapidly growing out toward the 9 o'clock and the 8 o'clock. It's almost as if it were reaching out for Venus or for the Earth. If you've ever seen the spotlight off the top of the Luxor at night in Las Vegas, this looks like what that wants to be when it grows up.
Integrity Science, glad to hear you're following your training of tell it like you see it.
So far, it's pretty symmetrical. There are 2 or 3 streamers that are growing in intensity and in magnitude, and it's slowly starting to widen, starting to spread out across the horizon. Pretty amazing view.
And Integrity Houston, great words.
Reminder for you, we are approaching the brightness level at which you should no longer be using the viewfinder on the D5.
Integrity copies, and thanks for the heads up.
Yeah, we don't want astronauts to get blinded.
This is Artemis Mission Control.
And I think we're seeing some directionality. Some of it is going in different directions because it appears to be moving and combining and recombining as it it's pointing in different directions, and some of it appears to be going like down toward the south pole of the moon, but it's and then coming back together and going out towards Venus and the Earth. And depending on how I stare at it, it looks like one large structure, but then it definitely has wisps, and you can see 3 or 4 structures inside of it. It's like watching a flame. It's like looking at a flame, and stand by. And so it has some inherent movement. Now there's a very bright spot. There's a very bright spot in the center of it. There's a towering light of. There's a towering light, and then there were like
there it goes.
Streamers that were going 30 degrees.
The sun is just emerged.
Now it is just extremely bright.
Houston, copies all.
And it's beginning to illuminate the Orion spacecraft again.
And we copied all. We wanted to remind you at this point on the Eclipse glasses. Should be about time for those.
All right, folks. We are BJ Tieron. Thank you so much. I really appreciate it.
Thanks for the report. We sure wish we were there with you.
At this point, we are going to keep the coverage going for a while for anybody who wants to keep watching. We'll keep it running for a little bit. Not sure. I'll have to consult with my producer to see how long it can be effectively run. But if you guys want to continue staying in the chat and continue watching the coverage, feel free to do so. But that's the end of the eclipse and the final milestone of the lunar flyby. And I have to admit, it was all kind of slow and predictable until all of a sudden we get these weird reports of meteor flashes and other strange visual phenomena during the eclipse. So in any event, yeah, that's interesting. So, folks, once again, I apologize if we're going to keep broadcasting for those of you who want to keep watching. But I was I started this I don't know how long ago. I started this broadcast 7 hours ago, something like that, over 7 hours ago. So at this point, I'm afraid I'm going to need to go ahead and sign off. But in any event, folks, if you want to keep, I think I'll ask producer to see how long we can keep the coverage rolling for you folks if you want to keep watching for a little bit. But in any event, I want to thank all of you for joining us. Thank you so much. It was so fantastic to have all of you here. And I have to admit, that was quite a strange surprise at the end, an unexpected surprise to say the least, that came up. So looking forward to touching base with you folks again. And of course, I've got more content coming. I'm going to find out everything I can about these mysterious flashes. See just how likely is it? How likely is it that we would have this many meteor impacts in such a short amount of time on the lunar surface that would be visible from thousands of kilometers away? So we'll see what ends up happening. But I think you're right, Mad Professor. I think that the whole idea of seeing these flashes on the moon
the
would
Artemis
be
flight
good
control room.
content to talk about in a
Integrity,
UFO
Houston,
video.
back with you
So, folks,
after
I
a
want to
data
thank
rate
you very
change.
much once again for joining
Regarding
me.
the SAW 3
And
camera
as I
P
say,
low caution,
we're going to
no
keep
action
the
for you.
broadcast running for
It
a
just
little
got
bit
a
for
little
anybody who wants
cool
to keep
during the
watching.
eclipse.
But until next time, stay angry about space.
Okay, we copy, and if you didn't copy my request for the mission summary to add about 20 new superlatives to help my vocabulary, I would appreciate it.
We copied it fantastically.
And Integrity Science, this is basically wrapping up your fly-by-day observations. I can't say enough how much science we've already learned and how much inspiration you've provided to our entire team, the lunar science community, and the entire world with what you were able to bring today. You really brought the moon closer for us today, and we cannot say thank you enough. And Science signing off, and can't wait to talk to you tomorrow morning.
To your entire team, Kelsey, to the entire NASA science team, you all really turned to when we shifted launch dates to April 1st, and you got the most incredible package together for us to go do some great science and some great, truly human experience moments here. And we were well prepared, and we appreciate all of you. And this is what we do best when we all come together and work as a team. So you all knocked it out of the park. Thank you for giving us this opportunity.
Beautiful words, Reed. Thanks so much.
And this is Artemis Mission Control. The lunar flyby observation period is starting to come to a close following that eclipse. And there on your screen you can see a look into the Science Evaluation Room, or the SIR, which is embedded within Mission Control to provide science input. And they provided that input throughout the live flyby operations today. They also have a back room called the Science Mission Operations Room that processes data, evaluates imagery, and supports rapid analysis. And then, of course, we have the Science Officer on console here in the Artemis Flight Control Room, which you can see a view there on the bottom right-hand corner of your screen. The Science Officer throughout the flyby operations today has been Kelsey Young, who is the Artemis Science Flight Operations Lead. And then to her left is Angela Garcia, who will be the Science Officer taking over for Orbit 2. And for the past 7 hours or so, the crew has been going through their lunar flyby observation period. And now they will wrap up that period and complete some final tasks and begin downlinking some of the amazing imagery that they've captured throughout the day, as well as some of the observations that they've recorded. And now on your screen, you're seeing a live look from the Orion spacecraft from those solar array wing cameras. The solar eclipse period ended just a few minutes ago, and during this eclipse, towards the end of the flyby window, it lasted about an hour, and it was when the sun was hidden from view behind the opposite side of the moon from the perspective of the Orion spacecraft and its crew. And during that time, the crew saw a mostly dark moon, and they used the opportunity to analyze the solar corona, which is the sun's outermost atmosphere, while it was visible. And then once the sun was completely out of view behind the moon, the crew looked for impact flashes, which they reported seeing multiple impact flashes, and those are flashes of light from meteoroids striking the surface of the moon. They also looked for dust lofting above the limb or the edge of the moon, along with some deep space targets, including planets, and they noticed Mars off to the distance, and we also saw Venus on one of the solar array wing cameras early on in the eclipse period. The crew also looked at parts of the moon illuminated by Earthshine, which is the sunlight reflected from the Earth when they come around toward the moon's near side at the very end of that flyby window.
Integrity Houston, understand that you are still reflecting upon and consolidating your lunar observations. At your convenience, I have 2 items related to the upcoming VIP event.
Go ahead.
All right, first we wanted to let you know that the message for that upcoming event is on board for review at your convenience. That's message 3.06.04. The second item is that we've seen a couple of video blips in previous events. So during the HDPAO setup activity, we're wondering if Jeremy could please confirm for us that the TS rate is set to 1300 when you get to step 10.
Okay, Jenny. Yeah, we're pretty sure we've been in 1300 for all the PAO events. We've been tracking that when we swap between the HHP and the D5.
We copy, Jeremy. Thanks. And for the record, the phenomenal Jenny has gone on to her next appointment of the day, and you've now got Tess with you.
I'm sorry, Tess. Great to have you on board Integrity.
No worries. Happy to be here.
This is Artemis Mission Control. We heard some communication there between the Capcom or capsule communicator here in Mission Control, which for Orbit 2 is Tess Caswell, and the CSA or Canadian Space Agency astronaut on board the Orion spacecraft, Jeremy Hansen. They were discussing an upcoming public affairs event.
And Integrity, 3-minute warning for the maneuver back to bias tail to sun.
The crew on board the Orion spacecraft recently completed their lunar observation period. It was an approximately 7-hour period of time in which they were focused on several different targets identified by the science team here on the ground that they studied and prepared for ahead of time. And then they also were referencing a lunar targeting package that was uplinked about a day ago with those final targets. Now they are completing some post-lunar flyby activities, so they're working to clean up their observations that they've made and also working to downlink some of the photos that they've taken throughout the day. The science team here on the ground will then work to get as much data as they can overnight, and then there will be a post-flyby conference tomorrow after the crew wakes up. And that's not a debrief, but a science data collection to capture their nuanced experience while they're still in the field and the experience is still fresh. And then, of course, there will also be a public affairs downlink event later in the day. Now that once the post-lunar flyby activities are complete. And then after that, the crew will go into some of their final activities for the day. They will have a private medical conference, or PMC, with the medical teams here on the ground. These are regular conferences that they have at the end of every day, and then there's also a flight director conference that they will have before they go into their pre-sleep period, during which they can complete hygiene activities, and they will have the chance to eat their dinner and complete any other final personal activities for the day before they head into their sleep period.
Hi folks, thanks very much for checking into the stream. Just to let you know, I'm going to wrap the stream up in about 40 minutes time because YouTube like you to keep the streams at about the 12 hours mark. So thanks very much for everybody that checked in, and I suppose stay angry about the lack of camera angles. Catch you in the next one. Cheers. Just a quick correction, it's not ASN, this is Digital Voodoo. I've been running the stream tonight because obviously ASN is still across in America after being over there with the Angry Astronaut for the launch. So I've been covering the stream tonight, and thanks very much for all you guys that support me as well.
And integrity, affirm. We are go to start the stream.
Okay, Houston, the stream has started. We checked the TS rates 1300 and audio is true. So I will give you a voice check now on the mic.
We copy good settings and we've got a good view.
In test, I sent an audio check down on the handheld mic. Did you get it?
Sorry for the delay, Jeremy. We were talking that a bit, but it was a bit broken, so please repeat for us. Integrity Houston, we like the scene. At your convenience, we'll take a 10 count with Jeremy in frame.
Okay, copy that. Give us 2 minutes and or 1 minute and we'll do that.
Copy. Great voice check and good words. We like the scene. And Integrity Houston, we are seeing a black cable going right through the middle of the scene. At your convenience, if you would please move that, PAO would appreciate it.
This is Artemis Mission Control. We're currently 5 days, 3 hours, and 21 minutes into the Artemis 2 mission following a liftoff from NASA's Kennedy Space Center in Florida on Wednesday, April 1st. The crew on board the Orion spacecraft is currently wrapping up their lunar flyby cleanup activities. They're making final...
Houston Integrity, high priority PAO images from the Eclipse are on PCD-1 in a so-named folder.
We copy, Christina. Thanks.
And NASA astronaut Christina Cook there calling down to the ground regarding some public affairs imagery that was captured during the lunar flyby activities. She referenced a PCD, that is in reference to their portable computing devices, which are basically tablets that they're able to transfer files and also follow along on processes and procedures and their timelines for the day. This is Artemis Mission Control in Houston, Texas. Currently on console here in Mission Control is the Orbit 2 team of flight controllers being led by Flight Director Diane Daly and the Capcom or Capsule Communicator, who serves as the single voice link up to the crew, is Tess Caswell. The crew on board the Orion spacecraft recently wrapped up their lunar flyby observation period, and now they are completing some cleanup activities and transferring some data and files down to the ground following that lunar flyby. Many of these files will be analyzed by the science team overnight in advance of a post-lunar flyby conference tomorrow once the crew wakes up. The crew is also preparing for an upcoming public affairs downlink event. And then following that downlink, they will have a few final activities for the day, including a private medical conference with their team here on the ground. These are standard conferences that happen at the end of every day, and they'll also have a private conference with the flight director here in Mission Control to go over the vehicle status and any other questions or concerns they may have for the remainder of their flight. We are currently in flight day 6, and we have a splashdown expected on Friday, April 10th. That splashdown expected in about 3 days, 21 hours, and 49 minutes from now. During the lunar flyby, and as part of Artemis 2, it marked the first time in more than 50 years that humans were able to observe the moon directly and provided a critical opportunity to practice how lunar science will be conducted during future Artemis missions. The moon preserves a near-continuous record of solar system history that has been erased on Earth, and with no atmosphere, weather, or plate tectonics, the lunar surface retains evidence of ancient impacts, volcanism, and solar activity that scientists can study today. Studying the moon helps scientists understand how planets formed and evolved, how the moon influenced Earth's history, and how the early sun shaped conditions across the inner solar system. The moon also serves as a unique platform for studying the broader universe. The science on Artemis is designed around questions best answered by humans working alongside robotic systems, combining decades of robotic lunar data with real-time human judgment, context, and adaptability. Currently on your screen, you're seeing a look at the Artemis real-time orbit website. You can access this website at any time throughout the mission at nasa.gov/trackartemis. It provides updates on the velocity as well as the distance from Earth and the distance from the moon of the Orion spacecraft and its crew. The crew currently on board the Orion spacecraft includes NASA astronaut Reed Wiseman, who is the commander for the mission, NASA astronaut Victor Glover, who is the pilot, alongside the 2 mission specialists, who are Christina Cook and Jeremy Hansen of the Canadian Space Agency. Currently, the Orion spacecraft is about 250,000 miles away from the Earth, and that distance now will continue to close down ahead of that splashdown on April 10th. And they are now about 8,100 miles away from the moon, and that distance will continue to increase as they are now in the return leg of their journey.
Go ahead, Integrity.
Hey, Tess, great to talk to you. Any chance we could drop the fan speed down for this PAO event?
We will put that in work. Great to be talking to you, too.
This is Artemis Mission Control in Houston, Texas. We're currently 5 days, 3 hours, and 37 minutes into the Artemis 2 mission. The crew on board the Orion spacecraft has recently concluded their lunar observation period during the lunar flyby. As part of that lunar flyby, the Orion spacecraft and its crew made the closest approach to the moon at a distance of 4,067 miles away from the surface at approximately 6 p.m. Central Time, 7 p.m. Eastern Time. Now, although the Artemis 2 mission is a new opportunity to study the moon, teams are also conducting other scientific experiments, including on the crew themselves. Here's a little bit more about the science of the mission.
Artemis 2 is our return of humans to the moon.
site, or arrow. The Artemis real-time orbit website there on the left-hand side of your screen provides updates on the velocity of the Orion spacecraft during its journey around the moon. Following a lunar flyby earlier today, which concluded about an hour ago, the crew has been conducting some cleanup tasks, so they've been transferring some of their documentation, their photos, and data that they captured during the flyby to the ground to be evaluated by the science team, and of course some of that imagery will also be evaluated by the public affairs team here at NASA and then shared with the world once it's available. The crew will also have a post-lunar flyby conference with the science team tomorrow following their sleep period to go over some of their observations while it's still fresh and at the top of their mind. On the bottom right-hand corner of your screen, you can see a look into the Artemis Flight Control Room here in Mission Control Houston, specifically the Flight Director Console and the Capcom or Capsule Communicator Console. The flight director currently on console for Orbit 2 is Diane Daly, and throughout the Artemis 2 mission, there are 3 shifts or orbits of flight controllers who provide 24/7 coverage and support to the Artemis 2 crew and the Orion spacecraft and its systems during its journey around the moon. We are expecting a splashdown on Friday, April 10th. That splashdown will take place in about 3 days, 21 hours, and 33 minutes. During the lunar flyby that took place earlier today, Orion, again that spacecraft named Integrity by its crew, passed approximately 4,000 to 6,000 miles from the moon and provided the crew with a full disk view of the lunar surface. And from that higher vantage point, much farther than Apollo's lunar orbits on average, the astronauts were able to observe both poles and large-scale geological features in a single view. And there on your screen, you're currently seeing a live look inside the cabin of the Orion spacecraft.
Integrity Houston, we are 3 minutes out from an on-time start, and we have adjusted the fan speed. We'll take a thumbs up if you're happy with it. Copy, thumbs up. Superlative thumbs up.
And there on your screen, you can see all of the Artemis 2 crew members, CSA astronauts.